Hello, hi, namaskar everyone. My name is Deependra and I welcome you all in this one short video of the chapter 3-dimensional geometry. This chapter is merged with the concepts of vector algebra and questions are framed on these two together. So minimum 2 to 3 questions are asked from these two chapters together. That means minimum 12 marks can be scored by you from these two chapters. What you need to understand is that this is one of those easiest chapters where you need to understand formulae and concepts and need to apply on the questions or illustrations which we'll be discussing in this particular one-shot video to consolidate your conceptual learning along with a lot of short techniques. So yes, through this one shot, you'll get a complete clarity on this chapter 3-dimensional geometry. And of course, with this free of cost one-shot video, we are also providing you the handwritten notes and the DPPs for your practice. The handwritten notes and the DPPs are available to you on our PW app, the link to which is already given in the description. You can click on it and access all of this at absolutely no cost. PW app is an amazing platform from where millions of students are preparing for different competitive exams and getting their desired results. So without further ado, let's get started. First of all, let us get to the part where we'll discuss that what all is asked from this chapter and which particular topic has what kind of importance. So if I could begin with the portion where I'll say that yes, of course, we'll discuss the basics of points in 3D. So this is something which we have started discussing from the chapter vectors, but from 3D's perspective, we'll also look at this particular portion. After that, yes, direction cosines and direction ratios, it plays a crucial role. Questions are asked from this particular topic as well. This is also what we'll discuss in detail. Then there comes this particular part where you need to work upon line in space, plane in space, and line in plane. If I would say that this is the part from where maximum number of questions are asked, then this is the portion from where the second most or highest number of questions are asked. Of course, these are also equally important, or rather I'll say that these are the topics which are used in this and this. So ultimately it is going to be a combination of all the topics. You should study everything in detail because anything can be used anywhere. So a concept learned here can be applied here. A concept learned here could be applied here. So all of these things can be merged. So we won't say that something is more important, something is having lesser importance. Rather, what you need to understand is that everything is equally important. You've got to study everything because they can merge anything from anywhere and then they ask you a question on it. So yes, study everything. Put your focus on everything in a best possible manner. Let's get started with this particular part where I'll say that how do you deal with this particular system. So as we have already discussed in the vector, the same thing I'll try to relate it from 3D's perspective. What do we have here? So we have this plane, or rather we have this 3D space in which I have created this frame with the help of x-axis, y-axis and z-axis. So these three axes are mutually perpendicular, and because of this we are able to create this 3D frame. Now here, if I look at these axes, this is your x-axis, that's your y-axis, and that's your z-axis. What I am trying to do is, I am trying to make you configure a point P in 3D space. So if we have this point P in the 3D space, whose coordinates are given by x, y, and z, how do we do that? I hope you know it very clearly that if this point P is given to us, and if from this point P, I am dropping a perpendicular on the YZ plane. So from this point P, on the YZ plane, we have dropped a perpendicular, which you all can see it very clearly. So this distance Pn will be equal to CL or equal to BM, or it will be equal to AZ. So this distance AZ, which is equal to the perpendicular dropped from this point P on the YZ plane, is going to be the x coordinate. Now it all depends. This distance is getting covered or measured on the positive side of x-axis or on the negative side of x-axis. So if it happens to lie on the positive side of x-axis, this coordinate will be positive. If it goes on the negative side of x-axis, this coordinate will have a negative value. This part I hope makes complete sense. Similarly, when you are asked about the y coordinate, as we have already discussed in vectors, I'll repeat the same part here, that for y coordinate, what I'll do is from this point P, I'll drop a perpendicular on XZ plane. So this is your XZ plane. I hope you can see it here. From this point P, if I have dropped a perpendicular L on the XZ plane, I hope you can see it very clearly. In that case, whether this is PL or CN or AM or OB, They all are going to be of equal length, and this OB will help us in denoting the y coordinate of this point P. I hope there is a complete clarity on it. Again, the point remains same, that if this OB is on the positive side of y-axis, then it will have a positive y coordinate, or if it lies on the negative side of y-axis, then in that case, it will have negative y coordinate. I hope there is no confusion on it. Moving ahead, the next part. Same will be true for the z coordinate as well. Nothing needs to be said about that portion. I hope you are getting it very clearly that from this point P only, if I drop a perpendicular on this xy plane, I hope you can see it very clearly. So this perpendicular PM will be equal in length with AL, NB and CO. And this CO, I hope you are realizing, is nothing but your z coordinate. And same, if it lies on the positive z-axis, the coordinate will be positive. If it lies on the negative z-axis, the coordinate will be negative. The same we have learned in the vectors as well. So if I wish to define this vector OP, I could have defined it as xi cap plus yzk cap, yj cap plus zk cap. What you need to understand here is that OP will be the position vector of this point P. Why? Because x-axis we are taking as I cap, unit vector in the direction of x-axis, a unit vector in the direction of y-axis we are denoting by j cap, and a unit vector in the direction of z-axis we are denoting by k cap. So if that is how you are taking these points, you can take it like that. So I hope you are able to relate vectors with 3D and you are able to create a complete sense out of it. Similarly, there is this octant theory, the way we have quadrants in the two-dimensional geometry. In the same fashion, we have this octant theory, which does not play a much crucial role if you have understood this particular part. So I hope this makes complete sense. Let's get more clarity on this part where I'm trying to make you understand that. Let's say if I take any point on x-axis, how will its coordinate look like? I hope you're realizing if there is a point on x-axis, its x coordinate will be having a certain value because it will be that distance basically. But when you talk about its y and z coordinates, they'll be 0. I hope you're realizing why. In the same manner, if there is a point on the y-axis, its y coordinate will be something significant value, but the other coordinates x and z will be 0. Similarly, a point on the z-axis will have its x and y coordinate to be 0. There is no confusion on that, I believe. Now, when you talk about a point lying on xy plane, yz plane and zx plane, I hope you can see it very clearly. Let's say this is a point M. And this point M lies on the xy plane. Now, can you help me with its coordinate? If I were to ask you the point M, I hope you're realizing if I could find this point M's distance from these three planes respectively, xy, yz and zx. So I hope you're realizing if I'm finding its distance from the zx plane, this will be this, which is going to be its y coordinate. If I'm willing to find its distance from the yz plane, then it will be this, which is going to be a certain value. I hope you're realizing it very clearly. But if I want to find this point's perpendicular distance from the xy plane, so this point is lying on the xy plane. And if this point lies on the xy plane, its distance from the xy plane will be 0. So that's exactly what I'm trying to say here, that if there is a point which lies on the xy plane, then it will have its x and y coordinates, of course, defined very clearly, but its z coordinate will be 0, because if it lies on the xy plane, its z coordinate will be 0 because it has no distance from the xy plane, because it is lying on the xy plane, and hence it won't have any z coordinate. In the same fashion, if a point lies on the yz plane, I hope you are realizing its x coordinate will be 0. And if there is a point which lies on the zx plane, its y coordinate will be 0. I hope you are understanding it logically that why can we say so. So all of these deductions should be learnt and remembered by you. More importantly, they should be logically understood by you all. Now, similarly, let's say if I'm asked to find out the distance of this point P from the origin. So the distance formula remains very simple, or you can find the modulus or the magnitude of this vector. So OP vector's magnitude will be the length of the vector OP, or in a simpler language, distance formula can also be used, which will be given by the distance between the point O and P, or rather the distance of point P from the origin is given by under root over x square plus y square plus z square. The formula is straightforward. The formula is very simple because either you find the magnitude of the vector xi cap plus yj cap plus zk cap, that will also be under root over x square plus y square plus z square, or you could use the distance formula that will also give you the same result. So I hope this particular part is very well understood by you all. Moving ahead towards the next conclusion, as we have already discussed this in vectors as well, along with its proof. So I'll directly give you this result. And I have been constantly mentioning it a lot many times that yes, please understand, most of the formulae, rather almost all the formulae which you will study in 3D are nothing but the extensions of the formulae which you have studied in 2D. So in 2D, the distance formula between x1, y1 and x2, y2 is under root over x2 minus x1 whole square plus y2 minus y1 whole square. So here, if there is third coordinate which is z1 and z2 for these 2 points, then the distance formula between these 2 points, p and q, will be given by this particular expression which says under root over square of x2 minus x1 plus square of y2 minus y1 plus square of z2 minus z1. Simple. I hope two things are very straightforward here. That most of the formulae which you are going to study in this particular chapter 3D will be relatable. Second, they are logically understandable. So nothing new or huge or complicated is here. Something which you already know, something which you have already studied is being discussed. So take care of it that this is one of those chapters which is easy and it can be learned with some efforts, with some simple efforts, and it can be mastered with some amount of good practice of previous year's questions and the DPPs we are providing. Now, along with this, if I could move to the next part where we discussed the section formula, that is also a very straightforward formula. What does it say? So here, if I could explain it in terms of vectors, there are two vectors. So point P and Q are there. So position vector for point P is given by, let's say, vector R1. Position vector for point Q is given by, let's say, vector R2. So these are the 2 points P and Q and their position vectors are given by R1 and R2. Now, I want a third vector R, or the position vector of R, which does this very simple thing that the line segment created by joining these 2 points P and Q is divided by this point R in the ratio m is to n. So can I work out that ratio? I hope working out that ratio is a very simple task. How and why? Because mr2 plus mr1 divided by m plus n will give me the vector R. This is exactly what we have studied in 2D. This is exactly what we have discussed in vectors. So that's exactly what we'll do here. Sir, what or how will you write its 3D formula? So that's again something you need not do, because with the help of vectors you can do. But still, if you need the 3D formula, I'll try and help you with that. For example, P has the coordinates. P is a point which has the coordinates, let's say, x1, y1, and there is third coordinate which is z1. Similarly, Q has the coordinates x2, y2 and z2. Now, can you not help me with the coordinates of R? Students, do you not think that x coordinate of this point R, x coordinate of this point R will be given by mx2 plus nx1? Do you remember that? So this is going to be mx2 plus nx1 divided by m plus n. In the same fashion, can you not find its y and z coordinates? Because for y coordinate, you will write m y2 plus n y1 upon m plus n. The same will be true for the z coordinate. Rather than writing it thrice, do you not think that it is more efficient and effective to write in its vector form? Because that will help you in getting the same result with one step only. But there you need to perform the same task thrice. I hope you're realizing this is more convenient and easy. So yes, we'll try and remember this. And of course, if you don't learn this, this is also there for you. Sir, this is the formula for internal division. What is the formula for external division? I hope you understand it very clearly. Here and here, I'll put the negative sign. So this addition sign will be replaced by negative sign, and that will give you the formula for external division. So everything is relatable. Whatever you have studied in 2D, whatever we have studied in 3D is basically getting revised in this chapter 3D. Although a lot of new things we are going to learn here, but first of all, what you need to understand is that how is vector and 3D related and how do you merge these two chapters? That is what I'm trying to explain here. So yes, for external division, we have already discussed this. Now, there are some corollaries. I hope you must have been able to recall this particular corollary, that if you have a triangle with its vertices x1, y1, z1, x2, y2, z2, and x3, y3, z3, can you find its centroid? we had discussed 4 formulae. Can you recall them? Centroid, orthocenter, incenter, and circumcenter. So if I were to ask you, first of all, the centroid of a triangle created by these 3 points. Of course, it is going to be x1, x2, x3. Their sum divided by 3. Same, sum of y1, y2, y3 divided by 3. Sum of z1, z2, z3 divided by 3. Do you remember this? I hope you must be able to recall all of this which we have already studied or discussed during the chapter vectors. So they are completely related. All you need to do is establish the link, that how should you bridge that, the link between vectors in 3D. So any concept which will look from the perspective of 3D can be done from the vectors perspective as well. We'll try to look at every single concept from both of the perspectives, but of course I'll tell you which method is more efficient. So this is the topic where you should use vectors, this is the topic where you should use 3D. This is what we'll keep discussing, so don't worry about that. If needed, I'll explain, instead of explaining both, I'll explain only that part only, which will be more efficient. So instead of wasting time, we'll learn that method only. So that is also what we'll do. Don't worry about that. But as of now, I hope this corollary is very well understood by you all. There is something more crucial, that let's say there is a tetrahedron. So let's say if we are having a tetrahedron, I hope you must have remembered we had a discussion in vector algebra on a tetrahedron. So let's say if there are 4 points. So first of all, there is a base. So there is a triangular base, right? So there is a triangular base. And there is this 4th point, let's say somewhat like this. Now this 4th point, if I could relate it with these 3 points in 3D, if you are able to imagine this, then this is a tetrahedron. Can you imagine? Are you able to imagine this particular shape? I hope it is making complete sense here. There is no confusion on it. There is no confusion on it. That is what I assume or believe. If you are getting confused, I'll draw it more properly so that a good clarity is established there on this particular front. Just give me a second, students. So I am drawing this particular tetrahedron here. And I hope you are able to imagine this tetrahedron in 3D space. Is it properly visible and understandable? Now, my part here is very simple to make you understand this particular result, that even if a triangle has a centroid, a tetrahedron also has a centroid. Now, instead of discussing its proof, I'll straight away give you the result. So we all know that this is a tetrahedron which has a triangular base, of course. So it has 4 faces. Now, all the four vertices, let's say, are given by the coordinates x1, x2, x3, and x4. Correspondingly, y1, z1, y2, z2, z3, y3, z3, and y4, z4 are also given in their coordinates. Now the point is, if we are given these 4 points, there is a small correction here. If I were to correct it, let me just do that correction: x4, y4, and z4. So these are the 4 points, right? So if the centroid of that is this tetrahedron is needed to be worked upon. So its centroid, which will be there, of course, in the 3D space lying inside the tetrahedron, that coordinate, the coordinate of that centroid is given by sum of their x, y, and z coordinates respectively divided by 4. So x1 plus x2 plus x3 plus x4 by 4. Similarly, let's say if I wish to write the coordinates of the centroid or the position vector of the centroid in using vector algebra, then let's say this is a point A which has the position vector A. This is a vertex B which has the position vector B. This is a vertex C which has the position vector C. And this here is a vertex D which has the position vector D. Now I hope in vector also it is a very simple task for you to write its coordinates, because it's a centroid. Let's say it's centroid which, let's say, is given by let's say O, but O we reserve for origin. So let's say centroid is given by, let's say, I. So its centroid's coordinate I will be giving by the sum of the position vectors of all these 4 vectors divided by 4. So this is how you could write the centroid in one single step rather than doing all this. Did you get that part? So with vectors also you can apply these formulae and get the results. So either 3D or vectors, I hope it makes complete sense that how you relate them. Here I'm using the component form basically, and here I'm using the vectors directly, right? Now, moving ahead, let's have a question and get more clarity on whatever we have discussed so far. So what is it? This is a question asked by JEE Mains in 2024. So the question says something very interesting here, that O be the origin and the position vectors of A and B are given by this and this vector, right? So there are two vectors and their position vectors are also given. Now can you imagine, this is a question which is classified as a question on 3D, but it uses the concept of vectors. Trust me, questions on vectors in 3D cannot be segregated. Most of the times you will get this feeling that the question which I'm using or solving with the help of vector can be done with the help of 3D and vice versa. So there is not a very huge or a very clear distinction between these two. Rather, there cannot be a distinction because they are same. It's just our perspective, our way of looking at the question. So if we want to treat it as a question on 3D, we can. If we want to treat it as a question on vectors, we can. That is totally up to you. What you need to understand is that they are interchangeably used, vectors in 3D as concepts. Look at this particular question. Here, what am I told? That the internal bisector of the angle OAB. So there is an angle OAB or AOB, whatever you wish to call it. So let's say there is this particular, right, there is this vector A and there is this vector B. So these are the two vectors. I hope there is no confusion on it. So this is O, this is A, and this is B, right? So what I'm doing is I am drawing the internal angle bisector of AOB. So if I were to draw the internal angle bisector of AOB, let's say it goes like this. So it goes like this. This is the internal angle bisector of AOB. If I join point A with point B, this is how a triangle will get formed, OAB or AOB, whatever you wish to call it. So what I know so far is that angle AOB here is bisected by this line, and I'm told that this angle bisector meets the vector AB at C. So this point over here is nothing but your point C. Okay, so this is your point C. All right, that's great. So what are we asked? The length of OC. Now, this is totally up to you whether you wish to use vectors or 3D or whatever. Let's say I'm using 3D here, although I can very easily with a lot of ease can use vector as well. So let us use both or either, whatever you wish to adapt here. So vector OA is given by 2i cap plus 2j cap plus of course k cap here. What about vector OB? Vector OB was given by 2i cap plus 4j cap plus 4k cap, right? Now, do you know the angle bisector theorem? This is what you study, right? This is what you have already studied, but if you have forgotten the angle bisector theorem, let me make you revise this so that we can use this angle bisector theorem in this particular question. So the angle bisector theorem says that if there is this angle A, right? So if there is this angle A and this, let's say AD is the angle bisector of this angle A. So if this AD is the angle bisector of this angle A, then the angle bisector theorem, suggests or says that here the ratio of these two sides AB and AC, so the ratio of the length of these two sides AB and AC will be same to the ratio of BD and DC, will be same with the ratio of BD and DC if the AD behaves as the angle bisector here in this particular triangle. That is what you call the angle bisector theorem. Now this is something which I am very clearly mentioning, that this is a formula which we will use in 2D as well, because in two-dimensional geometry also we use this particular theorem, angle bisector theorem, and in 3D also we can use it. Now how do we use it? Please understand here. Can you help me with this length OA? So if I wish to find the length of OA, I need to find its mod. So its mod will be given by 2 square is 4, 2 square is 4, 4 plus 4, 8 plus 1 is 9. So square root of 9 is going to be 3. So the length of OA is 3. Similarly, what is the length of OB? So if I find the modulus of OB, this is going to be 4, 16, 16, 32. 16 plus 16 is 32, 32 plus 4 is 36, square root of 36 is 6. So here what you need to understand is, by using angle bisector theorem, I can very easily conclude that OA is to OB. I repeat here, I write here. So OA is to OB, which we have found to be 3:6, which is 1:2, will be equal to AC is to CB or AC is to BC, whatever you wish to write it as in terms of length. So did you get that part? So this ratio also here is going to be 1:2. So this ratio is going to be 1:2. I repeat, this ratio over here is going to be 1:2. I'm writing it like this. Now, if I have this ratio 1:2 and if I know the position vectors of A and B, the points A and B, can I not find the vector C? We know the internal, section formula. So for internal division, can I not do that? So of course, the formula says that this two goes to this vector, this one goes to this factor divided by 2 plus 1. Do you remember that section formula? So if I use that section formula here, I'll be writing the vector OC as 2 times vector OA. So 2 times vector OA plus 1 times vector OB, section formula, right? So 1 times vector OB divided by 2 plus 1, which is going to be 3. So double of OA I need to do. So here I'm going to write OC. Can I use it here? So this is the part where I'm going to write OC here. I hope you won't get confused. So OC first of all is going to be 1/3 of something. So I'm writing that 1/3 outside. Double of OA. So double of OA is going to be double of this. So 4 I cap plus 2 I cap is going to be 6 I cap plus double of OA 4 J cap plus 4 J cap. So that is going to be 8 J cap. I hope there is no confusion on it. Similarly, 2 K cap plus 4 K cap, that is going to be 6 K cap. If you wish to take 2 common, you can, but this is going to be the vector OC. Now, what are we asked? We were not asked the vector OC, rather we were asked the length of that angle bisector, the length of OC. So all I need to do is take its magnitude. So even first of all, before taking its magnitude, can I take 2 common to simply, simplify my calculation? So if I take 2 common, 2, 2, 2, I hope 2 can be taken common. So OC will be, so vector OC will be, first of all, 2 by 3 times, which vector here, students? 3 I cap, 4 J cap, 3 K cap, right? 3, 4, 3. So 3 I cap plus 4 J cap plus 3 K cap. I hope you know it. Now to find its length, I need to find its magnitude basically. So its magnitude is going to be 2 by 3 will remain as it is. It is a constant basically. And here the square of 3 is 9, square of 4 is 16, square of 3 is 9, and I need to take the square root of it, right? So 16 plus 9 is basically 25. I hope there is no confusion on it. But 25 plus 9 is, I think, 34. So here it will be 2 by 3 times root 34. And I don't think that we can do anything with the root 34 thing, which clearly is given in the option B. The same I could do with 3D as well. What I could have done is I could have taken A as 2, 2, 1. I could have taken B as 2, 4, 4. And then by using the section formula, by using the angle bisector theorem, I could have found the ratio 1:2. And then by using the section formula, I could have found the coordinates of C, which could have been 6 by 3, 8 by 3, 6 by 3. And by using the distance formula between OC, I will find the length of OC, which is exactly what I have done here. So if you are intelligent enough, which you all are at this stage, I'm sure of, you must be able to relate that there are two ways, either vector or 3D, whichever you wish to use. They are actually same. There is not much difference there. It is up to you, whichever method you wish to use. Sometimes vectors will be more efficient. Sometimes 3D will be more efficient. It is totally up to you. You need to decide what is going to be more optimal approach. What is going to help you more in this particular category of questions. With that, let us move further. Let us go ahead. Let us look at the next concept we are going to learn. So yes, this is something which plays a very crucial role. Why? Because students end up wasting a lot of time with this particular formula, with this particular category of questions. Rather, this is a formula which is a technique which will help you in saving a lot of time. How? First of all, understand this is that category of question or a topic or a technique or a formula where if a question is asked, there is a standard method. You can adapt that, you can implement that. And by using that standard method, you may end up wasting a lot of time. Of course, it is fine. You can use it. You are definitely allowed to use it. But why to waste a lot of time when you have this short technique or a method or a formula to get the answer very quickly? Now, what is that? Let's imagine that we are given a plane. So you are given a plane. Now plane's equation is given by ax plus by plus cz plus d. If you don't get this, we will study it when we discuss planes. We are going to cover planes also in this one shot only. So we'll discuss what is it or why is it. So ax plus by plus cz plus d is representing this plane. And imagine that there is a line segment. Imagine that there is a line segment created by joining 2 points, let's say P and Q. So this is a point P, this is a point Q. And let's say the coordinates of point P and Q are given by, this is let's say point P and this is point Q. So point P and Q are joined. And then this line segment is divided by this plane in a certain ratio. I hope you are able to imagine this in 3D. So this is a point R which divides this line segment PQ in a certain ratio. And in the questions, what are we asked? Find the ratio. So what usually students do is that they imagine, sir, let's say the ratio of PR is to RQ is lambda is to 1. Then what they do is, let us find the coordinates of R by using section formula. So 1 into coordinates of P plus lambda into coordinates of Q divided by lambda plus 1 are going to be the coordinates of R. Then what they do next is that R, since lies on the plane, it should satisfy the coordinates of the plane, equation of the plane. So they make the coordinates of R, satisfy the equation of the plane, and by doing the entire calculation, ultimately they find the value of lambda, which is the ratio lambda is to 1, which is the ratio PR is to RQ, which the plane is doing or making the ratio or dividing it the line segment PQ at point R. All this process is not needed to be done. Then what is the process? The process is really simple, students. Here you are given the plane, the equation of the plane. Pass the coordinates of P, x1, y1, z1 into the equation of the plane. You will get a certain value. Let's call it power of the point with respect to the plane. So power of x1, y1, z1 with respect to the plane ax plus by plus cz plus d will be ax1 plus by1 plus cz1 plus d. Similarly, find the power of the point Q, x2, y2, z2 also with respect to the plane. That will be given by ax2 plus by2 plus cz2 plus d. Once you have found this power, take its negative ratio. So this value which we have gotten by x1, y1, z1, another value which we have gotten by putting x2, y2, z2 in the equation of the plane, take its negative ratio. This value here will be nothing but your ratio lambda is to 1. If you are calling it m is to n, then it will be m is to n. I hope you have understood this part. Are you not realizing how simple this will be, how easy and convenient this will be if you could use this particular formula directly instead of wasting a lot of time in the standard approach? Had it been 12th boards, I would have suggested you to go with this approach only, which you are taught in 12th board schools. But since it is IIT JEE and you are directly supposed to write the answer quickly, then why should you not use this particular result? How convenient this would be. I hope you are able to realize it. Along with this, what you also should additionally understand in this particular case is a very important phenomena, that if this calculation is done by you and ultimately in the end, if you find that lambda is to 1 is found to be positive, what does it imply? It will imply that this plane was dividing this point PQ, the line segment PQ, internally. So it was an internal division. But if this value lambda is to 1 is found to be negative, that would mean that it was an external division. Did you get that part? So I hope you're realizing that with this particular formula only, how easily you can get the answers and with how much ease or convenience you can get the results. So such techniques will keep using, don't worry about that. But it will be fruitful only when you remember them, when you apply them. So whenever you are seeing something like this, take a note of it, right? Moving ahead towards the next part here, let us discuss the next concept, the next topic, which is called direction cosines. While discussing vectors, we had a glimpse on it, direction cosines. Of course, here in a more detailed format, we'll discuss direction cosines and direction ratios. There also we needed to discuss it. So we had a discussion on direction cosines in vectors as well. But from 3D's perspective also, we'll see what is it, how is it used, and what role does it play in deciding a lot of things related to these 3D stuff. How? Have a look at that. So first of all, again, the concept remains same. So you have a point P in 3D space, you join it with origin, so OP. Now this line segment OP in 3D you should be able to imagine. So here you should be able to imagine that this line segment OP is making an angle alpha with the positive x-axis or the x-axis this OP is making angle beta with the y-axis, and this OP is making an angle gamma with the z-axis. Are you able to imagine this in 3D? In 2D, it is difficult to plot all this, but you should be able to think like this, that this is your OP in 3D space, this is your x-axis. So the angle between OP and x-axis is alpha. I'm taking cosine of it, so I'm denoting it by cos alpha. Similarly, the angle beta here, which is the angle between OP and y-axis, I'm taking cosine of it, I'm denoting it by cos beta. Similarly, the angle gamma, which is the angle between OP and the z-axis, I'm taking cosine of this angle as well, so cos gamma. So cos alpha, cos beta, cos gamma are called or said to be the direction cosines. Now, as I have been constantly mentioning that 3D can be related with 2D, yes, in 2D you have the concept of slope. You have the concept of inclination of a line. That exactly it is, but in a different sense. You will start realizing it once you get more deeper into the concept of direction cosines. You will be able to generate a lot of sense out of it. Or even if you don't understand the concept of slopes, do you understand that if a point is given in the Cartesian system, I can convert it into polar system? So the relation which you draw with between Cartesian system and polar system, that same relation holds true here with this concept of direction cosines. How? We'll understand it with more clarity, of course, in the upcoming slides here. First of all, this thing I hope remains very clear that cos alpha, cos beta and cos gamma are going to be there. And if I were to find cos alpha, I hope you don't get confused that here in 3D, this will be a right angle triangle. Which triangle? OP and the perpendicular drawn from P on the x-axis. So what will happen here is a very simple phenomena that, let's say, if this is your x-axis, that was your vector P, and this is O. So from P, what I'm doing is, on the x-axis, I'm dropping a perpendicular. So this length over here is the x coordinate of the point P. So if the P point had the coordinates x, y and z, this point here, let's call it M for a while. So this M will have the coordinates x, 0, 0. So I hope you can very clearly see that the length is going to be mod x. So if the angle between the vector OP and the x-axis is alpha, can you help me with cos alpha? I hope you won't hesitate in writing cos alpha as base upon hypotenuse, which is going to be x upon OP. And what is OP here, students? OP is the length of the vector P or OP. So that is given by, let's say, R for a while. So cos alpha with this formula is given by x upon R or x upon OP. Similarly, cos beta will be y upon OP and cos gamma will be z upon OP. So what you need to understand is that this is how, or this is where, or this is what is going to be the concept of direction cosines. So cos alpha, cos beta, cos gamma, where alpha, beta, gamma are the angles made by OP with the x-axis, y-axis and z-axis respectively. These cos alpha, cos beta and cos gamma are called the direction cosines. And here, I hope you all can see it that usually or conventionally or traditionally, we denote cos alpha as L, cos beta as M and cos gamma as N. You should be able to remember this. Along with this, if I square and add them, so if I do this thing, L square plus M square plus N square, then I will get another result which is going to be 1. So this is something you must remember, that if you have cos square alpha plus cos square beta plus cos square gamma or L square plus M square plus N square, then it is always going to be 1. This is something which you should have in your mind. I hope this is a proof which we already have seen in vector algebra as well, but here also I am repeating it. Take care of it, mind it, remember it, and yes, don't forget this, because this is something which is used at a lot of places in questions. Now, moving ahead, let me explain direction ratios here. Now, what is the meaning of direction ratios? Let us have more clarity on that. So now, let's talk about direction ratios. So now we are discussing direction ratios. Now, first of all, please understand, we'll find the value of direction cosines. That is, we'll find the values of direction cosines L, M, N. So let's say I could find the values of L, M, and N, which is going to be cos alpha, cos beta, cos gamma. It will be unique for every single line. And of course, how do you ensure that it is the direction cosines? Because the sum of their squares will result into 1. So cos square alpha plus cos square beta plus cos square gamma will give you 1. Or you may say L square plus M square plus N square will be 1. But let's say I have the values L, M, and N, and if I take their ratios, what I'm trying to make you understand is that there is a vector R. So in 3D, there is a vector R, let's say. So this is a vector R, and the direction cosines of this vector R are given by 1 by root 3, minus 1 by root 3, and 1 by root 3. So these are the values of L, M, N, and respectively. So for vector R, let's say the direction cosines are given by 1 by root 3, minus 1 by root 3, and 1 by root 3. This is what we could find, right? Now, even if you wish to verify whether it is a direction cosine or not, all you need to do is take the sum of their squares. So if you wish to validate whether it is the direction cosines or not, so 1 by root 3 square will be 1 by 3. Square of minus 1 by root 3 will also be 1 by 3. Square of 1 by root 3 will again be 1 by 3. So it is going to be 3 by 3, which is going to be 1. So yes, it was the direction cosines only. Now, if I could find the ratio of these direction cosines, so if I could simply, take the ratios of these direction cosines, how can I take the ratios of these direction cosines? So direction cosines are 1 by root 3, then minus 1 by root 3, then 1 by root 3. Now, if I am willing to find their ratios, can I not multiply all the three sides by root 3? Because in ratios, you can multiply them by any value, any fixed same value. So if I'm multiplying all the ratios by root 3, they'll become 1, minus 1, and then 1. Or let's say if I'm willing to multiply all of them by let's say any value, let's say 7. So it will become 7, minus 7, and 7. So here the ratio of direction cosines, in the most simplest form, it could have been 1 minus 1 or 1. Or even if I wish to divide it by 2, I could have said 1 by 2 minus 1 by 2, 1 by 2. Or if I multiplied by under root 13, it will be under root 13 minus under root 13, under root 13. Or if I have multiplied the ratio by 7, so 7 minus 7 and 7. So that's how I can keep dividing them or multiplying them by the same number, and I'll keep generating a lot of ratios here. So all these different possible infinite values are said to be the direction ratios. But what you need to understand is that for a vector, the set or the pair or the triplet of direction cosines is always unique. So I can have infinite direction ratios depending on whatever value of the multiplying factor I keep taking. So I could have taken 7, I could have taken under root 3, I could have taken 9, I could have taken any number. So with whichever number you keep multiplying these direction cosines, they'll keep giving you different ratios. So those are called the direction ratios. But when it comes to the direction cosines of a vector, they are unique. Why? Because sum of the squares of them will be 1. You won't see that the sum of the square of these numbers will be 1. No, it won't be true. If it is a direction ratio, it won't be true. But if a direction ratio, this is also a direction ratio, right? So if there is a direction ratio which fulfills this property, that sum of the squares of these direction ratios is found to be 1, then instead of calling it direction ratio, I'll be calling it direction cosine more specifically. Although a direction cosine is also a direction ratio, but to be more specific, it is direction cosine. So for a vector, direction cosine will be unique, but it can have infinite direction ratios. Are you understanding this concept and the difference between direction ratio and direction cosines? Are you getting clarity on it? If you have gotten clarity, let us move to the next part where, let's say I'm given two vectors, and more importantly, I am given the direction cosines of these two vectors. So let's say first vector has the direction cosines L1, M1 and N1. So that vector can be written as L1 I cap, M1 J cap and N1 K cap, right? So this will be N1 K cap here. Similarly, the other vector can be written as L2 I cap, M2 J cap and N2 K cap because it has having direction cosines as L2, M2 and N2. As we have discussed, direction cosines are unique for every single vector. And if a vector has a unique direction cosines, then with the help of those direction cosines, you can define that vector uniquely. So to define a vector uniquely, all I need is the direction cosines of this vector. I hope you got this part. If I take their ratios L1, M1, N1 or L2 is to M2 is to N2, then I'll get the direction ratios. But here at this stage, I'm saying or mentioning that if I have their direction cosines. So have we not discussed in the dot product in the vector algebra that if I know two vectors, let's say vector A and vector B, by taking their dot product, I can also find the angle between those two vectors because these two vectors are given in their component forms. So I hope you remember that if I wish to write A dot B, how do I write? By using the concept of vector algebra. This is how it is written: mod of A mod of B times cos theta. And what is cos theta? Cosine of the angle between vector and vector B. So we have already discussed this particular result, that here cos theta or theta is given by cos inverse of A dot B divided by mod A mod B. Now can you not help me with A dot B? So vector A is given, vector B is given. In component form, A dot B will be L1 L2 plus M1 M2 plus N1 N2. Do you remember it? Divided by mod A mod B. What is mod A? Under root over L1 square plus M1 square plus N1 square. What is mod B? Under root over L2 square plus M2 square plus N2 square. So that's how you can very easily find the angle between two vectors. Did you get that part? So if I have two vectors and their direction cosines are given, then this is how I can find it. Now, if this L1, M1, N1 and L2, M2, N2, if they are the direction cosines, then you know something very interesting, that L1, M1, N1 square and L2, M2 and N2 square, I'm really sorry, L1 square plus M1 square plus N1 square and L2 square plus M2 square plus N2 square is going to be 1, because they are the direction cosines. Had they been direction ratios, I could not do anything else. But if they are the direction cosines, their value is going to be 1, which means the angle between two vectors, if their direction cosines are given, will be L1, L2 plus M1, M2 plus N1, N2. Remember this as a formula. Although you should understand this, that this formula is valid and applicable if they are the direction cosines. If L1, M1, N1 and L2, M2, N2 are the direction ratios, in that case, I won't be using this formula. In that case, I'll be using this formula, because in that case, the denominator won't be becoming 1, because L1, M1, M1 and L2, M2, N2 won't be becoming 1, because in that case, they'll be direction ratios. So if they are the direction ratios, use this. If they are the direction cosines, use this. Did you get that part? Did you get complete clarity on this portion, that with the help of direction ratios or direction cosines, you can find the angle between two vectors? And forget all this. If we have two vectors, there is a simple formula to find the angle between two vectors. Either you use the dot or cross. So with the help of dot and cross, where dot is more convenient for us, we can find the angle between two vectors. So if that can be learnt, it is more advantageous for you. But if you have this thing in mind, that how to find the dot in component form, then you can use that formula and find the angle between two vectors. With that, if I could move ahead, let us move ahead towards the next portion, where we'll discuss the condition if two vectors are perpendicular or parallel, right? So if we know the angle between two vectors whose direction cosines are L1, M1, N1, L2, M2, N2, then of course this is also very simple to figure out, that if they are perpendicular, theta will be 90, cos theta will be 0, which means L1, L2, M1, M2 and N1, N2, the sum of this should be 0. So that's your second conclusion, that whenever you have two vectors which are perpendicular, that means this is what is going to be true. And yes, there is one more thing which is true, that if the angle is 0, so if the sine theta is 0, you can convert it into sine theta, or basically if they are parallel, then they will be proportional. This is what we have been discussing. So if these two vectors are parallel, by using vector algebra, there will be proportionality there between I cap, j cap and k cap components, which means L1, L2, M1, M2 and N1, N2, they'll have the same ratio. So by using this proportionality, if they are two parallel vectors, I can say so. So these two conclusions also should be remembered by you, that this is the conclusion which can be applied, or should be or must be applied, whenever two vectors are perpendicular. And if two vectors are parallel, this is what I'll be using here. Now, moving ahead towards the next conclusion, the conclusion or the error where students commit the mistake is, the point which you should remember is that if it is A1, B1, C1, A2, B2, C2, which means instead of direction cosines, you are given direction ratios. So you don't know the direction cosines. Although with the help of direction ratios, you can get the direction cosines. It's not a tough task. But let's say you don't have the direction cosines, you have the direction ratios. With the help of direction ratios, cos theta is given by, I hope you remember, it is not just A1, A2 plus B1, B2 plus C1, C2 now. Because it would be true had A1, B1, C1 and A2, B2, C2 would be the direction cosines. But if they are the direction ratios, you should remember A1, A2 plus B1, B2 plus C1, C2 would be divided by under root over A1 square plus B1 square plus C1 square. times under root over a2 square plus b2 square plus c2 square. And we all remember and know that if they are the direction cosines, the denominator will become 1 in that case. So this is the formula if a1 b1 c1 and a2 b2 c2 are the direction ratios. So by using this, we can find the cosine of the angle between these two vectors. This is what we have already discussed while having a discussion on angle through direction cosines, but you should remember this fact where students commit the error that if you are given the direction ratios, then this will be used. If you are given the direction cosines, then also this can be used, but this will be boiled, this will become more simpler, more easier, more straightforward with this part, the numerator only, because the denominator will become 0 in that case. Sorry, 1 in that case. I hope you are getting this clarity completely. But here also the property holds true that if they are perpendicular, if these two vectors having direction cosines as a1 b1 c1 and a2 b2 c2, if they are perpendicular, then also cos theta will be 0, which means the numerator should be 0. And if the numerator should be 0, the numerator is 0, in that case a1 a2 plus b1 b2 plus c1 c2 will be 0. Similarly, if two vectors are parallel, they will be proportional. a1 a2 b1 b2 and c1 c2 will be proportional. That's exactly what we have been discussing. So a1 upon a2, b1 upon b2 and c1 upon c2 will be same and equal. I hope from the perspective of direction cosines and from the perspective of direction ratios, you have gotten an exhaustive clarity on vectors, that when will they be perpendicular and when should you be concluding that they are parallel. I hope the phenomena is straightforward. It is very simple. Now, moving ahead, let us look at a question and get more clarity on it. And through this question, you will realize that they have merged the concept of 3D geometry with trigonometry. How? Let's have a look at that. Here the question says some very simple things, that each of the angles beta, gamma that a given line makes with the positive y and z axis respectively is half of the angle that the line makes with the positive x-axis. So let's say with positive x-axis, the line makes an angle alpha. But what does it say? It says that beta and gamma are half of alpha. So can I not say that if beta and gamma are half of alpha, then alpha will be double of beta and gamma? So can I say that alpha will be double of beta and it will be double of gamma? I hope you are getting it. What is alpha, beta, gamma? The angle made by this factor with the positive x-axis, y-axis and z-axis respectively. So if I know alpha, beta and gamma, do I have a relation? We know alpha, beta and gamma, which means I know cos alpha, cos beta and cos gamma, which are the direction cosines. Alpha, beta, gamma are not the direction cosines. Cos alpha, cos beta and cos gamma will be the direction cosines. So if cos alpha, cos beta and cos gamma are the direction cosines, I can very easily say that we know a relation that cos square alpha plus cos square beta plus cos square gamma will be 1, because we know L square plus n square is 1. Now what I do next is, what am I asked? Then the sum of all possible values of angle beta. So basically I need to work out the values of beta here. So first of all, one more conclusion which we all are able to draw is that 2 beta is equal to 2 gamma. So if 2 beta is equal to 2 gamma, which means beta and gamma are equal. I hope you're realizing that. So if beta and gamma are equal, I'll make some substitutions here. What? We know alpha is 2 beta. So I'll replace this alpha by 2 beta here. So this will become cos square 2 beta plus. This is beta. But what about gamma? That gamma is also equal to beta. So this will become cos square beta. So cos square beta plus cos square beta. I'll be making it or converting into 2 cos square beta. Of course, this is 1, which I bring on the left hand side becomes minus 1. So from this, I get cos square 2 beta plus 2 cos square beta minus 1. Do we have an identity? I hope you all are able to recall a particular identity which you all must have studied, that cos 2 theta is given by cos square theta minus sin square theta. Second one is 2 cos square theta minus 1. And third one is 1 minus 2 sin square theta. So if I use the second one which says 2 cos square theta minus 1, then can I use this here? 2 cos square beta minus 1. Can this identity not be written as cos 2 beta? So here, this is cos square 2 beta and this here is cos 2 beta. I hope there is no confusion on it, and this is given as 0. If I take cos 2 beta common, so if I am taking cos 2 beta common, so here if I take cos 2 beta common, the factor I'm left with inside is cos 2 beta plus 1. So this will give me cos 2 beta plus 1 is equal to 0. Now these two factors, the product of these two factors is 0, which means either of them or both of them will be 0. What I'm trying to make you understand is again a very simple phenomena, that what is beta? Sir, beta basically was the angle made by this, vector with the positive y-axis. I know as far as direction cosines are considered, these alpha, beta and gamma should always lie between 0 and pi. So from that, I know that 2 beta will also lie between 0 and pi. So if I know that here 2 beta lies between 0 and pi, can I not conclude that the value of beta should lie between 0 and pi by 2? So this is a conclusion I should carry or keep in my mind, that either I take care of this, that beta, the value of beta will be between 0 and pi by 2, or if I am talking about 2 beta, then the value of 2 beta I'll be taking between 0 and pi only. Now let's get back to our conclusion here. Please pay attention to this part. I am told that cos 2 beta into cos 2 beta plus 1 is 0. From here, I can draw two conclusions. First conclusion, cos 2 beta will be 0 or cos 2 beta will be minus 1. Now, if cos 2 beta is 0, we know cos theta. If I talk about cos theta, if you look at the graph of cos theta, if you are not able to visualize this much, have this thing in mind that these are your x-axis and y-axis respectively. And if I were to draw the graph of cos, this is how the graph of cos theta is drawn. So I hope you know this is 0 degree, or you can call it 0 radian. This is your pi by 2 and this is your pi, right? This is how you look at the graph of cos. So if I'm asked that cos of an angle is 0, then of course it is going to be pi by 2. First of all, if I look between 0 and pi only. So can I say that 2 beta will be pi by 2, the first and foremost condition. So if 2 beta is pi by 2, I hope I need not tell you, beta will be pi by 4. And we all know that beta is something we need to restrict between 0 and pi by 2. So I think I have a value of beta which is between 0 and pi by 2. Because if I take 2 beta as the other value, which is going to be 3 pi by 2, then I'll have a greater or a larger value which I'm not supposed to include. Here, let's look at this part. Cos 2 beta is minus 1. So 2 beta happens minus 1 when 2 beta becomes pi. I hope you can see it very clearly. So from here, I'll say that 2 beta will be pi, which will help you in cracking beta, which is going to be pi by 2. So I think these are the two values, because these are the two values which are fulfilling the condition, because if I go further, I'll be crossing this boundary, which I'm not supposed to. So I need to restrict beta into this zone only, 0 to pi by 2. So we have gotten two values of beta, which are pi by 4 and pi by 2. But what were we asked? We were asked sum of all possible values of beta. So what were we asked? Sum of all possible values of beta. I think it's a very simple task for you, because if sum was asked, that sum will be equal to, what is it? It will be pi by 4 plus pi by 2, which I need not tell you what is it going to be. So pi by 2 plus pi by 4 will be 3 pi by 4. Any confusions on that? I hope you're realizing it. 2 pi by 4. 2 pi plus pi is 3 pi. So this should be 3 pi by 4. Right, students? That is what we are given in the option A. Three things we did in this question. First of all, we used the property that L square plus M square plus N square is 1. Second thing, we used the data given to us. Third thing, simple identity, a trigonometric identity was used. And then some basic sense of graph, general solution, specific solution, particular solution we worked upon, and we concluded with the restriction which we were supposed to impose, that direction cosines are supposed to be limited when the angle is considered between 0 and pi only. So that conclusion, if kept in mind, this part was tricky here. So if you don't take care of this particular part, you may end up committing some error. So this is something you should take care of. And if you are taking care of this particular part, you are concluding your answers with a lot of ease and accuracy. And it is all about this only. What you need to understand is, you don't get good marks, or you won't get good marks, if you look at the broader perspective only, if you look at the broader picture only. You start getting great marks, you start scoring really well if you start looking at minutely. If you start noticing those nuances, so if you start paying attention to the details, you will get more accuracy and clarity. And it is all about noticing the things. So more attentive, the more cautious, the more alert you are, the chances are higher that you will be scoring well. You will be scoring great. The criteria is simple. How clearly you understand the problem, how clearly you look at things, how cautiously you take care of things. So if you are taking care of everything, if you are reading all the details, if you are comprehending everything with the complete utmost clarity which is expected to be there in a particular question or from a particular question, then of course you will do it accurately. So it's all about reading between the lines. Now, moving ahead towards the next part here, let's move ahead and let's see what gets unfolded next. So yes, there is another concept which is called projection of the line segment. We have had a discussion in vector algebra. I hope you remember with the dot product, its geometrical application was finding the projection of a vector on a vector. That same concept I'll be using here, but in 3D. How? Let's have a look at that. So let's say we have a vector AB. We have a vector AB and its direction cosines are given by L, M and N. And there is a line segment created by joining 2 points, let's say A and B, or rather P or Q in this case. And this line segment PQ has its extremes as P x1, y1, z1 and Q as x2, y2, z2. Now from PQ, if I'm dropping a projection here, I hope you can see that projection will be this AB only. So I can call this as that AB or this length as that AB. So this is the projection of PQ on this vector AB, vector which contains these 2 points AB, which is having the direction cosines as L, M and N. So the idea is very simple, students. The idea is very straightforward. All you need to understand is this particular result, which says that if you are asked to find out the the projection, it will be given by L times, what is happening over here? I'm really sorry. L times x2 minus x1 plus M times y2 minus y1 plus N times z2 minus z1. How did I get this result? If you go back to the lecture, vector algebra, there we have in a very exhaustive manner discussed how to find the projection. If you don't get it, all I have done is I have taken this vector PQ, I have taken this vector AB, I have taken their dot product and their dot product is divided by the mod of AB. I hope this is exactly what we have discussed when we had a discussion on the projection formula. I'm giving you a very simple conclusion, a very simple result here, that if I am asked to write the projection of PQ on AB, then the projection of PQ on AB is given by this formula only. Do you remember this result, students? Do you remember this result? And what we know is that for AB, L, M and N are the direction cosines. So PQ dot AB, I hope you know, vector PQ will be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. And with this vector, if I take the dot product with L1 I cap, L I cap, M j cap, N k cap, then the dot product will be this only. But what you need to understand here in this case is that the dot product when divided by mod of AB, it will be under root over L square plus M square plus N square. That will become 1. So this, which is the projection of PQ on AB, will be this only. Are you getting this result? Are you understanding this result? I hope there is no confusion on it. Sir, instead of direction cosines, had they given us the direction ratios, what would you do then? I will say the result is there with you. You have the approach with you. Even if you don't remember the result, keep that logical approach with you. That will help you. What I'm trying to make you understand is that, let's say there is this vector, right? There is this vector PQ. And this P and Q have their extremes as x1, y1 and z1. And Q has its own extremes as x2, y2 and z2. I hope this part is very well understood by you all. Now there is another vector AB. Let's say AB. Now for this vector, this is your vector PQ, right? For this vector AB, I'm not given this vector AB, neither its direction cosines, but its direction ratios. So let's say from P, I drop a perpendicular here. So from P, let's say I have dropped a perpendicular here like this. So if from P I have dropped a perpendicular here, from Q I have dropped a perpendicular here, and these 2 points, let's say I'm denoting by A and B. So I am not able to find the vector AB so far, but what I'm given is the direction ratios of AB. So direction ratios of AB is what I'm given, and they are, let's say, small a, small b and small c. I hope you're realizing it. So any vector lying parallel to the vector AB can be written as A I cap plus B j cap plus C k cap, right, students? So I think I have this vector AB or a vector along with the vector AB in the direction of AB. It can have its own magnitude. This time this is not L, M and N because they are not the direction cosines. It is A, B, C which are the direction ratios. So again, to find the projection of PQ on AB, that which is AB basically here in this case. So I repeat my part here. If I am asked to find the projection of PQ on AB, what will I say? I'll say a very simple result. I hope you're realizing what will be PQ. PQ is going to be a vector which is x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. I hope there is no confusion on it. This is how you define your vector PQ. I hope you remember vector P position vector, vector Q position vector. So Q minus P, the position vector of Q minus position vector of P will help me in writing the vector OP, vector PQ. So I have vector PQ, I have vector AB. Can I not find the projection of PQ on AB? I hope you remember the result. It is nothing but what? The dot product of PQ with AB divided by modulus of AB. Do you remember this? This is exactly what we have very rigorously discussed in the vector algebra chapter. Now, if I use this particular result, we know how to find PQ dot AB. We have PQ in the component forms. We have AB in the component forms. So PQ dot AB will be given by, I hope there is no confusion on it. PQ dot AB will be given by x2 minus x1 times A plus y2 minus y1 times B plus z2 minus z1 times C. This is your PQ dot AB, but this time instead of having under root over L square plus M square plus N square in the denominator, which is 1, here I'll have mod AB, which is under root over A square plus B square plus C square. So what I am trying to make you understand is that you need not learn all these formulae time and again. This is not something you're supposed to memorize or cram. What you should understand is this logical approach. And if you have this logical approach in your mind, then you do not bother about a different formula for direction cosines and then a different formula for direction ratios and then which one is to be used where. You need not bother about anything. What you need to understand in that case is that if you are given two vectors and you are asked the projection of one vector on the other, you should know this only. And if you know this, you can apply this and use it accordingly in whichever and whatever category of questions you are given this. I hope you are understanding that distinction which you should be able to make in this category of questions. Moving ahead towards the next set of questions, the next part of questions. Here we have another question, a straightforward question. This one I'll not be solving completely. I'll be just giving you the hint to make you understand that direction ratios, direction cosines don't play any role at all. You will be surprised that this is how easy questions JEE Mains asks. And that's why we have been constantly emphasizing upon that you should be able to categorize those easy and moderate level of questions. Once you have fetched those easy and moderate level of questions, you can solve and get a really good score in your JEE Mains. Easy and moderate is the game which you should play. Don't even look at the harder or the tougher questions. Please understand this. Here, look at this part, how easy this question is. The projection of the line segment. So these two points, I hope you are able to realize, are PQ in a sense with what we have discussed previously in the last slide. On the line joining, so these are your points AB, let's say for a while. So let's say there is this vector AB, Can I find its direction ratios? I hope we can. So direction ratios, how do we find the direction ratios? 3 minus minus 1. I hope you're getting it. So 3 minus minus 1 will be 4. So that is 4 I cap. Then minus 2 minus 2, that is minus 4 j cap. Then 10 minus 3, that is 7. So this is the direction ratio of the vector AB, or even you can call it the vector AB. So that is your vector AB. And on this vector AB, I need to find the projection of vector PQ. So there is this point P, there is this point Q. So can I find the vector PQ? I hope it's again a very simple task. So 2 minus 1 is 1, which is I cap. Minus 4 minus minus 1, which is minus 3 j cap. And here 11 minus 3, which is going to be 8 k cap. So that is going to be the vector PQ. Any confusion so far, students? Did you get complete clarity on it? That how did I find the direction ratios of the vector AB? Or even how could I write the vector AB, right? Now, once you have found the vector PQ and AB, all I need to find is the projection of PQ on AB. So let's say this is the projection of PQ on AB, let's say, which is denoted by CD. So this is what I need to find. So projection of PQ on AB, projection of PQ on AB, which is exactly what we are asked here in this question, the formula remains very simple, students. Do you remember it? It is going to be dot of PQ with AB divided by modulus of AB. This is what I won't solve further. Because you know how to find PQ dot AB. I hope you know 4 into 1, 4, minus 4 into minus 3, minus plus 12, 7 into 8 is 56, divided by mod of AB, which you know how to find. So calculation you all can do, and I'll be hoping and expecting a response in the comment box that once you have done this question, you write your answer in the chat box. Please do that. So I hope it was an easy question asked by JEE Mains in 2020. Did you get that part, that if you know things logically, how easily you'll be able to crack them? So JEE Mains deliberately and intentionally kept certain easy and moderate level of questions, which are always sufficient to get your percentile anywhere close to 95 or even above that. But what students do is that they focus on the tougher or the harder problems. They get into that trap. And that's where they end up wasting a lot of time. So it's simply not just about solving a lot of questions. It is more about selecting the questions, filtering the questions, rejecting the wrong questions. And that's how you put your focus on these category of questions, which will help you in getting that same amount of marks, which you could have fetched with the help of harder questions, which you are not supposed to. Getting my part, everyone, very clearly. Now, moving ahead towards the next part of this particular slide, what are we told? Now, once we have discussed point, once we have discussed direction cosines and direction ratios, let us put our focus on equation of a straight line in 3D space. So in coordinate geometry, we have discussed different forms of a straight line, slope form, point slope form, 2-point form, normal form, and a lot more, symmetric form, and a lot more. But here also you have equation of a straight line. There are going to be two versions in a straightforward manner, vector form and 3D form. The same will keep doing for a plane, sphere and all as well, but don't worry about it. You should be able to understand it logically. That's my concern. So if you are able to understand it intelligently, you need not claim anything. Rather, you should simply be able to understand things and you can apply them as per the requirement of the question. So put your complete focus on understanding. Please understand this. Now, here, two things you need, that if I wish to define a straight line, if I wish to define it uniquely, I need to have this thing, that the line passing through a given point and parallel to a given vector. So this is the case, or. So let's say this is the case where I'm saying that this line's equation is what I need to find, but I know two things about this line. One thing, that this line has a point lying on it. So let's say I'm given some data about this point. Let's say that point is vector A, position vector of that point is vector A. And this line whose equation we are trying to find, this line, what is happening over here? This line whose equation we are trying to find is parallel to a vector B. So let's say this is what we are given. Or if that is not given, then let's say in that case, let's say if I'm given that a particular line is passing through 2 points. So let's say I'm given this point A1, let's say that this line is passing through another point A2. So I hope we can relate. This is a point slope form kind of a structure we'll be dealing with. The way we deal in 2D, let's say I'm given that this line is parallel to this line, which means what? In a different sense, slope is given and the point through which it passes through is given. So y is equals to mx plus c kind of thing we might be doing. And here, if the line is passing through 2 points, so a unique line can be defined in that sense also. So 2-point form of a line can also be created or made or developed. But here it is not 2D. Since it is not 2D, we are in 3D now. So things will change a little. Of course, it will change, but the logic still remains same. So whenever you wish to define a line uniquely, there are two cases. Now, how do we define them? Let's look at them one by one. So this is the first case where I'm trying to say this thing very clearly, that let's say there is this point P lying on this line, and this point P's position vector is given by vector R. And this line AP, which is what we are trying to define, is parallel to the vector B, which is this. So two things are given. First, the point passes through a point P whose position vector is given by vector R, and this line AP whose equation we are trying to find out is parallel to the vector B, which is OF. Now, how do I write the equation of this line? I hope you are able to digest this particular part very clearly and completely, that here I can say that in this case that vector R will be equal to A plus lambda B. Now, why did I say that? What is vector R first of all? please understand, there is one more thing which I missed here. I'm really sorry. Vector R is the variable point. So vector A is that fixed point. I just mistakenly didn't notice this part. So I repeat this particular part here again. Please understand. Let's start from scratch only. Forget everything, whatever I've said so far. So there is this point A. There is this point A which lies on the line, which has its position vector given by vector A. There is this point P, which is a variable point, because this point will keep moving. So in the sense of a locus, I'm trying to define this point P. So this point P is a variable point which will keep moving on this line, which will help me in writing its equation. So this is a point P, which is a variable point which moves on this line, and its position vector is defined by vector R, which is again a variable which is given by x I cap plus y j cap plus z k cap. So whenever vector R is given, I'll replace it by x I cap plus y j cap plus z k cap. And the third thing, we have this thing in mind, is that this line whose equation we are trying to or willing to write is parallel to this vector B. So three things: a fixed point A, a fixed vector B to which it is parallel to. The third thing is a variable point which is moving on this line. So what you need to understand is that, can I not say, if I write vector R minus A, if I write vector R minus A, so this will be a vector. What is it? This is going to be this vector AP. Can I not say that this vector AP will be parallel to this vector? So if this vector is parallel to this vector, I can write that this vector is something scalar times this vector B, because they are parallel. And on the basis of this, I can write that vector R is vector A plus lambda B. This is nothing but the vector form of a straight line if I'm given two things. Which two things, students? Two things means, first thing is that the fixed point through which the line is passing, and the point, the vector to which it is parallel. I hope you got this point. What is R? R is that variable point. The way we have x, y, z in 3D, in vector we have the variable which is treated as R. Did you get this part? Did you understand this whole explanation? And if you have gotten this part, let me move to the next part where I'll give you the second part. But before that, I hope you're realizing that if a line, let's say, is passing through origin. So here there is a small correction here. Let me just do that so that when the notes are received by you, you don't get confused by looking at this. So this is the equation of the line A plus lambda B, which is very clearly understood by you all. The second conclusion is that, let's say, if the line is passing through the origin, then that A can be taken as O, which is 0. So then equation of the line could be R is equal to lambda B, because A has become 0, right? So in that case, if the line is passing through the origin, the equation of the line will look like R is equal to lambda B. Did you get that part? Now, moving ahead towards the next part, where I'll be giving you the 3D form, the Cartesian equation of a straight line in 3D space. In that case, let's say R is the variable point, which will be given by x I cap, y j cap, z k cap. The point A can be given by, this is a fixed point lying on the line. It is given by x1 I cap, y1 j cap, z1 k cap. And there is vector B, to which it is parallel, which is given by a I cap, b j cap, c k cap. So what have we learned? The equation of the straight line in vector form was given by R is equal to A plus lambda B. So if I try and define lambda, what would that be? So it will be R minus A divided by B, that will be lambda. And if I compare the x, y, z components, I'll get a very interesting result here. That here, if I find the value of lambda through this, and this, which are the I cap, j cap and k cap components, I will be defining lambda as x minus x1 upon A, y minus y1 upon B, and z minus z1 upon C. I hope I did not tell you two things very clearly here. First is this particular part here. Which part, students? x1, y1 and z1 are the coordinates of the point through which the line is passing. A, B, C are the direction ratios of the vector which is parallel to the line. So if I were to make you, visualize this thing in 3D space, or if I wish to help you that what does this equation mean, then it means that there is a straight line, and on the straight line there is a point x1, y1 and z1, and this straight line is parallel to a vector whose direction ratios are A, B and C. These are the direction ratios of this vector. So both of them are first of all parallel. I hope you're realizing this particular part. So this line is parallel to this vector, which is having direction ratios ABC. It could be cosines as well. Don't worry about that. And it is passing through x1, y1 and z1. So this line's equation is given by x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. This is something which you need to remember. This is a result which you should have with you. I hope you are getting it very clearly. Moving ahead, what do we have next? Let's see this particular part. Let's say on a line I wish to take a point. In questions we may need it. We will need it at a lot of times. So let's say on this line I need to assume a point. I need to assume a variable point. So that let's say this is that variable point r. So I need to assume this point r whose coordinates in 3D I'm denoting by x, y and z. So can I define x, y, z in terms of this x1, y1, z1 and abc? So from here, what is x? x1 plus lambda a. What is y? y1 plus lambda b. What is z? z1 plus lambda c. So whenever we are given a straight lines equation, I'll put it equal to a certain constant, lambda, mu or whatever is needed to be done. And from here, x can be found as a lambda plus x1. Y can be written as b lambda plus y1 and z can be written as c lambda plus z1. So through this, I can define x, y, z, which are the variable points lying on this line, which are written as, I hope you can see it, x1 plus lambda a, y1 plus lambda b, z1 plus lambda c. And then you'll be given a certain condition. You'll be given a certain condition, which when applied in that question will help you in cracking the value of lambda. And once you get the value of lambda, by putting lambda here, you will have the coordinates of that another point which we are supposed to find or which we are supposed to deal with. Did you get that part? So first of all, put that equation of the line as lambda, and through that you can define any point parametrically in terms of lambda, and then do what is needed to be done as per the requirement of the question. My concern is to make you understand that are you understanding that how am I defining a point on this line? When the equation of the line is given, this is how you can write any arbitrary point lying on the line. Did you get that part? Now, if you have gotten that clarity, which is what here being discussed, let's look at another remark where I'm trying to make you understand that let's say if I am willing to write the equation of x-axis. So we know that x-axis is passing through origin. So what will be the value of x1, y1 and z1? It will be 0, 0, 0. And on the x-axis, if I look at the x-axis, on the x-axis, there is this point 1, 0, 0. So if there is a point 1, 0, 0, which means x-axis is parallel to a vector I cap plus 0 j cap plus 0 k cap. So here, the direction ratios of the vector which is parallel to x-axis will be 1, 0, 0, which means the equation of the x-axis is given by this expression, which when simplified is nothing but y is equal to 0 and z is equal to 0. Don't get confused by this phenomena that sir here you are dividing by 0 and here also you are dividing by 0. No, don't treat it like this. Rather, you should treat it like this, that this is put equal to lambda, and this is how you define x as lambda, y as 0 and z as 0, which means any point on the x-axis will have its y coordinate and z coordinate is 0. So that's how you are defining x-axis. How do you define x-axis in 2D? We say y is equal to 0. So in 3D, if I wish to define x-axis, I'll say y is equal to 0 and z is also 0. So both of these should be 0. If both of the y-axis and y coordinate and z coordinate are 0, then we'll say that this represents the equation of x-axis. In the same fashion, you can define y-axis. In the same manner, you could define the z-axis, which is written there right there in front of you, which I don't think I need to explain. Here comes another part. Let's say the second condition. If I'm given 2 points. So if I'm given 2 points, can I still write the equation of the line? Yes. Because with the 2 points in space, you can define a line uniquely. Let's say I have these 2 points in space. So if I join these 2 points, I will be able to form a line, a straight line. So that's exactly what we are doing here. So here, let's say we are given 2 points. Their position vectors are vector A and vector B. Do you not think that if I do this vector B minus vector A, I'll get a vector which is parallel to the line which we are looking at, which we are trying to find. So B minus A will give me the direction ratios of the vector which is parallel to the line we are trying to form. Second thing, the line passes through either A or B, or actually both basically, but I can write either A or B here. So the equation of the line is given by R is equal to the point through which the line passes plus the direction ratios. I hope you're getting it. So R is equals to A plus lambda B minus A. That is also how you could write the equation of a straight line. I repeat this part here. If you have gotten confused with this conclusion, what is it? There is this line whose equation we are trying to find out. And this line has 2 points lying on it. The first point is vector A and the second point's position vector is given by vector B. So yes, we write the equation of a straight line as R is equals to A plus lambda. Lambda times another vector, which is vector B minus A, and vector B minus A is a vector which is parallel to this line. Rather, it is lying on the line. So it is parallel to the line. So B minus A is the parallel vector. A is the point which lies on the line. So A plus lambda B minus A will give you the equation of the line. Now, how do I write it in the Cartesian form? That is even more interesting. So the Cartesian form is very simple, a straightforward version where I'll say that what is it? See, there you have this line and this line has 2 points lying on it. Which 2 points, students? First point is x1, y1 and z1. And what about the second point? The second point is x2, y2, z2, right? Now, can you help me with this part which we have already learned, that what we do is x minus x1, y minus y1, z minus z1. And in the denominator, what do? We write the direction ratios of a line parallel to it. So the line or the vector which is parallel to it will have the direction ratios as x2 minus x1, y2 minus y1 and z2 minus z1. That's exactly how you write the direction ratios. Do you remember it? We had a discussion on it, that if there are two vectors, 2 points x2, y2, z2, x1, y1, z1, then the line segment created by joining these 2 points will have the direction ratio as x2 minus x1, y2 minus y1 and z2 minus z1. So I know the direction ratios of this line segment which is parallel to the line whose equation we are trying to form. And that's where we write ABC in the denominator. So ABC in the denominator would now become x2 minus x1, y2 minus y1 and z2 minus z1. So in Cartesian form, if I'm asked to write the equation of a straight line, it is given by x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Sir, you have been saying that things can be related in 2D and 3D. Yes. Forget this for a while. You cannot look at this, let's say, for a while. Look at this only. Can you not relate? This is exactly what you may have studied in 2D. 2-point form of a straight line, y2 minus y1 upon x2 minus x1 is equal to y minus y1 upon x minus x1. This is exactly what they have written in a little different format, because now we are dealing with z as well. So what is this ABC? That's the slope if you could relate it. So in 2D, the slope is tan theta, but in 3D, it is cos alpha, cos beta, cos gamma. I hope you are able to relate or make some sense out of it, right? Now, let's get back to the discussion we are having in 3D. Coming back to this part, we have another question, an interesting question, which will help you in understanding what all you need to understand when straight line in 3D comes into picture. So let's read it and then solve it together. This question here will give you complete clarity what I have been trying to mention here in terms of lambda. How do you define a point parametrically on a line? See, we are given a straight line x plus 2 y minus 1 is equal, x plus 2 is equal to y minus 1 is equals to z. We are given another straight line and we are given one more straight line. And what are we told? That with these three straight lines, a triangle can be formed. And can you imagine this in 3D? And then that triangle has an area, then a square is what you're asked. Let me try and make you understand this thing very clearly, that let's say this is a line. What is the line? The line is x plus 2 y minus 1 is equal to z. Let's call it the line L1. Right. This is another line. Let's call it the line L2. Right. And this is the third line we are dealing with. Let's call it the line L3. Now, let me try and help you with this line L1, which is given as x plus 2 is equal to y minus 1 is equal to z. Let's say this is the line. Can I take a random point on this line L1? I'll consider all these values as lambda, let's say. So the value of x, if I put x plus 2 is equal to lambda, what will be the value of x? It will be lambda minus 2. Similarly, what will be the value of y? The y coordinate in a parametric form on this line will be lambda plus 1. And what will be z? I hope you can see z is nothing but lambda. So here, what does it mean? That if I wish to take any point parametrically on this line L1, I can take its coordinates as lambda minus 2, comma lambda plus 1, common lambda. Did you get that part? So this is what I'm trying to make you understand here. So I am writing, or I am going to write these three parametric coordinates lying on these three lines L1, L2 and L3 respectively, which I'm going to use now. So On the line L1, as we have already concluded, on the line L1, if I wish to take a point parametrically, its coordinate are going to be, see, this I'll put equal to lambda. So x will become lambda minus 2. I hope you are able to imagine. Y will become lambda plus 1 and z will become lambda. Did you get that? Now, any point on the line L2 can be assumed as, imagine that this is what I'm putting equal to mu. Let's say and is not written over here. So this I'm putting equal to mu. So what will it give me? X coordinate will be 5 mu plus 3. So on the line L2, any point parametrically can be defined as 5 mu plus 3. I hope you are able to imagine 5 mu plus 3. Then I'll have y coordinates as negative of mu. Then I'll have the z coordinate as mu plus 1. Did you all get that part? So this is how you can define any point parametrically on the line L2. Similarly, can you help me with any point parametrically defined on the line L3? So I hope you have gotten a complete sense and a better clarity how to define it. So lambda mu, let's say here, I take any point, let's say I take gamma, right? So I'm taking gamma here. So here, let's say this equal to this equal to this is equal to gamma. So x will be minus 3 gamma, can you say so? So x will be minus 3 gamma, right? Now, what will be y? Y will be 3 gamma plus 3. Can you make sense out of it? So it should be 3 gamma plus 3. What about z? Z will be gamma plus 2. I hope you're able to get this part. So z will be gamma plus 2. I hope there is no confusion on this front as well. So here I have been able to define the parametrically 3 points lying on the line L1, L2, L3. Now, let me try and help you with this point here, that let's say this is line L1, this is line L2, and this is line L3. So imagine we have this line as the line L1, this line as L2, and this line as L3. Now, if by some means I'm able to crack the coordinates of the intersection of L1 and L2, and similarly the coordinates of the intersection of L2 and L3, and similarly the coordinates of the intersection of L1 and L2, I might be able to find the area of the triangle. How, that we'll discuss later, which exactly we have already discussed in the chapter vector algebra, but forget that for a while. As of now, I am more interested in finding the point of intersections of these, three lines taken two at a time, pairwise basically. So L1 and L3, how do I find the point of intersection? What I'm trying to make you understand is that this is a point which is the point of intersection of L1 and L3. What do I mean by that? It means that this is a point which lies on L1 as well as L3. If I denote these points, let us call it P, let us call it Q, and let us call it R. So P will be a point which will satisfy, let's say I know the coordinates of P. So the coordinates of P will satisfy the equation L1 and L3 both, because P is that common point which lies on L1 and L3 both. So can I not say that if I know the parametric coordinates of L1 and L3, both of them should be equal at P? Are you getting my point very clearly? My point here is very simple, that if there is a point P which lies on L1 and L3 both, which is nothing but the intersection of L1 and L3, so parametrically L1 and L3 should be same at point P. Do you get that point? So I'm putting L1 and L3, the parametric points, to be equal. So the x coordinate will be equal, which will help us in understanding that lambda minus 2 should be equal to minus 3 gamma. So this is a conclusion I have drawn. I can use either this or this. So I'll be using this, the z coordinate. So z coordinate there is lambda, and here it is gamma plus 2. So this value of lambda, which is gamma plus 2, I'm putting here. So this is becoming gamma plus 2 minus 2, which is minus 3 gamma. What is the advantage of having this? The advantage of having this is very simple. 2 gets cancelled by this 2, minus 3 gamma comes here. So it is 4 gamma, which is equal to 0, which implies that gamma is turning out to be 0. If gamma is 0, you can put the value of gamma here, which is 0, and you can find the coordinates of P. Or you can put the gamma of value 0 here, you can get the value of lambda from here, and you can put the value of lambda here. That will also give you the same coordinates, which are the coordinates of P. So by putting the coordinates of L1 and L3, the parametric coordinates equal, I could crack either lambda or gamma, or both rather, and through that I can define the coordinates of P. So here I have the value of gamma, which is 0. So if gamma is 0, minus 3 into 0 is 0, 0 plus 3 is 3, and 0 plus 2 is 2. So it should be 0, 3, 2. That should be the coordinates of P. That should be the coordinates of P. So P will have 0, 3, 2. Did you get this part? How did I find this? Are you able to digest it? That if I put gamma is equal to 0 here, 0, 3 and 2. So that's how we could find P. Are you understanding how are you supposed to use these equations of line and how are you supposed to define a point parametrically on a line? Now, if this part is understood by you all, let me define the other point. I hope you have understood the approach, the algorithm. So if I were to talk about the second point, let's say Q, that is the intersection of L1 and L2. So let's work on L1 and L2 now. So if I have started working on N1 and L2, I think this is what we have. So first of all, if I compare this, lambda plus 1 is equal to minus mu. I'm comparing lambda L1 and L2. So it is giving me lambda plus 1 is equal to minus mu. Getting it, everyone? Similarly, let's compare this, the z coordinate, which is lambda is equal to mu plus 1. So lambda is equal to mu plus 1. So the value of lambda, which is mu plus 1, I'm replacing here. I hope you're getting it very clearly. So if lambda is replaced by mu plus 1 here, it is mu plus 1 is equal to minus mu, right? So minus mu I'm bringing here, 2 I'm taking there. So minus mu comes here, mu plus mu makes it 2 mu, and this becomes minus 2. So mu becomes minus 1. So from here, when you have cracked mu, you could have cracked lambda as well, which is becoming 0 in this case. I hope you are understanding this very clearly. So either use the value of mu as minus 1 and put it here and get the coordinates of the point Q. Or if you don't want to do it like this, an extra step can be done, which you need not. Put mu is equals to minus 1 here, you can crack lambda and put lambda here. Through that also you'll get the same coordinate. I repeat my part. So here, if mu is 1, lambda will be 0. I hope you can very clearly see this part here. So if lambda is 0, this will be minus 2, 1, 0. Minus 2, 1, 0, which is the intersection of L1 and L2, which is what? Minus 2, 1 and 0. So this point Q will be minus 2, 1, 0. Are you getting this part very clearly? Now, are you realizing how should you find the intersection of L2 and L3? So intersection of L2 and L3 is now, I think, a very simple task for you all, because now I need to equate L2 and L3, the parametric coordinates. So which one looks more convenient? I think these two. So I'll choose this equation first. So here I have minus mu is equal to 3 gamma plus 3, and the second result is mu plus 1 is equals to gamma plus 2. So second result is mu plus 1 is equal to gamma plus 2, right? So from here, if I could define mu, then mu will become gamma plus 1. I hope you are comfortably understanding this. 1 is taken to the other side, and this gamma plus 1, if I substitute here, it will become minus gamma minus 1 is equals to 3 gamma plus 3. Any confusion so far, students? Then what I do next is I take minus gamma there, so it becomes basically 4 gamma. I hope you're getting it. Minus 3 comes here on the other side, so it becomes minus 4. So 4 minus 4, that gives you gamma as minus 1. Gamma as minus 1, right? So that is the value of gamma. Here we have been able to evaluate when L2 and L3 were equated. So if I replace gamma by minus 1, I'll have 3. This will become 0, I believe, and this will become 1. So I think 3, 0 and 1, right? So when gamma is replaced by minus 1, 3, 0 and 1. Okay, so 3, 0 and 1 are going to be the coordinates of R. So 3, 0 and 1. Let me just cross check it, because if I am making any error at this stage, that will cost me heavily because the answer will be wrong. So let me just check it. Gamma is minus 1. So 3, 0 and 1. Yes. So I think I have written 3, 0 and 1. A lot of times what you do is you calculate correctly, but you write different. So when you write something else, that's where again you are committing an error, silly mistake basically, but that will again cost you a wrong answer. That will again give you wrong marks, right? So here, these PQR are the point of intersections of L1, L2 and L3, pairwise taken 2 at a time. Now, why did I find PQ and R, the coordinates of PQ and R? Because now by using vector, I hope you are realizing, I used the concept of 3D, now I'll take it to the vectors. Why? Because that is more convenient. So as per our convenience, as per our comfort, we'll choose which is to be used when. So sometimes I'll be using vectors, sometimes I'll be using 3D, sometimes I'll be using both. So here in this case, I started with 3D, now I'll use vectors because I think that is more convenient for me. How? Have a look at that. Here, if I could define, let's say vector PQ. Can you help me with the vector PQ? So if I could ask you that what is vector PQ, who would have said, sir, position vector of Q minus position vector of P. So minus 2 minus 0, that is minus 2. So minus 2 I cap. Then 1 minus 3, that is minus 2 J cap. Then 0 minus 2, that is minus 2 K cap. So I could define the vector PQ. Can you help me in defining the vector PR? So yes, we all can define the vector PR as well. What will be vector PR? I think vector PR will be 3 minus 0, that is 3 I cap. Then 0 minus 3, that is minus 3 J cap. And then 1 minus 2, that will be minus K cap. So 3 minus 3 and minus 1. I hope we are going great. So PQ and PR vector are defined. Do you not agree that in the vector algebra class, we had a discussion that if there is a triangle PQR and I know vectors PQ and PR, I can define its area. So the area of the triangle PQR in vector algebra is given by half of mod of PQ cross QR. Any two vector you can choose on from this triangle and you can take the cross of them. So PQ cross QR. Sorry, PQ cross PR, because in this case we have defined PR and PQ. So PQ cross PR is what I'll take here. And then I'll take its cross, a vector will appear, I'll take its magnitude, basically mod, and then I'll divide it by 2. And that's how I'll have the result. So let's work on the final conclusion now. Now, the final conclusion will be pretty simple here, students, because PQ cross PR. PQ is minus 2, minus 2, minus 2. Okay. So I am now working on finding PQ cross PR first. So let us work on PQ cross PR. So it will be, first of all, I cap, J cap, and K cap. Then what is PQ vector? We know PQ vector is minus 2, minus 2, minus 2. So that will be minus 2, minus 2, minus 2, which I can take common. And then what do we have? PR 3 minus 3 minus 1. 3 minus 3 and minus 1. Yes. So it is 3 minus 3 and minus 1. So what you could have done is you could have taken minus 2 common. That will also work. So if I take minus 2 common from the second row, it will be I cap, J cap, K cap. Then it will be 1, 1, 1. Then it will be 3, minus 3 and minus 1. Let's simply expand it. So what will be the expansion? The product now looks like, sorry, it is minus 2 times. See, for I cap, it is going to be minus 1 plus 3. I hope you are getting it very clearly. So minus 1 plus 3 will be 2. So it should be 2 I cap. Now what about J cap? For J cap, I'll be using a negative sign first. So for J cap, it will be minus 1 minus 3. So minus 1 minus 3 is minus 4. Minus minus plus. So it should be 4 J cap. What should you do for K cap? For K cap, it should be minus 3 minus 3. I hope there is no confusion on it. So minus 3 minus 3 will be minus 6 K cap. So this is your vector. But what I need is I need the magnitude of it. So let's work on finding the magnitude of it. So PQ cross PR's magnitude is what I'm finding here at this stage. So PQ cross PR is what I'm trying to find out here. I hope there is no confusion on it. So here, magnitude, when it comes to magnitude, so magnitude of minus 2 will give me 2 here, that I need not bother about. So the other part should be 2 square is 4. 4 square will give me 16. And 6 square is nothing but what? 6 square is 36. So this is 36 and this needs to be, its square root is needed to be taken. I hope there is no confusion on it. 4, 16 and 36. So 16 plus 4 is 20. So 36 plus 20, I think 36 plus 20 is 56. So this is 2 times square root of 56. That is mod of PQ cross PR, right? But what are we supposed to do? Half of PQ cross PR. So half of PQ cross PR will be root 56. So I think I have figured out the area. The area is root 56. And if I have the area which is root 56, can you not help me with a square? A square will be 56. Easy it was. Simple and straightforward it was. I hope there is no doubt, no query, no confusion on it. Most importantly, the question could have been lengthy, but it was simple. It was doable. So this is that category of questions which are not easy but moderate. Why moderate? They are easy, they are doable, but they take some time, they consume some time, because initially we had to deal with 3 lines. And with pairwise, I had to find that point of intersection. And after finding the point of intersections, I had to use the area formula. area of a triangle. So a lot of calculation was involved in this question. So you were able to do it if you are aware of all the concepts which are being used, but then also it took a lot of time because in terms of calculation, it had a lot of things involved in it. So yes, it was an easy but a lengthy one. You should be able to segregate such questions. So in the first pass of your attempt of the paper, or whenever you're attempting any mock, or even in your real examination hall, your strategy should be attempting the easy and the shorter ones first, which can be done very quickly, and then go for the easy and the lengthy ones, which are the moderate ones. And then the third category of questions, which are hard, which are not understood by you, even if they are easy, you're not able to understand them, leave them. In the first and second pass, focus on easy and moderate only. Let us move to the second concept, or the next concept basically. After this, I hope this question is very well and completely understood by you all. The next thing we have is angle between two lines. This is what we have been constantly discussing, because if you know the concept of finding the angle between two vectors, you know how to find the angle between two lines. Why? Please understand. Let's say I have two straight lines. I have two straight lines which are given by a plus lambda b and a dash plus lambda b dash. Now a and a dash are basically the points lying on the line. But what is b and b dash? Students, are you not realizing b and b dash are the vectors to which these lines are parallel? Did you get my point? So let's say there is this line L1 and there is this line L2. So line L1 is parallel to the vector B here, and line L2 is parallel to the vector B dash here. Are you getting my statement very clearly? So if I am asked to find out the angle between L1 and L2, can I not deal with the vector B? Can I not deal? Let me write it more properly. Just give me a second, students. Here, let me just, this is B, right? So that was vector B here. So this was vector B. So what I'm saying very clearly is that the angle between the lines L1 and L2 will be same as the angle between the vectors B and B dash. Did you get my part? So how do we find the angle between B and B dash? I think that you already know. I need not even explain that. B dot B dash divided by mod B dash. Do you get that? That will give you the cos theta, which is the angle between two vectors, which now happens to be the angle between these two lines, which are parallel to the vectors B and B dash respectively. Did you get that part? I repeat this part very clearly, constantly, and time and again. If you know something logically, just remember that logical approach, because that logical approach will help you in deriving you everything. Of course, if you remember this result directly, that will help you in saving a lot of time in the real examination hall. That you should do. But before that, you should know how is it, coming or appearing logically. Getting my part, everyone? Moving ahead towards the next part. What is it? In the Cartesian form, again, what we know is that something very simple, that here the first line L1 is parallel to A1, B1, C1. That will be the direction ratios of that vector. Second line L2 will be parallel to A2, B2, C2, which means the direction ratios of the second line are A2, B2, C2. So A1, B1, C1 are the direction ratios of the first line. A2, B2, C2 are the direction ratios of the second line. So if I have the direction ratios of both of the lines, can I not find the angle between them? We had a discussion on this formula, which we have been discussing in this particular video and the previous video on vector algebra as well. So we have had a huge discussion on this angle between two vectors. So if two lines are given, you know the direction ratios, and if you know their direction ratios respectively, through their direction ratios, you can find the angle between those two lines. It is not a difficult task for you anymore. That is what I believe. That is what I'm sure of. Now, if this is what you have gotten very clearly, let us move ahead towards the next part. What do you understand by condition for perpendicularity? Again, those two lines had their parallel vectors as B and B dash. Those two lines were parallel to the vectors B and B dash. So if B and B dash are perpendicular, the lines will be perpendicular. And if B and B dash are perpendicular, which means A1, A2, B1, B2 and C1, C2 will be 0. Or B dot B dash will be 0. This is, I think I'm discussing for the 5th or 6th time, because this is the same concept but seen from a different perspective. For a line, how will you crack or develop this idea that these two lines are parallel or perpendicular? Are you getting this? Now, if I have discussed the perpendicularity, can you help me with parallelism? So if two lines are parallel, their direction ratios will be proportional. Or if you are saying that B and B dash, then they'll be same. They'll have some proportionality coefficient, which is lambda or mu or something like that, a scalar quantity. I hope you are getting it very clearly that when will you say that the two lines are perpendicular and when will you be able to claim that these two lines are parallel. The same concept is getting revised sixth or seventh time. But this time we are looking at it from the perspective of straight lines. But still it makes complete sense. If you know the direction ratios of two straight lines, you can find the angle between them. You can check whether they are perpendicular. You can check whether they are parallel because you know the direction ratios of those two lines. Did you get that part? Now, let us move ahead towards this particular concept, which is again an interesting one because here you are now asked, you're given a straight line and you are given a point, and from that point you drop a perpendicular on that straight line. Now you'll be having that deja vu that this is exactly what you may have studied in straight lines in 2D as well, that from a point, if I drop a perpendicular on a straight line, you have a formula to find its feet. Not just that, in a straight line, if I treat that straight line as a mirror, then the mirror image of a point can also be found. There were some formulae. And if there were some formulae, there is a method here in 3D as well. The same method, the same approach, the same algorithm, which we may have used in straight lines to develop the formula, the same algorithm, the same SOP, I'll be suggesting here in the 3D as well. That's why I have been constantly emphasizing that you should have this thing in mind that 3D is an extension of 2D only. All the logics, all the algorithms, all the modus operandi which you have learnt in 2D are in the same manner, in exactly same manner applied in 3D. Just the z-axis, the z coordinate is introduced additionally here. There is no other difference here between 2D and 3D. If you are able to understand these two relations logically, the relationship between 2D and 3D. Are you getting this? Let us work on this, how to find the feet or the foot of the perpendicular from a point on a line. First of all, let's say there is a straight line. So let me draw a straight line to make you understand this more clearly. So there, let's say we have a straight line. Where should I draw it? Let's say this is the straight line. So this is the straight line L1. So this is what I'm denoting by, let's say, L1 over here. So the straight line is given as x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. What does it mean? It means x1 comma y1 comma z1 will be a point lying on it. And what does ABC mean? That means the direction ratios of the line L1 will be given by a comma b comma c. These are the inferences which you can draw by looking at the equation of the line only. Now, one more thing we know for sure, that there is a point P. So there is an external point P which is given by alpha, beta, gamma. Its coordinates are alpha, beta, gamma. And now I am dropping a perpendicular from P on this line. So from P, I have dropped a perpendicular. From P, I have dropped a perpendicular on this line like this, right? So this is the perpendicular we have dropped. Now, let's say the feet of the perpendicular dropped from this point P are L. So this coordinate here is the L. Now, can you help me with the coordinates of L parametrically? Since L is a point, lies on the line L1, its coordinates will be given by, I hope you know, parametrically. So if I put this line, which we have denoted as L1, is equal to, let's say for a while, lambda. So the x coordinate will be a lambda plus x1, y coordinate will be b lambda plus y1, and z coordinate will be c lambda plus z1. So here, the coordinates of L here, I hope you can see them very clearly, can be defined as x1 plus a lambda, y1 plus b lambda, and z1 plus c lambda. Any confusions on that? Now, if I know the coordinates of P, which I'll be given in the question, so I know the coordinates of P and I have cracked the coordinates of L, which is in the parametric form. Why? Because lambda is still unknown to me. Can you help me, since I know the coordinates of P and L both, can you help me with the direction ratios of PL? See, if I wish to write the direction ratios of PL, it will be the coordinates of P minus the coordinates of L. I hope you're getting it. So if from alpha I subtract this, from beta I subtract this, and from gamma if I subtract this, or vice versa. From this if I subtract alpha, from this coordinate if I subtract beta, and from this coordinate of L I subtract gamma, then I will have the direction ratios of PL. So what are they? This is representing you the direction ratios of PL. Now please understand, this is what is giving me the direction ratio of PL, which has the only unknown to me is lambda. So this direction ratio contains three values, three parametric versions in three parametric points or values in lambda, where lambda is still unknown to me. But what now I know is that I know the direction ratios of PL. I know the direction ratios of the line L1. So what is the relationship between PL and L1? What I know is that PL is perpendicular on L1 because from P I have dropped a perpendicular on L1, which is L, the feet is L, and hence PL is perpendicular on L1. What does it mean? It means that if I know the direction ratios of PL, if I know the direction ratios of L1, then do we know that if these two lines are perpendicular, then there can be a relation which can be drawn between their direction ratios. So the direction ratios of PL were this, this, and this. The direction ratios of the line L1 were A, B, C. So if the direction ratios of the L1 were A, B, C, then A times this plus B times this plus C times this should be 0. Do you remember A1, B1, sorry, A1, A2 plus B1, B2 plus C1, C2 will be 0 because A1, B1, C1 are the direction ratios of the first line. A2, B2, C2 are the direction ratios of the second line. So A1, B1, A1, A2 plus B1, B2 plus C1, C2 will be 0. That's exactly what I've done. A1, A2 plus B1, B2 plus C1, C2 is 0. Now here I know everything. A, B, C, X1, Y1, Z1, alpha, everything is alpha, beta, gamma, everything is what we are aware of except for one thing, which is lambda. So lambda is what I don't know. But if I were to solve this linear equation in lambda, will I not get the value of lambda? So by solving this equation, I will get the value of lambda, which you need not remember. Rather, you should have understood the approach which I have been mentioning it very, very clearly. Once you have cracked lambda, which is going to be somewhat like this, it will not look like this. This will be a simple number, -1, 2, 7, something like that. So once you have cracked the value of lambda, put that lambda here, 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 and here, because the coordinates of the point L were given by this, comma, this, comma, this. So here, if I replace that lambda, which we have figured out by this entire process, then I will have the coordinates of L. Now, what is the meaning of coordinates of L? That's exactly what we were looking for, because L is the feet of the perpendicular dropped from P on the line L1. Did you get that part? Did you understand the approach? Did you understand the entire method? Three things I did. First, I defined the coordinates of L parametrically. Second, I found the direction ratios of PL. Third, I know the direction ratios of PL, I know the direction ratios of L1. I took this dot, this dot product, which I put equal to 0, through which I could find lambda. Fourth, replace that lambda here, you'll have L. Did you understand the whole process? Are you getting the entire SOP here very clearly? Now, if you have gotten this part very clearly, let us move ahead and understand the same concept now with an extension, that how do you find the image? I'll take you to this part, that do you know how to find the feet? Now, let's say I don't know how to find the image, but I know how to find the feet. So let's say there is this line AB. Its equation will be given to me. Listen to this part very carefully where I'm mentioning this entire approach. Approach matters here. The logical approach matters here. Here, I'll not be giving you a formula because learning these formulae will be hugely cumbersome. They are amazingly huge. You won't be able to use them. So rather, what I'm suggesting here is that learn these methods, learn these approaches. So up till this part where I need to find the feet, I know the process, I know the algorithm. What is it? I hope you know. You take the parametric coordinates of L, then you find the direction ratios of PL, and then you know the directions of AB, then you take the dot product, and that is 0. So why are you not realizing that there is this point P, which is given as alpha, beta, gamma, the coordinates, and then I need to find its mirror image in the line AB. Then will you not agree that PQ will have its midpoint at L, because PL and LQ will be equal in length, because this point L will be the midpoint, which is equidistant from P and Q both. I hope you're realizing that. So if L is the midpoint, and if I know P, if I know L, will I not crack Q? Why? Because if I have point P, if I have point L, can I not crack Q? Why not, students? I am saying this part very clearly. I know vector P, I know vector Q, and their midpoint is vector L. I repeat, I repeat, I'm really sorry. I know point P, I know point L, but I need to find point Q. But I know what I know is that the midpoint of P and Q is L. So will I not say that the coordinates of the point Q will be given by double of L minus P? I hope you're realizing it. I hope you're realizing it. In the vector world, this is how you can define it. So position vector of the midpoint L is given, which is the feet. The position vector of P is given, which is the point whose mirror image is which we are trying to find out. And Q is what we are trying to find out. What is Q? The mirror image of P. So double of position vector of the midpoint L minus the position vector of point P will give me the point Q. Will it not give me the point Q? I hope you're realizing how will this formula help us or assist us. That's exactly what I'm mentioning here with this particular approach. So I'm constantly repeating the same word. Don't try to claim formula here. Don't try to claim much formula here. Understand the logical approach. Put your focus, put your attention, put your efforts in understanding the approaches and understanding the algorithms. That will help you more in solving questions. I repeat, IIT JEE does not want a brain which is good at learning things or memorizing things or cramming things. They want more logically sound brains. They want more intelligent brains who are good at solving problems. If something is taught to them, they should be able to apply that knowledge in solving something. So that is the mindset which is required from a JEE aspirants. I hope you're getting this part. Now, let us go back to the discussion we were having. Here, let us find the next part, that how can you find the perpendicular distance of a point from a line. Now I'll say, since you already know the coordinates of the feet, how to find the coordinates of the feet dropped from a point on a line, then find the distance between those 2 points. Did you not get my part? My part is pretty simple, students. You need not do this thing time and again. Rather, all I'm trying to make you understand is very simple phenomena here. Let's say there is this line L. Of course, I will give you this formula. You will have these notes. You will have this PDF. Don't worry about it. You can have this formula right there with you. I am not refraining you from having the formula, but my motive is to make you understand that there are so many formulae. They are amazingly, immensely a lot formulae there. You won't be able to remember them. Even if you try to memorize all these formulae, then you may end up getting confused between these formulae. And that's why I am very intensively, very exclusively making you understand the algorithm, that this is what you should apply. For example, that there is a line L. Of course, its equation will be given by x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c, where x1, y1, z1 will be any point lying on the line, and abc, x1, y1, z1 will be a fixed point lying on the line, and a comma b comma c will be the direction ratios of the line. Now, let's say there is another point P. It is also given to me. Let's say alpha, beta, and gamma. So its coordinates are alpha, beta, and gamma. Now let's say, what are we asked? That drop a perpendicular from this point P on this line L and find this perpendicular distance. So basically, the perpendicular distance of a point from a line. That is what you need to evaluate. So how do we do this? I repeat that, do you know how to find M? Have we not discussed the algorithm to find the coordinates of M twice or thrice at least so far before this particular discussion we are having right now? So if by some means I know how to find the coordinates of M, which are the feet of M of this point on this line L, we know the algorithm for this. So if I could crack the coordinates of M by using the distance formula between P and M, will I not have the length of this perpendicular dropped from point P on the line L? Are you getting my point very clearly here, students? So you know how to find M. We have had a discussion on it. And by using the distance formula between P and M, I can have the perpendicular distance of a line from a point. I repeat, don't try to create any formula right here at this stage. Have this algorithm. That's exactly will help you. Even if you try to memorize a formula and apply it in the examination hall, it will consume the same amount of time. So please understand, approaches are more important in 3D. Have a look at this question. It will give you more clarity. This question was asked by JEE Mains in 2025, and let's look at it. What does it ask? Okay, so let's begin with this question here. It says that there are lines L1 and this is of course L2. So this is a line L2 here, right? So this is another line L2, and feet of the perpendiculars from the point this P on these lines L1, L2, B, Q and R. So there is a point P. From this point P, you have dropped two perpendiculars on the lines L1 and L2, and the feet are Q and R. Okay. Then what are they asking? They are again asking you the area of the triangle PQR, and then they are asking you the value of 4a square. Okay. Up till the triangle PQR, I can help you, but after, once we have cracked the coordinates of PQ and R, I won't be helping you. Because please understand, we have previously, right before this question, the previous question we have done, in the same question, the same concept was used. When a triangle was given, its vertices were given, and you were supposed to find its area. We know how to do it. We have done a question in vector algebra as well. We have done a question here as well. And in this same question also, they are asking you the same concept. So to the extent where you need my assistance is simply this, that you need to find the coordinates of Q and R. That is what I'll definitely help you with. But I will not help you with the area of triangle PQR, because this is what you already know. So how to find the coordinates of Q and R? Let us start working on that. I'll begin with the first part. Let's say we have a point P. What is point P? So point P has the coordinates. I'm really sorry. So point P has the coordinates 5, 1 and -3, right? And from P, I have dropped a perpendicular on the line L1, on the line L1, on the line L1, which is given by x minus 1 is equal to y minus 2 is equal to z. Now, if I put it equal to lambda, can I define a point parametrically on this line L1? What would that be, students? So that point will be, see, x coordinate will be lambda plus 1. Can I say? So this will be lambda plus 1. Let's call this feet as m here. So this point I'm denoting by m. Y coordinate will be lambda plus 2. I hope there is no confusion on that. And similarly, z coordinate will be lambda. I hope you all are getting it very clearly. Now, can you help me with the direction ratios of this point P, this line segment PM? So direction ratios of PM are going to be, I hope you know it, lambda plus 1 minus 5, that will be lambda minus 4. Lambda plus 2 minus 1, that will be lambda plus 1. And lambda minus 3, that will be lambda plus 3. Did you all get that? Can you help me with the direction ratios of this line L1? See, x minus 1 upon 1, y minus 2 upon 1 and z upon 1. So the direction ratios of line L1 are 1, 1 and 1. Now, what do we know? Sir, we know that PM and the line L1 are perpendicular, which means this into this plus this into this plus this into this should be 0. Do we know this? So yes, by having this, lambda minus 4 into 1 plus lambda plus 1 into 1 plus lambda plus 3 into 1 should be 0. Do you remember it? Now, lambda, 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 that is 3 lambda. So here lambda, 3 lambda is what I'm having. Minus 4 plus 1 is minus 3. Minus 3 plus 3 is 0. So from here, I could crack the value of lambda, which is 0. And if I know the value of lambda, which is 0, I think I have cracked this point M. Rather than calling this point M, I should have called it point Q, because this is point Q here. So this is not M, this is basically Q. So here also I should have written it as PQ, I think. Yes. So by putting the value of lambda, which is 0, I think I know the coordinates of Q. So coordinates of Q are 1, 2, 0. So I have the coordinates of Q, which are 1, 2 and 0. The same method, the same process, I'll repeat one more time to get the value of R, to get the coordinates of R. So again, I'll be using the same part. So P, whereas P is a point which is given by 5, 1 and minus 3. I hope there is no confusion on it. 5, 1 and minus 3, yes. And then there is this line L2. So we have a line L2. So let's say this is the line L2. And from P, I have dropped a perpendicular on L2. And this feet is called or said to be R. What is the equation of L2? It is x minus 2, y and z minus 2. So x minus 2, y, and the third is z minus 1. So x minus 2, y and z minus 1, right? So I'll put it equal to, let's say, mu. I wish to define R parametrically. How do you define R parametrically, students? So the parametric coordinates of R will be given by, I hope you can see it here. X will be given by mu plus 2. Are you all seeing it happening here? Y will be given by mu only. And what about z? Z will be given by mu plus 1. Do you all agree with this? So z will be given by mu plus 1. Now, we have the coordinates of r, we have the coordinates of p. Can you help me with the direction ratios of PR? I hope you can. Yes, direction ratios of PR are going to be mu plus 2 minus 5. That will be, I think, mu minus 3. I think I'm going great. Yes. Second will be mu minus 1. Okay, so it is going to be mu minus 1. And the third will be mu plus 1 minus 3, which is going to be mu plus 4. Right. Now, again, one thing which is very common, and they may have done it intentionally to make your calculation simpler, that here also it is x minus 2 by 1, y upon 1, z minus 1 upon 1, which means that the direction ratios of the line L2 are said to be 1, 1 and 1. I hope you can see it. So again, I'll use the simple phenomena that here also, that if line PR and L2 are perpendicular, that means 1 into this plus 1 into this plus 1 into this will be 0. So by using that, I can find the value of mu. So it should be mu minus 3 into 1 plus mu minus 1 into 1 plus mu plus 4 into 1 should be 0. So again, I think mu, that is 3 mu. Minus 3 minus 1, 4, it is 0. So here also, coincidentally, mu is found to be 0. Don't conclude that lambda and mu are always 0. Don't generalize like this. Please don't have such assumptions in your brain. This is merely a coincidence which is happening over here. So take care of it, right? So again, if I have the value of mu, can I crack the coordinates of r? So coordinates of r are going to be 2, 0, 1. So coordinates of r are going to be 2, 0 and 1. So I think I have p, q and r all three. What was p? P was 5, 1 and minus 3. That is what I think. 5, 1 and minus 3. What was q? Q was 1, 2, 0. So if this was p, let's say this is q. And q is given by 1, 2, 0. And then there was r. What is r here, students? R we have evaluated as 2, 0, 1. So r is 2, 0, 1. Now, if this is a triangle, can you not find its area? We have done a question right before this question. We have done a question where we had these three coordinates and we were supposed to find the area. I'll just share the approach. So if this is PQR, can you help me with the vectors PQ and PR? You can write the vector PQ and you can write the vector PR. I hope you can write the vector PQ as 1 minus 5, that is minus 4 I cap, 2 minus 1, that is plus j cap, and then 0 minus 3, that is 3 k cap, right? Then what will be the vector PR? PR vector will be 2 minus 5, that is minus 3 I cap, then 0 minus 1, that is minus j cap, and then 1 minus 3, that is 4 k cap. So we have vector PQ and PR. Now if I have cracked the vector PQ and PR, can you not help me with its area, students? So area of the triangle PQR is given by, do we know the formula for it? Yes, half of mod of which cross? PQ cross PR. So any two sides can be chosen and you take the cross of it. So PQ cross PR you will get a vector, you take its magnitude and then divide it by 2, you will get the area of triangle PQR. This is what I'm leaving it up to you, that do it by yourself, the last step. I hope you can do and get the answer. Although you will find the area, which is A. A is not what you are asked. After finding the value of A, square it and multiply it by 4. That will be the answer. So I hope there is no confusion on it. Let us move ahead, let us move further and let us now talk about the shortest distance between two lines. Please understand, in 2D, things were really simple. But in 3D, things will get complicated. How? Let me demonstrate it by this particular example or scenario over here. Now, what you need to understand is that, let's say this is a 3D space. All right, that's a 3D space. Now, what I'm trying to make you understand is, see, there are two lines. Try and imagine that one of the line is passing through your, along the diagonal of your terrace. So imagine you're sitting in a room and you have a roof over you. So that roof will have its diagonal. So let's imagine a line passing through that diagonal. Can you imagine a line? One more line I'm asking you to imagine in 3D. Now that line is, let's say, going along a wall, and that wall is this one. So along the diagonal of this wall, and that diagonal is this one. Of course, this is what I'm representing in 2D, so it may be a little difficult for you to imagine, but please try and imagine. Two lines I'm trying to make you imagine. First one is this, which is on the terrace, which is on the roof along the diagonal, and this is on the wall, which has no connection here. So I am trying to make you understand that these two lines in 2D space may look like intersecting, but in reality, in 3D, they won't intersect at all. For a 2D space, what we know is that lines are either intersecting or parallel. So they will either intersect somewhere or they could be parallel, which means the distance between two lines will remain same if they are parallel. Or they may intersect, and that's how the distance will become 0. But in 3D, what you need to understand is one more case arises. See, the lines could be either intersecting in 3D space. The lines could be parallel, which means the distance between both of the lines will remain same. And the third case, what if the lines neither intersect nor they are parallel? Are you getting my point? That's exactly is the case here happening with these two lines. I hope you can see this very clearly, that if you are able to imagine this in 3D, these are the two lines. These are the two lines. One is going along with the terrace and another one is going along with the wall. And if you could imagine that they won't intersect at all, they won't intersect at all. If you look at my hands, this hand is going in this direction, this hand is going in the direction. So these are the two straight lines, and no matter how much I extend them, they won't intersect at all in 3D space. So they are neither intersecting nor parallel. Still, there is third more category which is getting introduced, and that category is called the set of skew lines. So first of all, are you able to understand when I say skew lines? Did you get this terminology? So skew lines means they are neither intersecting nor parallel, still they exist because it's a 3D space now. And because of this 3D space, can we find the distance between two skew lines? So always remember, whenever you are asked to find the shortest distance between two curves, mind you everyone, what I'm saying is that let's say there are two curves and you need to find the shortest distance between two curves. So let's say this is one of the curves and this is the other curve, right? So the shortest distance between two curves is always found along with the line which is the common normal to both of the curves. So if this line over here behaves as a normal to this curve as well as a normal to this curve, imagine that if this line is the dotted line I have represented or drawn over here, if this line is a line which is behaving as a normal to this and this curve both, then this particular distance will be said to be the shortest distance between two curves. This is something you need to remember because this is something we'll use in application of derivatives as well. So whenever you are asked the shortest distance between two curves, it is always found along the line which is a common normal to both of the curves. Why am I using this concept here and why am I mentioning this concept here? Please try and understand this particular concept, this particular law is equally applicable in 3D as well. So the point is very simple. If you are given two straight lines, let's say if you are given two straight lines and they are skew lines, which means they are neither intersecting nor parallel, which means there could be a line which will be the line of shortest distance between them. So that shortest distance, there will be a point, 2 points on these two lines, which when connected will be normal or perpendicular to both of the lines. Here, from this particular session, in 2D space, it will be difficult for me to make you understand that, but try and imagine that you have two skew lines in 3D space. So here, these are the two lines, they are in 3D space. They are not intersecting. I hope you are not mistakenly taking them as intersecting lines. They are two skew lines in 3D space. So this is a pair of skew lines. First of all, this is what you need to understand. Now, if these are the two skew lines in 3D space, I can find a third line segment which will behave as perpendicular to both of these lines. So in a 3D space, I would be able to find a line segment which will be perpendicular to both of these lines. Of course, it is really difficult for me to make you understand this in 3D, but there will exist a line segment which will be perpendicular to both of the lines. And this line segment, let's call it PQ for a while, this line segment will be said or called to be the shortest distance between two skew lines. Did you get this part first of all? Of course, I'll tell you the algorithm, I'll tell you the formula to find the shortest distance between two skew lines. But more importantly, are you getting how do you define the shortest distance between two skew lines? Did you understand this particular phenomena, this concept here very clearly? I hope there is no confusion on it at all. Now, if I start working on this formula, the formula is very simple. The formula is a very straightforward version of it. How do you find the shortest distance between two skew lines? Let me just come to it directly here. With this, let me focus on this particular part. Let's say first line is this one. This is your first line. And there you have another second line, which is also a skew line here. So that's your second line. So these are two skew lines, right? Skew means in 3D space, they won't be intersecting. And as we all can see, they are not parallel at all. Now, let's say there is a third line, which in 3D space is perpendicular to both of the lines. So this is that third line, which is perpendicular to both of the lines. I hope you are able to imagine this. Now, it is very difficult for me to draw all of this in 2D space. So first of all, let us understand that there is a third line. There is a third line which is perpendicular to both of the lines. Let's say this is that line. In 3D space, in 2D space, it may not look like a perpendicular line, but in 3D space, it is actually perpendicular to this line as well as this line. This is what you need to assume or imagine. This much liberty you need to give me if you want to understand this particular part or if you want me to explain this particular part. So these two lines have this common line which is perpendicular to both of the lines. And this I will be defining as a shortest distance. Now, let's say this line has its own equation, which I'm giving by r is equal to, let's say, whatever formula they are giving you, let's apply that only. So a1 plus, let's say, lambda b1. This is how they are defining this line. Similarly, there is another line r is equal to, let's say, a2 plus, let's say, mu b2. That's the next line we are dealing with. Now, by looking at their equations, what can I conclude? I can conclude two things for sure, that there will be a point on this line 1, which will be a1. There will be a fixed point on this line, L2 you may call, which can be said a fixed point, which is, let's say, a2. So now if I join a1 with a2, I will get a line segment, or I may call it a vector. So if I wish to define this vector, which has extremes as a2 and a1, extremes at a2 and a1. So this position vector, this point's position vector is given by a2, this point's position vector is given by a1. So let me call it for a while. Let's say vector AB. So this over here is point A. I'm choosing the points as they have given in the derivation as well. So this is your AB. Now, this AB is basically a line segment. We'll use it later. Now let's work on this factor, the dotted line segment. What I know is that in 3D space, this dotted line segment is perpendicular to this as well as this. What I know is that this line is parallel to a vector which is given by V1 vector. This particular line is parallel to a vector which is given by B2 vector. Now please try and understand, if there is a third line which is perpendicular to B1 and B2 both. Now let me come to the discussion we had in vectors. Let's say this is a plane, and in this plane two vectors lie, vector b1 and vector b2. So there is third vector which I'm looking for, which is perpendicular to both b1 and b2, So do we not know that it will be in the direction of b1 cross b2? And if I want the direction only, I'll take the unit vector. So that unit vector will be, I need to divide this vector by its magnitude. So this is that n cap. Which is perpendicular to the plane in which b1 and b2 lie. Now it could be either upward or downward. So I can take either plus or minus. Upward for, let's say I say plus, and for downward I can say that it is minus, or vice versa, depending on the right hand system, which I'm not getting into. I am now trying to tell you that if I want to take a unit vector in the direction of this dotted vector, that will be b1 cross b2 upon modulus of b1 cross b2. That will be my n cap. Did you get that part? So do you not think that if I take the projection of AB on, let's say there is a unit vector here, on this dotted line, which is n cap. So if I take the projection of AP on this n cap vector, I'll get this distance, which I'm denoting by PQ, let's say. Yes. So projection of AB on this n cap, which is given in the direction of this vector PQ, will give me the length PQ. Did you get that part? So what is PQ? The shortest distance between two lines. What is that? The projection of AB on n cap. What is n cap? B1 cross B2 upon B1 B2, with the modulus of cross of B1 B2. So here, by this formula, you can get the shortest distance between two skew lines. The formula says you need to take this vector, which is AB, dot projection on this vector, which is PQ, and PQ is given by this vector. So this vector dot this, and of course its unit vector is needed to be taken, so I'm dividing it by its modulus of its cross. So if the formula and its derivation is understood by you all, my conclusion remains same. This is the vector, right? I need its distance. Distance is a scalar quantity. So I take mod of it, and when you finally take mod of it, this formula here gives you the shortest distance between two lines or two skew lines. What is it? If I were to simply give you the conclusion here, let's say these are the two skew lines, and this is the shortest distance between them. This vector PQ represents the shortest distance between them. So this shortest distance, let's say PQ, is given by, of course, on this line, there is a point A1, and this line is parallel to a vector B1. On this line, there is a fixed point A2, and this line is passing parallel to a vector B2. So if you know these four things about two lines, then the distance, the shortest distance between these two skew lines is given by, please pay attention, A2 minus A1 dot B1 cross B2 upon mod of B1 cross B2. And it's mod. It could be either negative or positive. It will be positive, of course, but A2 minus A1 could do something. But here, even if you're taking the dot, it will be scalar. So I need to take mod of it because it is a distance quantity, scalar quantity. One more thing here. B1 cross B2 dot this. I hope you know STP, scalar triple product. Cross of 2 dot with the third vector, it will give you the scalar triple product. So can I write the numerator as box of B1, B2, A2 minus A1. So this formula is still written, can also be written as B1, B2, A2 minus A1, the box of this, divided by mod of B1 cross B2. So that is the formula through which you find the shortest distance between two skew lines. If this vector formula is understood, can we learn the Cartesian formula as well? How to define the Cartesian formula? Let me now finally conclude the Cartesian formula, then I'll come back to this part, or rather let us discuss this part. Let's say if the lines are intersecting. So if two lines are intersecting, that means they are not skew, they are intersecting. That means the distance between them should be 0. If the distance between them is 0, then the numerator should be 0. The numerator is 0 means B1, B2, A2 minus A1. The box of these three should be 0. The scalar triple product of B1, B2 and A2 minus A1, these three vectors should be 0. So did you get this part? The condition if the lines are intersecting, always remember this. Rather, here I will emphasize that you learn this formula. You cannot skip this. This is something you got to learn. Which? The formula. What formula? The shortest distance between two skew lines. You need to have that formula with you. Now, once you learn that, this is also what you can conclude. Because if the distance between two lines is 0, which means they are intersecting. And if they are intersecting, the distance is 0, which means the numerator of this formula will be 0. So I hope you are getting it very clearly. The STP of B1, B2 and A2 minus A1 will be 0. Next conclusion, I am trying to make you understand the way we have understood the shortest distance formula in vector form. In the same manner, can we develop the distance formula in the Cartesian form. What is it? We know in the numerator what I need is a2 minus a1. What will be a2 minus a1? Sir, a2 is x2, y2, z2. a1 is x1, y1, z1. So how do you find STP? In the first row, you write a2 minus a1, which is x2 minus x1, y2 minus y1, z2 minus z1. Did you get that? Now, in the second row, I need to write the vector b1. So what is vector b1? It is a1, b1, c1. In the third row, I need to write the vector b2, which is a2, b2, c2. So this is how I am finding the box of a2 minus a1, b1, b2. So I hope the numerator is completely understandable. Now let's talk about the denominator. Don't learn this particular part. Rather, I'll say, do you know how to find the cross of two vectors? I hope you know. So here we all know that these two vectors, which two vectors, students? Vector b1 and vector b2 are basically the parallel vectors to the lines L1 and L2. So vector b1 is basically given by a1 I cap plus, let's say, b1 j cap plus c1 k cap, and vector b2 is given by a2 I cap plus b2 j cap plus c2 k cap. Don't get confused with this b1 and b2. They are different, right? Now, if I have b1 and b2, can I find b1 cross b2? I hope you know the determinant method to find the cross product of two vectors in component forms. And by having that, you can find the magnitude of it, because b1 cross b2 will be a vector, and then you can find its magnitude. And once you have found its magnitude, it will be this only, but this is not what you need to remember. This is basically the expansion of that determinant and then its magnitude. So this is what you need not remember, rather learn this only, and then from this you can derive the Cartesian formula if needed. So I repeat, the only thing which you need to remember is that whenever two lines are given, the shortest distance between those two lines are given by this formula. Even at this stage, if you are not able to remember or memorize or understand the shortest distance formula between two skew lines, claim it, learn it, by heart it. This formula is going to be the savior you need. Have it with you. It will help you in solving a lot of questions. How? Let us look at that by proceeding further towards the next part. What is the next part here, students? Condition for lines to be intersecting, as we have already discussed, the numerator should be 0, which means box of b1, b2 and a2 minus a1 should be 0. And this is exactly nothing but what that box. The first line contains a2 minus a1, second line contains b1, and the third row contains b2. That's exactly what we are doing. So in vector form, we know box should be 0. In Cartesian form, this determinant should be 0 if the lines are intersecting. There is one more concept which you should have with you, which is, let's say, instead of these skew lines, if the lines are parallel, can we find the distance between parallel lines? Yes, of course. That distance will remain constant and same this time because the lines are parallel. So what you need to understand first of all in this particular case is that if the lines are parallel, there this b will remain same. Because first line will pass through a fixed point a1, second line will pass through another fixed point a2, but they will have this b and b same because they are parallel. So the vector to which they are parallel will be same. So the equation of the first line will be a1 plus lambda b, and the equation of the second line will be a2 plus mu b. Are you realizing why am I having this b and this b same, but a1 and a2 are different? Because they are passing through two different points, because they are two different lines but parallel. Now, I need to find the shortest distance between them. I'm not discussing this entire derivation. Rather, I'm giving you the formula, which is somewhat similar to what we have already discussed. Here, the shortest distance between two parallel lines, here at this stage, the shortest distance between two parallel lines, which are passing through A1 and A2 and which are parallel to vector B, is given by modulus of cross of A2 minus A1 B, A2 minus A1 and B divided by mod of B. I hope you must have remembered. For skew lines, what was the formula? STP of A2 minus A1 dot B1 cross B2. I hope you must have remembered. But here there is no B1 or B2. In that case, here I'm having only B. I'm having this B only. Which means in the numerator, for two parallel lines, the distance, this time there is no shortest distance because the distance will remain constant and the same. Hence, the distance is given by A2 minus A1 cross B divided by mod B. Remember it. This is again another formula which I'm strongly advising and urging you to have with you. Please memorize these two. Two formulae I have strongly advised and discussed that you should have them at your fingertips. First one, the shortest distance between two skew lines. What was it? A2 minus A1 dot B1 cross B2. STP of these two, these three, box of these three, divided by mod of B1 cross B2. And if the lines are parallel, it will be A2 minus A1 cross B by mod B. I hope you'll remember it. In the numerator also, you'll get a vector. You need to take magnitude of it because it's a distance. Right. Now, moving ahead towards the next part, let's get a complete clarity on whatever we have discussed so far by having this particular question. This question is a question on 3D, which uses the concepts of 3D. And subtly, they have brought a question on 2D as well. So they have merged the concepts of 2D and 3D together and asked you a question. And have a look at this, how interesting this question is if you know the basics. So let's start working on this question. First of all, let's read it. So what are we told? That the values of lambda for which the shortest distance between this line and this line. So now we know the formula, right? We have the formula. I think we can work on finding the shortest distance. And once we have found the shortest distance, I think I could deal with this lambda, which is an unknown to us, right? So this is exactly what we need to deal with the help of the shortest distance formula. Along with this, you need to understand that the shortest distance is already given. And of course, if lambda has two values, lambda 1 and lambda 2, I can very easily predict that lambda will either be a quadratic or with a plus minus sign, I'll get two values of lambda 1 and lambda 2, right? So we are asked something else. We'll discuss this something else later, but as of now, let us work on finding the shortest distance. I hope there is no confusion on it that how do we find the shortest distance. You have understood this particular formula right here very clearly. Either you use this Cartesian format or you use this vector format. I hope there is no confusion on it that what is A2 and A1. So A2 and A1 are the direction ratios of those two lines. Sorry, A2 and A1 are the fixed points through which the lines are passing. And what are B1 and B2? B1 and B2 are the direction ratios of the lines or the lines which are they parallel to. Now, let's get back to this particular question over here. So the question has this thing here that if I pay attention to this part, x minus 1, y minus 2, z minus 3. So the first line passes through a fixed point 1, 2 and 3. I hope I did not tell you that will be your vector A1. So if I'm asking you about vector A1, what would that be? That vector will be I cap plus 2j cap plus 3k cap. I hope there is no confusion on it. Can you help me with the vector A2 as well? Now, I hope it's not a tough task for you to find the vector A2. It is lambda 4 and 5. So it should be lambda I cap plus 4j cap plus 5k cap. Did you all get that part very clearly, students? I hope there is no confusion on it. Now, moving ahead. Do I know something about vector B1? Yes, it is going to be 2, 3, 4. Do you get that? So if I were to figure out vector B1, it would have been 2i cap plus 3j cap plus 4k cap. Similarly, if I wish to work upon vector B2, so vector B2 would be 3i cap, 4j cap, 5k cap. So it should be 3i cap, 4j cap plus 5k cap. Now, I hope you're realizing if I have found all the values, it's simply a matter of putting these values into the formula and getting the right answer. That's all you need to do. So what is the formula? The shortest distance between two skew lines is given by, I hope you know, box of A2 minus A1. So there is this vector A2 minus A1 and B1 and B2. So box of these three vectors is needed to be taken, and this should be divided by modulus of magnitude of B1 cross B2. Do you remember it? So these three things we need to find out. So I'll find these three things, rather these two things separately. I'll find the numerator first, then I'll work upon the denominator, and then I'll divide the numerator by denominator. But what you should know or remember is that they have already given you that this shortest distance is nothing but what? It is 1 by root 6. So I need to find the numerator. Then I'll find the denominator. I'll divide numerator by denominator, and then I'll put it equal to 1 by root 6. That is going to be the method to work upon the values of lambda, right? Then we'll do or see further the next part of the question, which we'll discuss later. But here, let's begin with this part. So A2 minus A1, can you help me with this? I hope I can directly find the numerator. So if I have started working on the numerator, right? Let me write numerator here. So I have started working on the numerator. Numerator is box. We know how to find the box. We have studied it in the chapter vector algebra. So box is given by determinant because it is going to be a scalar quantity. Scalar triple product it is. I hope you know it. So A2 minus A1 will be lambda minus 1, 4 minus 2 is 2, 5 minus 3 is 2. So lambda minus 1, 2, 2. Okay, so first row will have lambda minus 1, 2 and 2. Any confusions on that? Now, let's talk about the second and the third row. So B1 and B2. What is vector B1? 2, 3, 4. So second row should be 2, 3, 4. Can you help me with the third row? That is vector B2, 3, 4, 5. So this is going to be the vector B2, 3, 4, 5. Now, we have the methods. We know Sarah's rule, or if you want to expand it simply with respect to or along with any row or column, you can do that. So let us expand it along with first row, let's say. So if I'm expanding it along with first row, it should be lambda minus 1 times 3 into 5, 15, 4 into 4, 16. So 15 minus 16 is going to be minus 1, right? Minus. Then I'll have the second term, which is 2. So 2 times I'll have 5 into 2, 10. 3 into 4, 12. So 10 minus 12 is going to be minus 2. So this should be minus 2 into minus 2. That should be 4. Then I'll have plus 2. This third element I'll take multiplied by this. 2 into 4, 8. 3 into 3, 9. So 8 minus 9 is going to be again minus 1. I hope there is no confusion on it. Now, when you simplify this further, what you get is lambda minus 1 multiplied with minus 1 gives you 1 minus lambda. This is here 4 and that's here minus 2. I hope there is no confusion on it. So 4 minus 2 is 2. 2 plus 1 is 3. So this turns out as 3 minus lambda. That's the numerator. I hope there is no confusion on it. Of course, when you deal with the shortest distance formula, this could be either positive or negative. So to ensure that this distance stays positive, I put a mod over it, right? So yes, that is what we need to take care of. So this is going to be the numerator, right? Now, let's talk about the denominator part. So how do you deal with the denominator? Let us find B1 cross B2 first, then I'll take its mod. So if I'm working on B1 cross B2, we know the determinant formula I cap, J cap, K cap. Then vector B1 and B2 were these two only. I hope you remember 2, 3, 4, 3, 4, 5. So I'll write 2, 3, 4 like this and then 3, 4, 5 like this. And of course, I need to take a mod of it, which also I'm putting here. So again, the process remains pretty simple. Magnitude of the vector I cap, I hope you can see it, 15 minus 16. It is minus 1. So it should be minus I cap, what we have already figured out. I hope you remember. Similarly for J, it should be 10 minus 12, which is minus 2, but it is already minus J. So minus 2 into minus J should be plus 2 J cap, which we have already figured out. Then you have this K cap. For K cap, it should be 4 into 2, 8, 3 into 3, 9. 8 minus 9 is minus 1, so it should be minus K cap, right? And if I were to take its magnitude, it is going to be 1, 4, 1. I hope there is no confusion on it. I repeat, minus 1 square is 1, 2 square is 4, minus 1 square is 1. So 1, 4, 1, that is going to be 6. So it is going to be under root 6. So we have the magnitude here as well. So if I could compare numerator upon denominator, which is 3 minus lambda upon root 6. This is going to be the shortest distance along with the mod. But what they are giving us, the shortest distance as 1 by root 6. Now, if I simply cancel this root 6 by root 6, what I'm left with is, I'm left with 3 minus lambda is equal to plus minus 1, because if I remove the modulus sign, I'm supposed to put plus minus on the other side. Now, I'll take lambda on the other side. So when you take lambda on the other side, what are you left with? I am finally left with 3 minus plus 1. I hope there is no confusion on it. So whether you write it as 3 minus plus 1 or 3 plus minus 1, both are the same thing. I hope you're realizing why. So lambda goes on the other side, plus minus comes on the left hand side, it becomes minus plus basically. So 3 minus plus 1 is going to be either 2 or 4. So I have received two values of lambda from here. So two values of lambda we have been able to find. And so first value is 3 minus 1, that is 2. Second value 3 plus 1, that is 4. So we have found the value of lambda 1 and lambda 2. Let us go to the second part of the question. What was the second part of the question? The second part said that the radius of the circle passing through the points 0, 0, lambda 1, lambda 2 and lambda 2, lambda 1. Okay, so now I am dealing with a circle, right? So I am now dealing with a circle. Now what is special about that circle? That here, this circle is passing through, let's say 3 points. Which 3 points, students? 3 points which are given are, first of them is 0, comma 0. Okay, so this circle here passes through 0, comma 0. The second point here is lambda 1, comma lambda 2. So what is lambda 1, comma lambda 2? It is 2, comma 4. So second point is going to be, let's say, 2 comma 4, and the third point I think was lambda 2 comma lambda 1, which should be 4 comma 2. I have just drawn them randomly. I have not scaled them up as per the Cartesian scale. So just I have written these 3 points randomly on the plane. So this is what we have. Now what are we asked? I think we were asked the radius of the circle. So I need to find the radius of the circle. Now what are the multiple ways or different methods through which radius of this circle can be found? So we have this circle, right, students? I hope there is no confusion on it. So you can have two methods from here basically. First method is, let us assume, I'll discuss both the methods here. Let us assume that the center of this circle is h comma k. So if the center of the circle is h comma k, we know that this center will be equidistant from all these 3 points. So if I simply find the distance of this h comma k from 0 comma 0, the distance of h comma k from 2 comma 4, and the distance of h comma k from 4 comma 2, it should be the radius. I hope you're getting this part very clearly. So yes, by using the distance formula in 2D, I can write the relation. So h comma k with 0 comma 0, if I, let's say, denote it by C, this point by A, this by, let's say, B, and this is C. C is already there, so let's write it D, right? So what we are aware of is AC, BC and CD are equal. Can I not say AC square will be equal to BC square and it will be equal to CD square? I hope there is no confusion on it. So by having this square, I'll be able to remove that square root sign so that the calculation becomes more simpler. Now with that, if I find the distance between h comma k and 0 comma 0, I hope you know that h comma k and 0 comma 0 will have the distance as h square plus k square. This distance will be same as the distance between h comma k and 2 comma 4. So that distance is going to be h minus 2 whole square plus k minus 4 whole square, and this distance will be same as the distance between h comma k and 4 comma 2, that is going to be h minus 4 whole square plus k minus 2 whole square. Now all I need to do is, see, I'll deal with them pairwise. So first of all, I'll deal with this part, and then I'll deal with this part and this part. I hope these two equations will get created and get the final solution. How? Have a look at that part. So first of all, I'm comparing or I'm equating these two. I repeat, I'm comparing or equating these two. I hope you can see it completely and very clearly. So now if I'm equating these two, what do I get? On the left hand side, I'm having h square plus k square. Yes, on the left hand side, I'm having h square plus k square. What will I get on the right hand side? On the right hand side, from here I'll get h square, from here I'll get k square. So those h square and k square I'm writing first. Then let me write the terms in h and k. So here I'll get minus 4h. From here I'll get minus 8k. So minus 4h minus 8k. That will be the second term, right? And finally, let's talk about the constant terms. So the constant terms are going to be 4 and 16. So 16 plus 4 is going to be 20. Any confusions on that? Now, when you simplify h square by k square, what are you left with? H square, k square, k square are cancelled. So from here, 4h plus 8k is found to be 20, which when simplified gives you 4 can be taken common. So you're left with h plus 2k is equal to, I think, 5. So that is going to be your first equation over here. I hope there's no confusion on that in h and k. Now, let us work on the second result. So what is the second result? If I compare these two, this one with this one, I hope you can see it clearly. So if I compare these two, will I get a result? Yes, I will. Which result? Again, on the left hand side, I'll be having h square plus k square. So let me write that result first. So on the left hand side, I'll be having h square plus k square, of course. So here I'll have h square plus k square is equal to, what will I have on the right hand side? The expansion of this expression, right? So h minus 4 whole square will give you h square. Then of course k square is also what you'll get from this part, right? Then let us write the terms in h and k. So it will give me minus 8h, it will give me minus 4k. So minus 8h minus 4k. So here I'm writing minus 8h and minus 4k. Then what am I now left with? The constant terms. So it will give me 16 plus 4, which is going to be again 20, right? So this is going to be plus 20. Now, if I could simplify this result, again, what I'm clearly seeing is that h square, k square are cancelled. I'll be getting 8h plus 4k is equal to 20. And if I were to simplify this, what result will I get? I'll get, again, I can divide it by 4. So I'll be getting 2h plus k is equal to 5. I hope this result makes complete sense. So now I have received two equations in h and k. I can find the values of h and k by solving them together. So what I'm going to do is both of them are equal to 5, or rather, let us try and eliminate k from here. So I'm multiplying this equation by minus 2. So if I'm multiplying this equation by minus 2, it will be minus 4h minus 2k is equal to minus 10. And if I'm adding this equation to this equation, which is h plus 2k is equal to 5, then I think I'll be able to crack the value of h finally. So 2k and 2k are cancelled. This is minus 3h, which is equal to minus 5, I believe. So h is going to be 5 by 3. Now, once I have cracked the value of h, can I find the value of k? By putting h either here or here, I can find the value of k as well. So if I put h as 5 by 3, if I take the value of h as 5 by 3 here, so this is going to be 5 by 3 plus 2k is equal to 5, right, students? I hope there is no confusion. 5 by 3 plus 2k is equal to 5. So 2k is going to be 5 minus 5 by 3. I hope there is no doubt on that. So here it is going to be 5 minus 5 by 3, which is 15 minus 5 by 3, right? So this is 10 by 3. If 2k is 10 by 3, will you not help me with k, which is also going to be 5 by 3? Let me just check this calculation. 15 minus 5, 10 by 3. So 2k is 10 by 3, k should be 5 by 3. So h and k both are 5 by 3. Now what is the advantage of this? If I have found h and k both, which are found to be 5 by 3 comma 5 by 3, then I think I have found the radius of the circle. Why? Because radius of the circle is either AC, BC or CD. Are you getting this conclusion? So here, let us work on finding either of them. So I think AC is a simpler, BC is a very simpler task, more cost effective for us. So I'll begin with this part. So 5 by 3 comma 5 by 3 from 0 comma 0 is, I think, going to be, I hope you know, if let's say it is a comma a and it is 0 comma 0. So distance will be under root a square plus a square, which means root 2 times a. So here the distance is going to be root 2 times 5 by 3. I repeat, so this distance BC, which is going to be the radius, is going to be root 2 times 5 by 3, as we all can see in the option A. Now, as mentioned, this is the first method. This is the method number 1, which you all can use as per the need. And of course, this is what I will prescribe you all. But is there there is another method as well? There is. So what is that method? Let us work on that. Although, again, that method again involves a lot of calculation. So either you use this method or the method which I'll be sharing right now. Both of the methods are equally lengthy in terms of calculation. So either whichever you use is going to consume some time. So what you need to understand is you should have these two methods. Whichever you feel more comfortable with can be adopted. But I will still emphasize and recommend that first method you should be using. What about the second method? Second method is basically a formula. The formula says that the circumradius is always given by ABC upon 4 delta. Now what is ABC? ABC is the product of lengths of the three sides. So if the sides are A, B and C, lengths are A, B and C of a triangle, then the product of these three sides, the length of these three sides is given by A dot B dot C. What is delta? Delta is the area of the triangle. So through this also you can find the circumradius. Now what is the circumradius? Again, the approach, the formula remains very simple. Let's say this is a triangle which had 0 comma 0 as one of the vertices. Another vertex was, let's say, 2 comma 4, and the other vertex was 4 comma 2. So these are the three vertices of a triangle, let's say. Now there is a circle which passes through all the three vertices of this triangle. So there is a circle which luckily or coincidentally, let's say, passes through the vertices of this triangle. So of course, this circle is called the circumscribing circle, right, of this particular triangle. So if I am asked to find the radius of this circle or the circumradius of this triangle, then this is given by, let's say this is A, this is B, and this is C. So of course, this length over here is denoted by small a. I hope there's no confusion on it. This length over here is denoted by small c. And this length over here, the side of this length over here is denoted by small b. So by using distance formula, you can find a, b, and c. I hope you know how to find a, how to find how to find b, and how to find c. I hope you know that. So a, b, c can be found. Now, how do you find the delta? Delta is the area of the triangle. So by using the stair method, do you remember stair method? We had a discussion on stair method while having a discussion on in the chapter determinants. So through stair method, you can find the area of this triangle. I hope you remember it. If you have forgotten it, do watch it again. So yes, we know how to find delta, area of the triangle. We know how to find the lengths of the sides ABC if the coordinates are given. So I have ABC, I have delta. By using these values in this formula, I can find the circumradius, which again will be found to be root 2 times 5 by 3, which is given in the option A. So I hope both of the methods are making complete sense. First method was more logical, more understandable, I believe. Second method is again a formula based method. So yes, if you are comfortable in learning formulae, do keep this in mind. So I am making a note of it here. So this is the formula for the circumradius. So whenever you are asked to establish a relationship between the circumradius and the area of a triangle, this is the formula. So take a note of it, keep this with you, don't hesitate in remembering it or memorizing it. Now moving ahead, let's talk about a plane now. So I think we had a great discussion on lines. Now we'll be discussing planes. A very crucial part. Questions are formed on it, and line and plane are merged together, and then they become the second most important topic from this chapter. So basics of 3D, algebra of 3D is what you need to deal with first. That should be your priority. But yes, if I were to talk about the second most important topic, that will be line and plane. So line and plane are merged together, and then questions are framed on both of them together simultaneously. So of course, to understand line and plane or to solve questions based on line and plane together, you should be able to understand lines separately and planes separately. So now we are moving towards the part where we'll be having clarity on planes. And after having a discussion on planes, we'll see lines and planes merged together and how are questions formed on them and how should you deal with both of them simultaneously or together. I hope you're getting it. So let's look at the part where we discuss planes, right? So any of these three is given to me. If any of these three is given to me, what are these three things? Please pay attention to the first part here. What does it say? It says that if the normal to the plane and its distance from origin is given. What does it mean? It means, let's say that this is a plane. And let's say the normal vector, which is perpendicular to the plane, if that is given, and if this plane has some distance from origin, that is given. So if these two things are given, then I can write the equation of the plane. Second data. If this is not given, then what else? Let's say if I am told that the plane passes through a fixed point. So there is this plane and there is a fixed point lying on this plane. So if that point is given, and again a normal vector which is perpendicular to the plane is given to me. If that I know, then also I can write the equation of the plane. How? We'll discuss that later. But as of now, I'm discussing the other different cases. If they are given, I'll be able to write the equation of the plane. The third case. The third case says that if the plane passes through three non-collinear points. So let's say if there is a plane and on this plane, three non-collinear points are given. So if three non-collinear points are given on a plane, then also I can write the equation of the plane. So I will be able to define a plane uniquely if any of these three conditions is given to me. How? Let's have a look at that. So let's begin with the first part where I'll say that this is the vector form or the equation of a plane in the vector form when what you have is two things. The normal vector which is normal to the plane, which is perpendicular to the plane, which is a normal vector, which let's say is a unit vector, and then the distance from the origin. So distance of the plane or the perpendicular distance of the plane from the origin. Whenever we mention distance, it is always perpendicular if it is not specified. We always take it as the perpendicular distance. Have this thing in mind. So what I'm trying to make you understand is that let's say there is this plane. I hope you can imagine this very clearly. Two things, let's say we know that from origin, if I drop a perpendicular on it, then that perpendicular distance we know, and that perpendicular distance is given by a scalar quantity d. I hope there is no confusion on it. Similarly, we know that there is a normal vector to this plane. What is that normal vector to this plane? Let's say on this plane there is a vector which is perpendicular to it, and it is given by vector n, and its unit vector is given by n cap. Two things, I repeat, the perpendicular distance of this plane from origin, and second thing, the unit vector which is the normal vector to this plane. I hope there is no confusion on it. Now, what I am trying to make you understand is that by following the definition of the plane, I will say that if I take any point on this plane, let's say if I have taken any point on this plane, let's say that point is given by vector r. So please understand that if I have taken any variable point on this plane, that is vector r, which is xi cap plus yj cap plus zk cap. Now this point P, which is the variable point, which can lie anywhere on the plane, let's have its position vector is given by vector r. So of course, this vector r gives me the position vector of this point P, which lies on the plane. So I hope this OP is your vector r. There is no confusion on it. Now, one more thing which you need to understand here is that can I take the projection of this vector r on this vector n, which is the normal vector here? So if I take the projection of this vector r on this vector n, which is the normal to the plane, then its projection will be given by vector r into vector n upon mod of n. So vector n upon mod of n is nothing but what? N cap. And what is the projection of r on this vector n? I hope I need not tell you, that is nothing but the perpendicular distance of this plane from origin, which is given by d. So I hope you're realizing that this projection is nothing but the perpendicular distance of this plane from the origin. So did you get this part? That vector r, which is a variable point lying on the plane, which means the position vector of this point lying on the plane, dot n cap, any perpendicular vector to the plane. N cap is the unit vector, mind you. N cap is the unit vector. Take care of this thing. So r dot n cap will give you d. What is d? A scalar quantity, of course, but d is the perpendicular distance of this plane from this origin. So whenever you get something of this sort, you can say that this equation represents the equation of a plane, which has the normal vector to the plane as n cap, and it will have d as its distance from the origin. Did you get this part? Sometimes students confuse this with this phenomena, or with this assumption that let's say if I'm given r dot n vector as let's say lambda. Let's say if this is what I'm given. Lambda is a scalar quantity, n is a vector, r is a vector, where n is a vector which is perpendicular to the plane of the vector. Here, if you claim that lambda is the distance of this plane from the origin, then you are wrong. Can you help me with the fact that why are we saying that you are wrong in this case? You are wrong because here, if you pay attention to this vector n, what were we supposed to take here is that you should have n cap, the unit vector. So if this is the perpendicular or the normal to the plane, then its unit vector is needed to be taken. Its direction is needed to be taken. So if it is n vector, I need to divide both sides by mod n. So if I'm dividing both sides by mod n, here I'll have mod n. Here also I'll have lambda upon mod n. And now if you pay attention to this part, I hope you can see it very clearly that this r dot vector n upon mod n has become r dot n cap, and there you have this lambda by mod n, and this time this lambda by mod n is going to be the perpendicular distance of this plane from origin. So this lambda by mod n is becoming d now. The only thing you need to remember is that if you are writing the equation of a plane, and if you want to say that this scalar is the distance of the plane from origin, then you should ensure that this n should be a unit vector. This thing is needed to be ensured. Have you understood this particular result? Now, if this particular result is understood, let us understand its Cartesian form as well. This is exactly what we have tried explaining you right now, distance from the origin only. Now, let us discuss or understand its Cartesian form. Now, what do I mean by Cartesian form here? Let me just make a small correction over here. Just give me a second, students. This will not be R, this will be R equal to, right? So just give me a second. So let's say there is a plane, right? So we have a plane here. Let's say this is the plane, okay? Now, on this plane, there is a variable point. So let's say there is this variable point, R vector point, whose, coordinates in variable sense, let's say this point is given by P, and the coordinates of P in a variable sense are assumed to be X comma Y comma Z, because now we are looking at it from the perspective of 3D geometry. So far we have understood what is the equation of a plane from vector algebra sense. Now from 3D's perspective, let's try to have a look at that. So here you have this vector P. Now we know that there could be a vector or a unit vector perpendicular to this plane. So let's say I'm given a unit vector perpendicular to this plane, which is this n cap, and this n cap is given by LMN, which is Li cap, Mj cap, Nk cap. So the direction cosines, direction ratios or direction cosines, but let's prefer direction cosines. I hope you are understanding the reason why, because I need the unit vector. So let's say the direction cosines of this vector n cap are going to be L, M and N. So I hope you know this part again very clearly, that if I take the projection of this point P, OP basically, if I take origin somewhere, wherever it is placed at, so if I take the projection of OP on this vector N or N cap, it is going to be the perpendicular distance of this plane from the origin. So again, this dot this will be giving me D only. Again, the same logic can be applied, what we have learned previously, the projection formula. So by having this conclusion, I can conclude that this here will give me the equation of the plane. Now, when you look at it, that you wish to call it equation of the plane, what you need to understand here is that here the coefficients of x, y, and z, which were L, M, and N in this equation of the plane, are the direction cosines of this vector n, which is normal to the plane. What about this d? This d over here is the perpendicular distance of this plane from the origin. Now, I hope this makes complete sense. So, this is the Cartesian equation of the plane. What students again take mistakenly is that, let's say if sometimes I'm given this ax plus by plus cz is equal to d as the equation of the plane. So what they always or usually or by mistake take is that the coefficients of x, y and z, what are they? A, B and C. So they assume A, B and C as the direction cosines of the unit vector which is perpendicular to the plane, which again I think is wrong, because if they are the direction cosines, the sum of the squares of A, B and C should be 1. So what if it is not 1? Then you cannot call them the direction cosines, right? So that's the mistake they commit. So let's say if I'm given this and said that it is the equation of the plane, then you need to ensure that this A, B and C are either direction cosines, and if they are not the direction cosines, which means they could be the direction ratios. So let's say if I'm given the direction ratios A, B and C, can I get the direction cosines? Yes, I can. So if I have the direction ratios A, B and C, I can get the direction ratios. What are direction ratios? They are going to be A upon under root A square plus B square plus C square, B upon under root A square plus B square plus C square, comma C upon under root A square plus B square plus C square. So with A, B, C, I could get the direction cosines, which let's denote by L comma M comma N. So through that, I can write this equation here. I hope you're able to understand this. What I'm trying to make you understand is that L can be defined as A upon under root A square plus B square plus C square. Let's take this as the direction cosine here. Similarly, what about M, the second direction cosine? M can be given by, again, B upon the same under root over A square plus B square plus C square. Similarly, what about the N? N is given by C by under root over A square plus B square plus C square. Getting it, everyone? So these are the direction cosines. I hope you're getting it very clearly. Sir, how can I have the standard equation of the plane from this equation of the plane? All you need to do is nothing, but I hope you can see the hint right there in front of you. the coefficients of x, y, and z, which were a, b, and c. So divide both of the sides of your equation by the square root of the sum of the squares of coefficients of x, y, and z, which is under root over a square plus b square plus c square. So all I'm trying to make you understand is that if this equation was ax plus by plus cz is equals to d, which is not there in the standard form. This is the standard form of the plane, but this is not the normal form. There you cannot take this d as the perpendicular distance of this plane from the origin. And if you want to have it, then what you need to understand here is that I'm dividing both the sides by under root a square plus b square plus c square. So a upon under root a square plus b square plus c square will become L. B upon under root a square plus b square plus c square will become M, and c upon under root a square plus b square plus c square will become n. So this is going to be Lx plus my plus nz is equal to d upon under root a square plus b square plus c square. And that's how you need to understand that this will be the distance of this plane from the origin instead of d. So don't mistake it as d. That's the confusion, or that's the error students commit often. They usually look at the equation of the plane and then they take d as the perpendicular distance of the plane from the origin. No, you cannot have that. You first of all need to ensure that this ABC should be the direction cosines, which means the coefficients of x, y, and z should be the direction cosines. And if they are not the direction cosines, let's say they are the direction ratios of the normal to the plane, then you know how to convert direction ratios into direction cosines. So if you have converted direction ratios into direction cosines, the same balancing act should be done on the right hand side as well. And with that, I'll get this constant term on the right hand side. So it will become Lx plus my plus nz is equal to a constant quantity, a scalar quantity. And this scalar quantity over here, is the perpendicular distance of the plane from the origin. I hope you have understood this particular part very clearly. There is no doubt on it. Now, let's talk about the second part. What is the second part? The second part is pretty simple. Let's say this time I am given that there is a point which lies on the plane, first thing, and I am given the normal to the given vector. So previously there was a different case, but now let's look at the second scenario. What is the second scenario? The second scenario clearly says that this time I am given that this plane passes through a fixed point. So a point lying on the plane is given and the normal to the given plane is given, right? I hope you're comfortably understanding what I'm trying to say here. Again, if I try to make you understand the scenario here, would you not say, sir, let's say this is the plane. Yes, let's accept that this is the plane. So in this plane, let's say I'm given that fixed point, and that fixed point is given by, let's say, vector A. So that point's position vector is given by vector A. Okay. So if that is a point which is given by vector A, there will be a variable point which is given by vector R. And what I'm told is that here, this point which is vector A, through this point A, let's say there is a normal passes to the plane. So there is a normal to the plane which passes through A. So I am given a normal vector as well, which let's say is given by, let's say, n cap. So a normal to the plane is also given to me, which is given by n cap. Now, please understand, will you not help me with this particular result, that if I were to define this vector here, will you not say that, sir, this vector is going to be nothing but vector r minus a? And then if I take the dot product of this vector with this n cap, then do you not think that they are the perpendicular vectors? And if they happen to be the perpendicular vectors, then would you not say that if this vector and this vector over here are perpendicular, then their dot product will be 0. So the conclusion remains very simple. R minus a vector is a vector which lies in the plane. N cap is a vector which is perpendicular to the plane. So if these two things are given to me, point A which lies on the plane and the vector n cap which is perpendicular to the plane, then R minus a whole times n cap will be 0 because they are perpendicular. Their dot will be 0, which will again help you in writing the equation of the plane. Did you get that part? Again, if I rewrite this particular portion more clearly, so r dot n minus a dot n is what I'll get. So again, if you look closely, you'll get the same result. Which result, students? The same result, which means you will get r dot n minus a dot n. If I take a dot n on the other side, let's call it a scalar quantity. So again, I have gotten the same result, which is r dot n is equal to d, which is exactly what we have been discussing. So I hope you're realizing time and again, I'm giving you the same thing, that yes, r dot n cap is equal to d is going to represent the equation of a plane. But this equation of a plane can be attained with this case as well, when you are given a point lying on the plane and the normal to the plane. If these two things are also given, then also you can write the equation of the plane in this manner, and the logical explanation, the proof, is also given to you. Any confusions on that? Now let's move towards the next part, where we discuss the Cartesian form. How do you understand the Cartesian form? See, what we know is that there is a vector r, which is a variable vector, lies on the plane r. I hope you're getting it very clearly. Then there is a point A, which is a fixed point, which lies on the plane, which is x1, y1, z1. And there is a normal vector n cap, which is the normal to the plane, which is given by ai cap, bj cap, ck cap. So as per the discussion we already had, what did we discuss so far previously in the last slide? We had a discussion that vector r minus vector a dot n cap should be 0, because r minus a will be perpendicular to n cap, because r minus a will lie in the plane. N cap is the normal to the plane. So if I use this r minus a dot n, so what is r minus a? X minus x1, y minus y1, z minus z1. And if I take its dot, with n cap, which is a, b, c, I hope you're realizing it. So if I take its dot, then of course again I'm going to get an equation where it is going to be a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0. Again, if I were to simplify this, I'll have ax plus by plus cz on the left hand side. On the right hand side, the constant terms, ax1 plus by1 plus cz1. Can you see that? Again, it is r dot n is equal to d form. It is ax plus by plus cz is equals to d form, if you are paying attention. So again, with this thing, if you are given the point through which a plane passes and the normal vector, if these two things are given, then also you can write the equation of the plane in vector form or Cartesian, whichever you are asked to deal with. Is this part very well understood by you all? Now, moving ahead, let's get more clarity on the next part, where let's say I am writing the equation of a plane if it passes through three non-collinear points. So let's say there is a plane. Now, if there is a plane and on this plane 3 points lie. So let's say those 3 points are A, B and C. So we have a point A. Its position vector is given by, let's say, vector A, or you can call it x1 I cap, y1 j cap, z1 k cap. There is second point, let's say B, and there is third point, let's say C, right? Now, if they are coplanar, which of course they are going to be. So if there is a plane which passes through three non-collinear points, so if there are three non-collinear points, a unique plane can be defined, a unique plane can be drawn, a unique plane can be created, which will contain these 3 points. So if I am asked to write the equation of the plane, again I'll say, sir, let's take a variable point, let's call it P. In this case also they have taken this point as P. So if I define 3 vectors here, which 3 vectors, students? First vector, let's say, is going to be vector PA. I hope you can see that. Second vector is going to be vector PB, and the third vector is going to be the vector PC. Can you see that? Or if not PA, PB, PC, let's not take it PA, PB, PC. Let's say the vector PA, I hope we can take it. Then let's say I take another vector which is BA, and let's take another vector which is vector CA. So I have taken 3 vectors, PA, BA and CA, so that the other 2 rows remains more simpler. The reason is very simple, I'll tell you. But as of now, let's say that these are the 3 vectors lying in that same plane. I hope there is no confusion on it. Now, if these 3 vectors are coplanar, do you remember in vector algebra, we had a discussion that if 3 vectors are coplanar, then their box will be 0, their STP will be 0. Do you remember the discussion we had? Do you remember the discussion on coplanarity, that if 3 vectors are coplanar, their STP, their box, their scalar triple product will be 0. So I hope you remember PA, PB sorry, PA, B and CA, whichever three you take, but this will give you more simpler calculation basically. So PA, BA and CA, the box of these three vectors will be 0. How do you find the box? You take the determinant. So PA vector is x minus x1, y minus y, z minus z1. Similarly, vector B and vector CA can also be written, and then their box can be taken. Box means the determinant can be taken. And once you expand this determinant, once you find the value of this determinant, again you'll get a linear equation in x, y, and z, three variables basically with a constant term d. And again, that will represent the equation of the plane which contains these three non-collinear points A, B, and C. Are you able to develop a great clarity on this concept here? I hope there is no confusion on it. Similarly, if I were to write the vector form, the three vectors are going to be r minus a, b minus a, and c minus a. And if they are coplanar, their STP will be 0, their box product will be 0. And when you simplify their box product, this is the conclusion you get, which I won't ask you to remember at all. All you need to remember is the Cartesian form. That is sufficient. And even if you don't remember the Cartesian form, remember this conclusion. This is which will always help you in attaining the answer. Even if you don't remember this, that these three vectors will be coplanar, and if they are coplanar, their box will be 0. By this only, you can always create the equation of the plane. Don't hesitate in that. So you need not remember all these formulae. You should apply this approach and get the result, basically equation of the plane, whenever asked. Now, there are certain things which you need to understand. Let's say whenever you are asked that there is a plane, and if its distance from origin is asked. So in that case, let's say if these 3 points A, B, C are lying on the plane, then we can find the distance of this plane from origin by this formula as well. Again, don't remember it. Rather, I'll always say the 3 points are given to you. With the help of those 3 points, can you not write the equation of the plane? Yes, we can. We have just learned writing the equation of the plane. And once you have gotten the equation of the plane, through that you should be able to write the distance of the plane from the origin. I hope you must have been able to recall it, something which we have just discussed previously here, this particular portion here. So what I'm saying is, let's say 3 points are given to you. With those 3 points, let's say finally you are able to write the equation of the plane. So I hope you won't be in a rush to say that this d is going to be the distance of the plane from origin. No, it is not. So what you need to do is always divide this d by square root of a, b, by square root of sum of square of a, b and c. So a square plus b square plus c square, square root of it divides d. That's what gives you the distance of the plane from the origin. Sir, what if a square plus b square plus c square is 1? Then that's the best case. Why? Because in that case, A, B, C won't be the direction ratios. They'll be L, M, N. They'll be the direction cosines. They'll be the n cap. And if that is so, A square plus B square plus C square, if it becomes 1, then D will be the perpendicular distance of the plane from origin. But otherwise, this is the formula. I hope you're realizing it and you won't commit that mistake. So again, instead of asking you to remember this formula over here, I'll again say that remember that standard process which we have learned and apply that rather than learning or creaming this one. Did you get that part? Now, there is an intercept form of a plane. Can you recall something which you have studied in 2D coordinate geometry, that intercept form of a line? Can you recall that? So let's say there is a plane. Let me see if I have the figure or not. So I don't have the figure. I'll just draw it here for you. So let's say I have these 3 coordinates. Let's say this is the Z. Okay, give me a second, everyone. So these are the coordinates you have in the 3D plane: x-axis, y-axis, and z-axis. Let's say, right now there is a plane. So there is a plane and this plane intersects x-axis, y-axis and z-axis. So let's say that plane has its own infinite length because it is getting extended here, everywhere. It is getting extended here. But what I am now able to see is that this plane intersects x-axis, y-axis and z-axis at 3 distinct points. What are these 3 distinct points? The plane intersects x-axis at a, 0, 0. The plane intersects y-axis at 0, b, 0. And the plane intersects the z-axis at 0, 0, c. So what I know is the intercepts made by this plane on the axis, which are a, b, c. In that case also, you can freely, unhesitatingly write the equation of the plane as x upon a plus y upon b plus z upon c is equal to 1. Now, how do I personally remember it? I relate it with 2D. So in 2D, with straight lines, whatever we have studied can be applied to plane here in 3D. What I'm trying to make you understand is a very simple phenomena here, that if in 2D, the equation of straight line intercept form used to be x upon a plus y upon b is equal to 1. So here in 3D, the equation of the plane in the intercept form will be given by x upon a plus y upon b plus z upon c is equal to 1. Are you able to understand this entire phenomena very clearly here? I hope there is no confusion on it. With that, let us move ahead and understand another next pretty important concept. What is it? Let's say I am asked to deal with the concept of angle between two planes. Of course, questions are framed on it, questions are asked on it. So, equations of two planes are given, and then you need to deal with the angle between those two planes. So, how do you find the angle between those two planes? The modus operandi is very simple. Once you look at its algorithm, once you understand its approach, you can always think by yourself in this manner and get the result. Of course, we'll discuss the formula as well, but put your focus on understanding the approach, that how am I developing that formula, because that will help you a lot more in solving a lot of questions. Please understand, this exam is not checking your ability to put data in the formula. They don't want such brains which can memorize formulae, and whenever data is given to them, they put the data in the formula and find the answer. That is something which calculator does. You're not a calculator. You are intelligent, logical, sound brain. So if you are mentally, logically sound, then what is expected from you is that whether you can think logically or not, whether you can do the problem solving or not. Once concepts are taught to you, you are able to apply them or not, whether you are able to apply them or not. That's exactly what they're trying to assess. So here also, if I'm trying to teach you how to find the angle between two planes, that is you should put focus upon. That is where you should put focus upon. Because once you learn this algorithm, questions could be asked on this algorithm rather than the formula. There is no harm in remembering the formula. I am not against it. I am in favor of it. Do learn it. Do memorize it. Keep that formula with you, but have that algorithm as well through which you got this formula. Because in questions, rather than the formula, you will be using the algorithm more. You will realize it once you start solving the previous year's questions. So solve PYQs. You will start gaining this insight that this exam is more about being logical. This exam is not more about cramming the formula. This exam is more about understanding the concepts. So the more clear you are with the concepts, the better you understand them, the better clarity you have that how were you able to derive them, then you will be able to conclude a lot of things more clearly. You'll be able to deal with questions with more efficiently. You will start noticing it if you start understanding concepts in a more detailed and insightful manner. Let's get back to this part here. All I was trying to make you understand is that let's say I'm given two planes, right? So let's say we are given two planes here. So this is a plane here. This is another plane over here. So whenever I'm given two planes, can I not say I know the normal to the planes? So here, if this is the plane, this is the other plane, I know the normals to the plane. So look at this part very clearly here. See, what you all need to understand is that this angle over here between these two planes is theta. Right. Let me draw the normals here only. So the first normal, which is N1, can I draw that here only? So I'll try to draw it more clearly here so that you get more clarity. So let's say this is the first normal, which is this only, which is parallel to this normal only. I hope it makes complete sense here. You are getting a lot of clarity here. So this is this normal N1. I hope you're getting it more clearly. Similarly, you have another normal N2. So let me draw another normal, which is this N2 only, which I am drawing here. I hope you're getting it very clearly. Now, I'll do a lot of things here. Don't get confused by that. Just pay attention to this part. What I am trying to make you understand is that, see, please understand, this angle over here, which angle, students? This angle over here. This angle was a 90-degree angle. can you see that this angle over here was a 90-degree angle? Similarly, can I not say that this angle over here will also be a 90-degree angle? I hope there is no confusion on it. And one thing is there for sure is this, that the angle here, this angle here is theta. I hope there is no confusion on it. Now, if I were to ask you, can you help me with this angle over here? Let's say we don't know this angle, although it is theta, but let's say we don't know this angle and let's say this is alpha. Then will you not say that, sir, if this overall angle is needed to be found, what am I trying to say here is that this overall angle, the pink angle, the angle which I have colored with the pink color, if this overall angle is needed to be found, can I not say from this perspective, it will be alpha plus this 90? Are you getting it? So it will be alpha plus 90. I hope you're getting it. Similarly, from other perspective, will it not be 90 plus theta? So from another perspective, it will be 90 plus theta. So that's exactly what I'm trying to make you understand, that this 90 and this 90 gets cancelled and this theta is found to be equal to alpha. I hope you are able to digest this part completely, that whatever is the angle between the normals of the planes, that same angle will be there between the planes. Did you get that part? That's my point which I'm trying to make you understand here. I hope this part is understood by you all. So if I know two planes, then of course I know their normals n1 and n2. And if I know two vectors n1 and n2, can I not find the angle between those two vectors? By having n1 dot n2 divided by mod n1 mod n2, this will give me the cos theta of the angle, cos of angle between these n1 and n2. And this theta is the same angle which is the angle between the planes. So whenever you are asked to find out the angle between two planes, you can always find the angle between their perpendicular vectors, the normal vectors. So that same angle will be there between the planes as well. Did you get a great clarity on this concept? And if you have understood the algorithm, the logical approach, I think we can move ahead towards the next part here. Here, let's have a look at this part. This thing also which I'd like to explain here, that let's say two lines are given. Always remember this as a fact. So if this is theta, this is always 180 minus theta. Just remember it as a fact so that you don't get confused. What I'm trying to give you this here, that let's say if this is line L1 and this is line L2. So between line L1 and L2, of course this is L2 and this is again line L1. So if somebody says that there is a theta angle between the line L1 and L2, then there could be 180 minus theta angle will also be there between the same line L1 and L2. It is a matter of acute angle and obtuse angle. Let's say theta happens to be the acute angle between L1 and L2. So between the same line L1 and L2, there can be an obtuse angle also. I hope you're understanding why. So this clarity, if is received by you all, let us move ahead and let us understand, when do you call or say that two planes are perpendicular? I hope I need not explain this part again, that if the angle between their normals is 90 degree, which means the dot product of their normals is 0. So if two planes are given and I could find their normals, which we all can with a lot of ease, because normal is given in the equation of the plane only, and if the dot product of their respective normals is found to be 0, that means their normals are perpendicular, and if their normals are perpendicular, that means the planes are perpendicular. So what is the condition for perpendicularity? I hope you are understanding it. If the normal to the planes are perpendicular, the planes will also be eventually perpendicular. Did you get that part? Now moving ahead, let's have more clarity on this. When do you say that two planes are parallel? I hope I need not say this part again. Again, anything related to two planes being perpendicular or parallel can be said based on their normals. So if their normals are proportional, if the normal to the one plane is some scalar times the normal to the other plane, which means this n1 and n2 are parallel. So if their normals are parallel, I hope you're realizing the planes will also be parallel. I hope you're able to visualize this very clearly, very straightforward manner. Now, moving ahead, let's get more clarity on this part. In Cartesian form, let's say if I am having two planes, this a1x, b1y, c1z is plus d1 is equal to 0, a2x plus b2y plus c2z plus d2 is equal to 0. So here, the coefficients of x, y and z, a1, b1, c1, a2, b2, c2 are the direction ratios. They may not be the direction cosines, but they could be the direction ratios. They, of course, are going to be the direction ratios of the normal vector to the plane. Always remember this. So whenever these linear equations in XYZ are given, they always represent planes. Of course, you remember in coordinate geometry, if linear equation in XY is given, it represented a line. But in 3D, if XYZ, a linear equation in XYZ is given, then it will represent a plane. So, if you are given two planes, then the coefficients of XYZ will be the direction ratios of normal to the plane. So here, if I talk about the direction ratios of first normal to the plane, the normal to the first plane, it will be A1, B1, C1. Normal to the second plane will have the direction ratios as A2, B2, C2. And if I know the direction ratios, can I not find the angle between these two planes? I hope you must have remembered this particular formula, which we already have discussed, that if the direction ratios of two vectors are A1, B1, C1 and A2, B2, C2 respectively, then the angle between those two vectors is given by this formula, which is now going to be the angle between the two planes. Because as we know, the angle between their corresponding or respective normals is going to be the same angle between those two planes. Did you get a complete clarity on this part? If you have been able to understand this particular result, let us move ahead and the next part. The next part, again, if two planes are parallel, the coefficients of x, y and z will be proportional. If two equations or equations of two planes differ by a constant only, please try and understand. Let's say I write an equation somewhat like 2x plus 3y plus z plus 7 is equal to 0. And let's say I write another equation 2x plus 3y plus z minus 8 is equal to 0. Then of course, what you all can see it very clearly here is that x, y, z, their coefficients are same. Not even if they are same, even if they are proportional. What do I mean by proportionality? Let's say I double them. So 2x when doubled makes 4x. This becomes a 6y. This becomes 2z. And this is anything it can be, right? Even that, in that case also, the coefficients are proportional. 2 by 4 is 1. 3 by 6 is 1. 1 by 2 is, 2 by 4 is 1 by 2. 3 by 6 is 1 by 2. 1 by 2 is 1 by 2. So even if in that case, the coefficients of x, y, z are proportional, then the planes are said to be parallel. I hope you remember in 2D, two lines are said to be parallel if the coefficients of x and y are proportional. In the same manner, in the same fashion, in 3D, if the coefficients of x, y, z are proportional, then the planes are said to be parallel. So their constant terms may differ, but they will be proportional. I hope you're getting this result. So yes, that's the result for the condition for parallelism. And if you want to say that they are perpendicular, we know cos 90, which is 0. So the numerator A1, B1, A1, A2 plus B1, B2 plus C1, C2, that numerator is going to be 0. Did you understand this particular result as well? Did you get a great clarity on this result, that how did I find this particular conclusion? I hope there is no confusion on this part. Now, let us move ahead. Let us talk about how do you write a plane which is parallel to a given plane. If I were to ask you this question, will you not say, sir, the answer to this question is given in the previous slide only? Please understand. Let's say I am given a plane ax plus by plus cz plus d is equal to 0. That's a plane, right? That's a plane. Now, if I wish to write any plane which is parallel to this plane, would it not be ax plus by plus cz plus d dash is equal to 0? Because both of the equations will be same, because the coefficients of x, y and z are proportional, but they differ by the constant term only. So if the equation of a plane is given by ax plus by plus cz plus d is equal to 0, I can take another plane which is parallel to this plane as ax plus by plus cz plus lambda is equal to 0. Then I'll be given a certain condition. Which can be applied here in this particular equation, and then by applying that condition I could find the value of lambda. And once you crack the value of lambda, substitute that value of lambda here, through which you can define that plane uniquely. So that's exactly what I'm trying to make you understand, that if parallel planes are mentioned, you just take care of the constant term and the rest is handled in the same fashion the way you wrote the previous plane. So if the planes are parallel, x, y, z terms are same, they differ by the constant term only. Did you understand this part? Can I move ahead? Now, let's say there are two planes. If there are two planes, now try and imagine the book, the copy in which you are writing. So if you split that book, if you split that copy, I'm not having a copy here. So let's say these palms, these are two planes, right? So if these are two planes, I am joining these two planes like this. So by having this join here at this place, I hope you can see that this is the line of intersection of these two planes. This point here where my palms are intersecting, this is the line of intersection of these two planes. So if this is the line of intersection of these two planes, this line, I hope you can imagine this line. So from this line, this plane may pass, or this plane may pass, or this plane may pass, or this plane may pass. So infinite planes can pass through this line of intersection of two planes. I repeat, in 3D, if I were to make you imagine this particular result, I'll go back to this result which we had discussed when we were discussing the angle between two planes. So these are the two planes, right? And these two planes were intersecting here. Can you see them getting intersected here? Here, this is the line of intersection of these two planes. So from this line, are you not able to imagine that infinite planes can pass? Out of those infinite planes, these are those two planes which are passing through this line. And through that line, another plane can pass somewhat like this. I hope you're able to imagine. So infinite planes can pass through the line of intersection of two planes. So if two planes which are intersecting, then through their line of intersection, infinite planes can pass. And the family of those infinite planes is given by plane 1 plus, this is not equal to 0. What have they done is, this is incorrect. Let me just write the correct equation here. This is absolutely incorrect. Let me just make that required correction over here. So equal to 0 won't be here. Equal to 0 won't be here. This equal to 0 will be there on the right hand side. So here what you need to do is a1x plus b1y plus c1z plus d1 plus a scalar lambda mu k whatever it is times a2x plus b2y plus c2z plus d2 is equal to 0. Now again, to define a plane uniquely, you will be given a certain condition. They could say that this plane, that plane passes through a fixed point, and you can pass that fixed point to this family of planes, and when you make it satisfy by that point, you will be able to find the value of k. And once you crack the value of k, you can put that here and you can define that plane uniquely. So of course, infinite planes can pass through the line of intersection of two planes. But if I were to define a plane uniquely out of those infinite planes, I'll be given a certain condition. That condition will be satisfied here on this family of planes, through which I can crack this scalar quantity's value, the constant term I'll be able to crack, and then by putting that value here, I'll be able to define that plane uniquely. Did you understand this particular part here very clearly, students? And if you have gotten clarity on it, let us look at the other part, the next part here. Please pay attention. Let's say there is a plane. Let's say there is a plane. And this plane has its own equation given by ax plus by plus cz plus d is equal to 0. Now, what you need to understand is, let's say there is a point which lies on the plane. So if the point lies on the plane, it will satisfy the equation of the plane. So if I put the x, y, z coordinates of the point in the equation of the plane, it will be 0. It will satisfy the equation of the plane. But, what if the point lies on the left or on the right or the above or the below of the plane? It all depends where the plane is. It is basically our perspective. So when you wish to compare that whether a point lies, let's say we have 2 points. So the 2 points will be lying on the same side of the plane or could be lying on the opposite sides of the plane. So now let's say if I wish to figure out, if I wish to conclude that whether they lie on the same side of the plane or on the opposite sides of the plane, then the power of a point with respect to the plane comes into picture. What does it mean? Here, let's say there is a point P, there is a point Q, and there is a point R. So what I'm trying to make you understand is that if I find that this P and Q lie on the same side of the plane, on the left hand side of the plane. So what I'll do is I'll find the power of point P. What is the power of point P? In the equation of the plane, I'll pass the coordinates of the point P. Then I'll find the power of point Q. I'll find the power of point Q. So I'll pass the coordinates of point Q in the equation of the plane. And if they generate the same sign, which means either both of them will be positive or both of them will be negative. So if the power of 2 points is giving me the same sign, either positive or negative, then I say that both of the points lie on the same side of the plane. But in case of, let's say, P and R. So in case of P and R, if I find the power of point P with respect to the plane, which means I'll pass the coordinates of P in the equation of the plane, and I'll find the power of R with respect to the plane, which means I'll pass the coordinates of R into the equation of the plane. So if I find the power of P and if I find the power of R, which means I'll get a numerical value here. In that case, since they lie on the opposite sides of the plane, point P, let's say, lies on the left and point R lies on the right hand side of the plane, in that case, they'll generate the opposite signs. What does it mean? If P generates the positive sign, R will be giving me a negative value. And if P gives me a negative value, R will be giving us a positive value. Are you getting it? So in that case, what you need to understand is that the powers will be opposite in nature in terms of sign. So what you need to understand is if two points lie on the same side, their product, the product of their powers or their division of their powers, whatever you wish to take, either division or product, both will be fine. That will be positive because both of them are lying on the same side. So power of both of them will be either positive or negative. So positive into positive or negative into negative will be positive. But if they lie on the opposite side, if they are lying on the opposite sides of the plane, in that case, powers will be opposite, which means if it is positive, this will be negative. If this is positive, this will be negative. In that case, the product or the division of their individual powers will be negative because positive into negative or negative into positive will be negative. Did you understand the concept of identifying whether whether 2 points lie on the same side of a plane or on the opposite sides of the plane? This is how or what you do. I hope you all remember this method, this technique as well. So when I move ahead, let us talk about, can I find the distance of a point from a plane? Yes, we all can. How do we do that? Let us work on it. So first of all, let us understand the case here. What you need to understand is that let's say we are given a plane. So this is a plane here, right? And of course, in the 3D space, there is a point. So there is a point here. Let's say this is the point. So let me take the point as per what they have given. So they have given a point P. So point P has the coordinates x1, y1, and of course, z1, right? So these are the points x1, y1 and z1. Any confusions on that? And there you have a plane whose equation is given by, I hope I need not explain it, it is given by ax plus by plus cz plus d. So this here is the plane. So this plane is over here. I'm really sorry. So this is your plane over here. I hope there is no confusion on it. Now what I do next is, can you find the perpendicular distance of this point P from this plane? So let's say I drop a perpendicular from this point P to this plane. So let's say this is that perpendicular which we have dropped from point P to this plane. So this is that perpendicular. Do you or are you getting a complete clarity on it? So the feet, let's say, from point P, let's say I have dropped a perpendicular on this plane and I'm denoting that feet by, let's say, M. I hope there is no confusion on it. Now, what I am trying to make you understand is something very, very, very evident, something very clear, something which you all must have been able to notice, that this line PM passes through a point x1, y1, z1. Yes, it does. We all must agree with that. Similarly, this point PM will have the direction ratios, same as the normal to the plane, Do I know the direction ratios of the normal to the plane? Yes, because if I look at the coefficients of x, y and z, which are a, b and c, so they are the direction ratios of normal to the plane. And if they are the direction ratios of normal to the plane, I have drawn a line which is perpendicular to the plane, which is PM. So will it not be parallel to this normal only? So PM will also have the same direction ratios, a, b, c. So if I know the direction ratios of the line PM, if I know the point through which the line PM passes, can I not write the equation of the line PM? I can. The equation of the line PM is going to be x minus x1, y minus y1, z minus z1 in the numerator because it is passing through x1, y1, z1 upon individually I'll have ABC because ABC are the direction ratios of the line PM. Did you get this part? Did you understand this part? Now, if I am able to define this line, can I put it equal to lambda or any other value, right? Let's say, what are they putting it equal to? So they are saying x1 plus AR. So they are putting it equal to R. So instead of lambda, I'm taking R so that we stay in sync, whatever they have done, so that we stay in sync. So if I am putting all of these values equal to R, can I define a point parametrically on this line? So this point M this point M will have the coordinates, I hope you can see, x1 plus AR, y1 plus BR, z1 plus CR. So this point M, which lies on the line, will have these coordinates. But the problem here is that this R is a parameter which is an unknown to us. This is what we haven't figured out yet. But you have an advantage over here. What is that beauty? That beauty is that this point M is the feet of this point P on this plane. What is it? This point M is the feet of this point P on the plane. So this point M lies on the plane. And if this point M lies on the plane, would you not agree that this point's M's coordinates must satisfy equation of the plane? What was the equation of the plane? Ax plus by plus cz plus d is equal to 0. But what are the coordinates of M? They are x1 plus ar, y1 plus br, z1 plus cr. So if I put these coordinates into the equation of the plane, I'll get an equation in R, and through that I can crack the value of R. I am absolutely not asking you to remember this formula. I am very intensively trying to make you understand the approach. That's exactly what you need to learn, because if you could remember that approach is what you're supposed to apply in the examination hall or even while practicing the questions. So yes, I repeat my statement. We have found the coordinates of M in a parametric form, and if I put those coordinates of M into the equation of the plane, because M lies on the plane, it will satisfy the equation of the plane. So through that, I can get the value of R. R will give me a value, a numerical value, 2, 3, 4, minus 7, root 3, something like that. So once you have cracked the value of R, once you have received the value of R, I think you will put the value of R here. And once you put the value of R here, you will basically have the coordinates of M. Because R is now known to us. So I'll replace or substitute the value of R here, and that's how I'll get the value of coordinates of this point M. And I hope I need not explain this part. Once you crack the coordinates of M, you can, by using the distance formula, find the distance between PM. Because we have the coordinates of M, we know the coordinates of P, so we can find the distance between P and M. Once you have found the distance between P and M, what is it? Is it not the perpendicular distance of this point P from this plane? Did you understand my statement? Did you understand the whole algorithm? Are you able to understand this approach? Will you remember this whole process which I have suggested or explained here? This is exactly what you need to understand or remember, because this is exactly what we'll keep doing while solving questions. So instead of learning a formula, this is what you should understand or remember, because this is what is needed or expected out of you in different set of questions. Please understand, I repeat my part very clearly. You are not a machine or a calculator which is asked to figure out an output when an input is provided. You are a logical brain who can solve problems. And that's where I am suggesting you with some solutions, with some approaches, with some ideas. And you should use these ideas in your questions while dealing with the problems. Are you understanding what I'm trying to make you understand? The idea is very simple, students. I don't remember this person exactly. It was maybe Benjamin Franklin or someone else. He once said that give a man a fish and you can feed him for a day. Teach a man to fish and you can feed him for the entire life. Are you understanding my statement? So if you are helping somebody thoroughly, if you're spoon feeding someone, then you're not actually helping them. They are becoming totally dependent on you in that case. But rather, as a teacher, what is my job is to help you, to make you able to develop that skill in you, to ignite that spark in your brain. And once that spark is ignited, then you should be able to solve those problems by yourself. So I am staying there as a supporting hand, as an assistant. You are who is supposed to solve those problems. I hope you're understanding my motive, my intent very clearly as a teacher here. Now, let's get back to the next part here. If this particular thing is understood by you all, let us move to the next conclusion. This is what you can remember. Always remember with you that whatever we have discussed, the final conclusion is this formula. After finding the value of R, you can find the coordinates of M. And once you have found the coordinates of M, you can find the distance between P and M. And once you apply that distance formula between P and M, this is what is found. What is it? ax1 plus by1 plus cz1 plus d, which is the power of point P with respect to the plane, divided by under root over coefficients of x, y, and z, which are a square, b square, and c square, sum of this. And you take mod of it because it is the distance. Now, even if you were to remember a formula, sometimes you can relate it with something which you already know, and then you can extend it and remember it. How? Please understand, in coordinate geometry, while dealing with a straight line and a point, if there was a point x1 comma y1, and if there was a straight line ax plus by plus c is equal to 0, then what was the formula for finding the distance of that line from that point? The formula was ax1 plus by1 plus c divided by under root over a square plus b square, and then you put a mod over it because the distance should be positive. Are you not realizing the same formula is getting used here? The point was x1, y1, z1. The plane was ax plus by plus cz plus d is equal to 0. So as I have been mentioning that the way line was behaving in 2D, in the same fashion plane is behaving in 3D. So if there is a point x1, y1, z1, and if there is a plane ax plus by plus cz plus d is equal to 0, then the distance of this plane from this point, perpendicular distance mind you, will be given by modulus of power of that point with respect to the plane, which is ax1 plus by1 plus cz1 plus d, divided by under root over a square plus b square plus c square. I hope you are able to relate it, or rather extend it from your understanding of coordinate geometry. Can you see a lot of things getting related here? Of course you can, and that's how you can learn or remember these things. Well, if this part is understood, let us move ahead. Let us get more clarity on one more concept, that if, let's say, I am given two parallel planes. So if there are two parallel planes I'm given, right? So this is a plane, let's say, and there is another plane which is parallel to this plane, right? So these planes are parallel. And if these planes are parallel, there could be some distance between these two planes which are parallel. So what could that distance be? I repeat my statement. Do you remember a formula when we were asked to find the distance between two parallel lines? What was it? Modulus of c minus c dash upon under root a square plus b square. That same formula can be used, even that same algorithm can be used here. See, I can find the perpendicular distance of this plane from origin. I can find the perpendicular distance of this plane from the origin. And the difference of those distances will be the answer because they are parallel. I hope you're understanding the algorithm. So what is the formula finally which you are supposed to deal with? The formula is the numerator will have the differences then in their constant terms divided by under root over a square plus b square plus c square. I repeat, if I'm given two planes, let me just make a correction over here. This entire is not D1. D1 will be there. 1 will be there basically as a this part here. So if you are given two planes, AX, BY, CZ, AX, BY, CZ, because they are parallel, but D1 and D2 will be different because they'll differ by the constant term. So these are two parallel planes. Then what you need to remember is that the distance between these two planes is given by the difference between their constant terms divided by under root over a square plus b square plus c square, and then you take the mod of it because the distance is positive. Now there is the catch. Students commit a mistake. What is that mistake? Let me help you with that, and please don't do that. Let's say one of the planes is 2x plus 3y plus z plus 7 is equal to 0. And the other plane is, let's say, 4x plus 6y plus let's say 2z minus 1 is equal to 0, right? These are the two planes. And I'm asked to find out the distance between these two planes. Now, students make an error that they subtract 7 and 1. They take the difference between 7 and minus 1, and then they divide it by under root over 2 square plus 3 square plus 1 square. And that's wrong. Why? I know, and we all know that these two planes are parallel. But the problem here is that their coefficients are not same. So to apply the formula which we have learned to find the distance between two parallel planes, what you should remember is that the coefficients must remain same. So here, instead of dealing with this plane, I should deal with a better plane in a better format. This plane's equation can be converted into, when I divide both the sides by 2, I'll get 2x plus 3y plus z minus 1 by 2 is equal to 0. And now, I'm supposed to use the distance formula on this and this plane. I hope you're realizing if you were to use the distance formula between these two planes, you would have gotten a wrong answer. And you could have gotten confused because which ABC will you take? Will you take 4, 6 or 2, or will you take 2, 3 or 1? I hope you're realizing. So that's the problem there. So first of all, you should have the coefficients to be same. 2, 2, 3, 3, 1, 1, right? So I now know that these two planes are completely parallel, although they were parallel previously as well, but now the equation makes sense and then the formula can be applied. Of course, in the numerator, you will take the difference between the constant terms divided by under root over a square plus b square plus c square. And of course, if it is found to be negative, put a mod over it to make it positive. Anyway, put a mod over it. Because if there is a variable, you forget to put a mod over it, and then despite, when you don't put a mod over it, you get only one value. And sometimes the solutions are two. Why? Because of the mod. So develop this as a habit of putting a mod. Have you gotten a complete clarity on this particular concept? Can we move ahead with this part now? Now, let's look at the next part where I say that how do you find the angle bisector, or sorry, it's not the angle bisector, rather. This is the equation of a plane which is the bisecting the angle between two planes. Now, what does it mean? First of all, let's understand that particular part. So let me just draw it more properly so that I could explain this part here. Let's say we have two planes. Let's say we are dealing with two planes. So this is the first plane we are dealing with. And then there is one more plane, let's say. This is the other plane, and let's rotate it a little so that this is how it is drawn. Okay. So I'm just rotating the other plane like this, let's say, and this is how the other plane is drawn. It will be very difficult for me to draw it here. So let me just skip this part and let me draw another plane. So give me a second, participants. So let's say this is the other plane, right? So this is the other plane. So these are the two planes basically. Okay. Did you understand this part? If you are not able to digest what I'm trying to say here, these are basically two planes, right? So let's say I'm drawing a line in this plane so that we can draw and understand the things more clearly. And I'm drawing one more line in this other plane, which let's say is this. Now, I hope you can see that these two dotted lines can have angle bisectors. One could be the acute angle bisector, other could be the obtuse angle bisector. Similarly, if you start imagining these two planes, I hope you can see these two planes. So when these two planes are intersecting, then I can see two planes getting created with the help of the angle getting bisected between these two planes. What I'm trying to make you understand is, see, if you are noticing, are you not noticing that this is the first angle which is getting created by the, bisection of these two planes? Similarly, this is also one of the angles which is getting created by the bisection of these two planes. So I'll be having two planes. One will be an acute angle bisector plane, another will be obtuse angle bisector plane. I hope you're realizing and understanding it. So again, if I draw it here, it will become more confusing, but I'll try to do it so that you get the clarity on this. But yes, I'll remove it if it becomes confusing, and I'll just give it this to you that you should understand it by yourself. So let us say that I am drawing somewhat like this. I'll just put it here. Don't conclude anything right now. Let's say this is a plane which we have been able to draw, let's say, which is very difficult for us to comprehend at this stage. But now, since it is a 2D, plane basically, in which I'm trying to draw all these 3D shapes and you won't be able to comprehend, the only thing which I can do this is this last thing, that this here line is the line which is basically the angle bisector of these two planes, and through this a plane is passing. So this this pink colored plane is the plane which is passing through the bisection of the angle between these two planes, which are orange and green. Even if you are getting confused, don't look at this. Imagine that we have two planes. You can take your own copy and you can have this. So take two pages like this, and these are the two planes. So between these two planes, there is a line, right? So there is a line, there is an angle. So if you bisect that angle, the third plane can pass through it. So let me take this remote of this AC. So this remote of the AC, this remote of the AC, I hope you can see it here. See it here like this. This remote of the AC, this is the plane which is the bisector of the planes, bisector of the angles between these two planes. Are you getting this part clearly here? So that's exactly what I was trying to draw here, but it is of course very difficult for us to draw something like that in 2D. So if I could simply give you that what could be the equations of those two planes. Why am I getting two planes? Because one will be an acute angle bisector, the other will be an obtuse angle bisector. So if it is giving me two planes. So all you need to do is the way we used to do in straight lines. In the same manner, I'll do the same thing in the planes as well. What did we used to do? Let's say we were given two straight lines, ax plus b, a1x plus b1y plus c1 is equal to 0. I'll just make you understand in the context of lines. And that same formula needs to be extended here. So let's say two lines are a1x plus b1y plus c1 is equal to 0. And what used to be the second line? Second line was a2x plus b2y plus c2 is equal to 0. So in coordinate geometry, what you will learn is that the angle bisector of these two lines is given by, you write the equations of these two lines. So a1x plus b1y plus c1 divided by under root over a1 square plus b1 square is equal to the other line. What is the other line? a2x plus b2y plus c2 divided by under root over a2 square plus b2 square. And of course, you put a mod on both these sides. So when mod is removed, you put plus minus on either of these sides. Please understand. While discussing the chapter straight lines, we'll have a discussion on this and I'll explain this part, that where did we get this equation from. I'll explain it with the logic as well, so don't worry about that. That same logic is being used here, so don't worry about it. Just learn this result. That same formula is getting extended in 3D. How? The equation of the plane is a1x, b1y, c1z, d1. Second plane is a2x, b2y, c2z, d2. Now, in the denominator, I'll have a1 square, b1 square, c1 square. Here, a2 square, b2 square, and c2 square. Only thing is, I'll put plus minus sign. So, one of them will be an obtuse angle bisector. The other one will be an acute angle bisector. I hope there is no confusion on it. You have gotten a complete clarity on this particular part. Now, here, what you also need to understand is that sometimes you need to answer that find the bisector of the angle between the two planes which contains the origin. I hope you're realizing. So let's say here this could be one of the angle bisector, or the other plane could have gone like this. The other bisector could have also been possible. So the plane which contains the origin, or the plane which is closer to the origin, if that plane's equation is what I'm asked to deal with, then do one thing. First of all, ensure that when you're writing the equations of the planes, d1 and d2 are positive. Ensure that when you're writing the equations of the planes, d1 and d2 are positive. What do I mean by that? First of all, here it should have been a2x, b2y, c2z, and d2. Now, let me try and explain it to you. The algorithm I'm explaining to you. Let's say I'm given two planes, x plus y plus 3z minus 4 is equal to 0. And the equation of second plane is 2x plus 2y minus, let's say, z plus 7 is equal to 0. So first of all, the problem is that constant term here is positive, but here it is negative. So take negative sign common out of it. So this equation can be written as minus x minus y minus 3z plus 4 is equal to 0. So have I now ensured that the constant terms in the equations of both of the planes is positive? Yes. Now do the next thing. What is the next thing? The next thing is write the equation of the first plane, which is 2x plus 2y minus z plus 7. Write the equation of the second plane, which is minus x minus y minus 3z plus 4. Now, divide them by their coefficients square sums under root, which means 2, 2, 1, which is 4, 4, 1, which is going to be 9, and square root of 9 is 3. Here it is going to be 1, 1, 9. So this is going to be 9 plus 1, 10, 10 plus 1, 11. So it is going to be under root 11. So this equation is put equal to this equation, and instead of putting a plus minus sign, put the plus sign only. So with that plus sign, you are writing the equation of the plane which contains the origin, or the plane or the bisection which contains the origin. I hope you are getting it very clearly. So if I put the negative sign, then I'm writing the plane in the section in which does not contain the origin. So let's say here, this was the pink angle bisector which contained the origin. So this plane does not have the origin on it, but here, in this angle, in this zone, in this entire section which is, getting created like this section contains origin. So this section which is created by this angle bisector, this does not contain the origin. So I am writing the equation of this pink plane. I hope you're understanding this particular part. So I hope you're understanding the modus operandi is very simple. If two planes equations are given to me, and if I'm asked to write the angle bisector of these two planes, which contain the origin, which means the angle which contains the origin. It is not the plane which contains the origin, it is the angle which contains the origin. Then first of all, ensure that the constant terms are made positive, and once the constant terms are made positive, you just equate them like this, put their denominators as under root over a square b square plus c square, and that's how. Put a plus sign, don't put the negative sign. If you are putting the plus sign, it will give you the equation of the angle bisector, which contains the origin. If you put the negative sign, then it will be the angle bisector which does not contain the origin. Here the catch is, ensure that the constant terms are made positive first before this is done. That's exactly is what I am trying to give you as a result. I hope you will remember it. Now, the second result will be this, that how do you find the equation of the plane where you are defining the acute angle bisector and obtuse angle bisector. So sometimes instead of origin, you are asked to find the acute angle and obtuse angle bisector. Again, the modus operandi remains same. First of all, ensure that the constant terms are positive. First of all, ensure that the constant terms are made positive. So the two planes are a1x, b1y, c1z plus d1, and the second plane is a2x plus b2y plus c2z plus d2. What you now need to ensure is that d1 and d2 are positive. Did you get that part? Now, what is the next step? The next step is calculating this thing. a1, a2, b1, b2 and c1, c2. If you calculate this, a1, a2 plus b1, b2 plus c1, c2, and if this is positive, then always remember that the positive sign, I hope you're remembering that there are two possibilities. In front of this, when this is written, you have two possibilities, either put plus sign or minus sign. So I hope you remember, I have two choices to pick, either plus sign or minus sign. Now, first of all, always remember, did we not have a discussion that if d1 and d2 are made positive, then it is always the positive sign which gives you the bisector which contains the origin. So remember this as a fact, that origin lies in the obtuse angle bisector. What I'm trying to make you understand is that if a1, a2 plus b1, b2 plus c1, c2 is positive, then this will be the obtuse angle bisector. This will be the obtuse angle bisector. Plus means when you are putting plus here, and the negative sign wala angle bisector will be the acute angle bisector. I hope you are not getting confused here. Vice versa, the opposite. What is the opposite? The opposite part is if a1, a2 plus b1, b2 plus c1, c2 is calculated, and if it is found to be negative, then origin lies in the acute angle bisector. What does it mean? It means, I hope you remember the origin. The bisector which contains the origin was represented by the plus sign. So again, I had two choices, either I put plus or minus here. So when you are putting the plus sign, this angle bisector, which you will get by putting the plus sign over here, gives you the bisector which contains the origin, and the bisector which contains the origin is the angle bisector, which is the acute angle bisector. So in that case, the bisector which you will create with the help of the plus sign will be the acute angle bisector, and of course, the negative one will give you the obtuse angle bisector. One more trick I have to remember is, how I personally remember is, that I say that whatever the sign of this expression is, will be the sign of the obtuse angle bisector. What did I just say? Let's say first of all, you need to ensure that d1 and d2 are made positive. That is something which you need to remember. So once you have made d1 and d2 positive, then you calculate a1, a2 plus b1, b2 plus c1, c2. And if it is positive, the obtuse angle bisector will be positive, which means it will be represented by the plus sign. If a1, a2, b1, b2, c1, c2 is found to be negative, then the obtuse angle bisector will be given by negative sign. That's how I remember it. So if I could conclude whatever we have learned so far, I repeat, first of all, always remember this as a fact, that in the very first step, ensure that d1 and d2 are kept positive. Now you have two choices. You compare the equations and you put plus minus sign. So here you write an expression, there also you write an expression, and you put plus minus sign. Now what you do is, you evaluate a1, a2. Now you evaluate a1, a2 plus b1, b2 plus c1, c2. Right. Now this a1, b1, c1, a2, b2, c2 should be those A1, B1, C1 and A2, B2, C2 which you have attained after making D1 and D2 positive. Do not take them from the previous equation. Please keep this in mind. So update the equations of the plane. Ensure that the constant terms are positive. The moment you see an angle bisector question or a question based on angle bisector, do this thing first of all, that you ensure the constant terms are made positive. I hope you'll remember it. Once the constant terms are made positive, then what are the cases? Let's explore all of them. Let's have a summary of all of them. I hope you know how to write the equation of the angle bisectors. So it will be a1x plus b1y plus c1z plus d upon under root over a1 square plus b1 square plus c1 square is equal to plus minus a2x plus b2y plus c2z plus d2 upon under root over a2 square plus b2 square plus c2 square. That is not what I'm writing, assuming you know. And I'll be using plus minus sign. Now, plus and minus will help us in understanding which one contains origin, which one is the obtuse, which one is the acute. Now, it all depends based on this. A1, A2, B1, B2, C1, C2. You evaluate this. Now, there are two choices. A1, A2, B1, B2, C1, C2 will be either positive or negative. What is the trick? Whatever is the sign of A1, A2 plus B1, B2 plus C1, C2, that same sign I'll be taking from here to write the obtuse angle bisector. Did you get that part? So if A1, A2 plus B1, B2 plus C1, C2 is found to be positive, which means the angle bisector, which I'll write with the help of the plus sign, will be the obtuse. I hope you're writing. I hope you're getting. Similarly, if I'm getting this value as negative, then the obtuse angle bisector will be given by the negative sign here. So if I take the negative sign and simplify this and solve this, then the bisector which I'll get will be the obtuse angle bisector. Did you get that part? Second part. I hope with this I will be able to conclude that if with the plus I'm expressing the obtuse angle bisector, with negative sign I'll be expressing the acute angle bisector. If here with negative I'm expressing the obtuse angle bisector, with positive I'll be expressing the acute angle bisector. Any confusions on that? Now, what about the bisector which contains the origin? The approach was very simple. You have maintained D1, D2 to be positive. So put the plus sign and that will give you the bisector which contains the origin. So here I use the plus sign for the obtuse. So this one will be containing the origin. Here I use the plus sign for acute. So this one will be the one which will be containing the origin. I think with this particular slide, you have been able to summarize all what we have studied so far. This is the part which is the most confusing part because students tend to forget it. So I hope with this summary you will keep this thing in mind, and how to write the angle bisector which contains the origin, how to write the angle bisector which is the obtuse angle bisector, how to write the angle bisector which is the acute angle bisector. All of that can be concluded with this cheat sheet. So I hope you can take the screenshot of it so that you can remember it. Now, let us move ahead and let us talk the next concept, which is called the angle between a line and a plane. How do we understand it? Let's have a look at that part. Mostly whatever we have discussed so far is the portion or was the portion from where maximum number of questions are asked. But sometimes they merge the concepts of lines and planes and they ask questions based on the merger of these two concepts together. So what all possibilities can be generated or created, let us explore them one after another. But I hope, I'm sure that whatever we have explained or understood so far is very well understood by you all. There is no confusion on that front. Now let's talk about this. So there is another case, another part where we'll be discussing angle between a line and a plane. So I hope you're realizing this part here. Let's say there is this line, right? So to get the direction of line, what I need is the direction ratios of the line to which it is parallel to. So we know that vector B is that through which or to which I can find that this line will be parallel to the vector B. Let's say if there is a line R which is defined as A plus lambda B. So what I know by looking at this line is that A is a fixed point through which the line passes and B is the vector to which it is parallel. I hope you're getting it. So that let's say this is the line. And if I want to know something about the direction of the line, this vector B is sufficient for that to help us in understanding the direction of the line. Similarly, we have this plane. If I look at the plane, then I have this thing that R dot n cap is equal to D. So that's the equation of the plane. So here by looking at this n cap, we can conclude that this will be the normal of the plane. So I am trying to find out the angle between the normal and the line. So the normal to the plane is n cap, let's say, and the line is B. So can I find the angle between these two vectors? So the angle between these two vectors, which two vectors? vector b and vector n cap, I hope you know cos theta will be given by vector b dot vector n divided by mod b mod n. My concern is not to make you understand how to find theta. Theta was not the angle between the line and the plane. Theta was the angle between the line and the normal to the plane. But if I am interested in finding the angle between the line and the plane, do you not think it will be 90 minus theta? Are you understanding it? Because normal is 90 degree to the plane. So if the angle between the line and plane is theta, if the angle between line and the normal to the plane was theta, then the angle between line and the plane will be 90 minus theta. So my funda will remain very simple, that if you have understood that cos theta will be given by b dot n upon mod b mod n, then this is cos theta. Now what I'm trying to make you understand is to find the angle between, please understand this is cos theta. Let's say the angle between the line and the plane is given by alpha, which is 90 minus theta. So what I know is that cos theta here is given by vector b dot vector n upon mod b mod n. I hope there is no confusion on it. I hope there is no confusion on it. You know what is vector b, you know what is vector n. There is no doubt on it so far after having this much great clarity on these two concepts, plane and lines. Now, my concern is, if you know what is cos theta, can you not crack cos alpha or whatever alpha, sin alpha, tan alpha, whatever you need to find? Because what is the relationship between theta and alpha? If alpha is 90 minus theta, can't you say that theta will be 90 minus alpha? So if I replace theta by 90 minus alpha here, we'll get cos 90 minus alpha, which is sin alpha. So sin alpha will also be same as this only. So this is the sin alpha. So from here, I hope you are able to create a formula that sin alpha, where alpha is the angle between the line and the plane, is given by b dot n upon mod b mod n. It is not cos theta, it is sin alpha. What is alpha here? The angle between the line and the plane. Because cos theta gives you the cos of the angle between the line and the normal. So that will be equal to sin alpha, because alpha is the angle between the plane and the line, which will be same b dot n upon mod b mod n. Did you understand how are we able to derive this relation or conclusion with the help of this particular property or observation only? Even this is not even a property, a simple observation only. With this, you can conclude a lot of things. The line will be, I hope you can see that if the line is parallel to the plane, then alpha will be 0. If sin alpha is 0, sin is 0, which means b dot n is 0. So if b dot n is 0, the line is parallel to the plane, because line is perpendicular to the normal to the plane, which means line is parallel to the plane. Now, similarly, if b is proportional to n, which means b and n are parallel. So if the line is parallel to the normal to the plane, which means line will be perpendicular to the plane. So I hope these are some simple conclusions or observations which you can make through your own understanding as well. So far, we have been discussing this thing time and again, everywhere in all the concepts which we have been learning. Condition for perpendicularity, condition for parallelism, which you can again bring here in this picture. Now, if that part is understood by you all, let us move to the next part. Can we find the intersection of a line and a plane? So let's say I am given a plane. So we have a plane somewhat like this, right? And there is a line. So there is a line. Let's say this is the line which goes somewhat like this. So this here is the line, and this line is passing through the plane. So of course, this line must be intersecting the plane somewhere. So this, let's say this is the point where the line intersects the plane. So if I put it equal to lambda, let's say, can I write a point in parametric form on the line? So that point in a parametric form on the line will be given by, I hope you know, L lambda plus x1. I hope you know that. Similarly, m lambda plus y1. I hope you're understanding it. Plus n lambda plus z1. So this is a point, let's say P, lying anywhere on the line parametrically. Now, let us assume that this point P is the point of intersection of line and the plane. Then what is special about this point P? Do you not think that in that case, that if this point P is the point of intersection of the line and the plane, in that case, this point P must satisfy the equation of the plane. So this in place of x, I hope you're realizing, this in place of y, and this coordinate in place of z can be substituted here in this equation. And through that, you can find the value of lambda, because the only variable will be lambda, because you know A, you know L, you know x1. So everything is what you are aware of. Only thing which you don't know is lambda. So by passing these coordinates into the equation of the plane, because P will satisfy the equation of the plane, because P lies on the plane, I'll get the value of lambda. Once you have cracked the value of lambda, can you not find the point of intersection, which is P? So if I'm asked to find the intersection of a linear plane, this is the algorithm, this is the approach where I'll use. Instead of making you solve a lot of questions this time, we are understanding different approaches. So this time 3D has different set of questions. So instead of making you solve those examples or illustrations, I'm giving you different cases. If this arises, this is what you should do. If this happens, this is what you should do. If this happens, then this is the tool which you use. So basically this time I'm giving you all the weapons, basically the artillery we are developing. So if this is the case, use this weapon. If this is the case, use this theorem. If this is the case, use this formula. If that kind of question arises, use this algorithm or this approach which we have learned. So I'm giving you all the different cases basically. And then you develop your mindset, you develop your entire approach that if this happens, then this is needed to be done. If this pattern comes, this is what is needed to be done. So here we are discussing a lot of patterns theoretically, and then you're supposed to apply these patterns depending on the type of questions which are asked in the examination hall. I hope you'll remember it. So if I talk about the next case, which you may be supposed to deal with, this is what we have already discussed. Now, this is exactly what you'll get, so don't worry about it. Now, we have already discussed in the Cartesian form, if a line is parallel to the plane. In the vector form, we had a discussion on it. So if in the Cartesian form, if a line is parallel to the plane, so what do we know about the line? So line will have this L, M, and N as its direction ratios, and plane will have A, B, and C as its direction ratios. And we know if these two vectors are basically perpendicular. Why? Because please understand, this is the plane and the plane has a normal and the line is parallel to the plane. So the line is parallel to the normal to the plane. I hope you are understanding it. I repeat my statement. If you are getting confused, let me repeat this part more clearly. If you are not getting or understanding it, the things are opposite here. Please understand. If the line is parallel to the plane, which means line is perpendicular to the normal to the plane. Are you understanding it? This is exactly what I'm trying to make you understand. So let's say if there is a plane, and this plane has a normal to it, and there is a line which is parallel to the normal to the plane, which means the line will be perpendicular to the plane. But if the line is parallel to the plane, let's say if the line is parallel to the plane, in that case it will be perpendicular to the normal to the plane. Are you understanding these two cases? So first case, the line is parallel to the plane. So if the line is parallel to the plane, it will be perpendicular to the normal to the plane. Are you understanding my words? Now, if the line is perpendicular to the plane, the normal has A, B, and C as its direction ratios, and the line has L, M, and N as its direction cosines or ratios. So if the line has L, M, N, if the normal has A, B, C, and if they are perpendicular, normal and the line, then of course A, L plus B, M plus C, N will be 0. I hope you are understanding why. There is no doubt or hesitation or confusion on it. I hope you understood it why. Similarly, the second case, if the line lies in the plane, what if the line lies in the plane? Before I discuss this, let me make you understand the third case as well before we discuss the second case. Let's say there is this plane, and the line is perpendicular to the plane. So this is the normal to the plane, and this is the line which is perpendicular to the plane. So if line is perpendicular to the plane, do you not think that line will be parallel to the normal to the plane? So the direction ratios of normal, which are A, B, and C, and the direction ratios of the line, which are L, M, and N, they'll be proportional, which means A upon L will be equal to B upon M will be equal to C upon N. Do you realize this? Condition for perpendicularity, condition for parallelism. We have been discussing it. Third case, if I want to check whether a line lies in a plane or not. So if I wish to verify that, let's say I wish to verify that there is a plane, and I wish to check whether a line lies in this plane or not. So what I know is that line has its own equation, x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. What does it mean? It means that there will be a point lying on the line which is x1, y1 and z1. Do you agree with me on this? Now, the plane's equation, let's say, is given by ax plus by plus cz plus d is equal to 0. This is the equation of the plane. I hope there is no confusion on it. Now, first of all, will you not agree that if line lies in the plane, the point which lies on the line must lie in the plane also? So first condition will be that this coordinate must satisfy the equation of the plane. So first check will be ax1 plus by1 plus cz1 plus d will be 0. That is your first condition if the line lies in the plane. Second condition, do you not agree or would you not agree that if line lies in the plane, then the normal to the plane will be perpendicular to the line as well, because the line lies in the plane. So if there is a normal, there is a vector which is perpendicular to the plane, to the entire plane, to the whole plane, then it will be perpendicular to any line lying in the plane, which means the normal vector, which is ABC, will be perpendicular. I'm really sorry, there also I have taken ABC. So here I should have taken, let's say, L, M and N. So let's say the line had L, M and N. They will have their dot product to be 0, which means AL plus BM plus CN will be 0. So if these two conditions are met, which is exactly what we have written or given over here, then I'll be in a position to say that the line lies in the plane. More important than this formula was the algorithm. Were you able to understand the whole approach? Are you able to understand what I'm trying to make you understand through these theoretical explanations? Will you be able to apply these explanations in the questions if asked? Now, a line will be in a plane, these two conditions as we have already discussed. Now let's move ahead towards the next part. Coplanarity of two lines. So two lines will be coplanar, which means two lines will lie in the same plane. When does that happen? So there is a straight line, there is a plane, right? And this is what we have discussed, that the line will lie in the plane if this is the condition which is satisfies, that any point lying on the line must satisfy equation of the plane, because that point will also lie in the plane, and the line and the normal to the plane will be perpendicular, because normal is perpendicular to the plane. Then the normal will be perpendicular to the line as well, because the line lies in the plane. I hope you're understanding this result. Now, with this, let's move to the next part. This is what we have already understood and explained. This part where I need to find image of a point in a plane. So let's say the plane is behaving as a mirror and I need to find the image of point P in this plane. So can I not use something which we have already learnt, that do you remember I can find the coordinates of L? Previously here only we have understood and learnt that if I were to find that if this line has its feet or image in a plane, then we can find it through a very simple method. That same method is what I'll be suggesting or extending here in this concept when I'm asked to find the feet or the mirror image. The concept is very simple here. We have the plane ax plus by plus cz plus d is equal to 0, and we have the point alpha, beta, gamma, right? Now, I need to find the feet of alpha, beta, gamma, which is L, and also I need to find the image of alpha, beta, gamma in this plane, which is, let's say, x1, y1, z1. Do you remember in 2D we have developed a formula? That same formula will be used here first of all. So even if I don't explain the whole algorithm, which I will, don't worry about that, can I take that formula into picture and use it? So here, instead of algorithm, I am suggesting that you remember this formula. Which formula? The formula which is used in finding the feet or the mirror image of a point in a plane. Are you understanding my statement here? How? The formula is what I'll give you along with the algorithm. So the formula says, I'll talk about the formula first, then I'll talk about the algorithm. I'll talk about the formula here. So the formula is this here. This is what is going to help you with the formula. What is the formula? Let me derive that formula here. But before we come to the formula, let me explain the algorithm. See, I need to find the coordinates of L. So to find the coordinates of L, what I know? I know a lot of things. Equation of plane, normal to the plane, equation of line. If I could find the direction ratios of PL, I can do a lot because I know the normal to the plane. How? Let's talk about that. Lately, what we are discussing in this part of this video, recent part of this video, all these topics are either reduced or not very frequently asked. But yes, they can be asked, questions can be formed from these as well. But even if they are not asked directly, or if the syllabus is even reduced from these chapters like 3D, these concepts when used could help you a lot in solving some questions directly. So some question can be done with what you already know with that limited syllabus you are provided. But let's say if you know something additional, if you know something extra, and if that can help you in being more effective or efficient, then why should you not have it? So that's exactly in the latter part of this video, in this recent part of this video, where we have been discussing a lot of theory. So a lot of things are either reduced or removed from your syllabus. But yes, it plays a crucial part. It is a vital portion of your syllabus, and you should have these things in your mind, because if you remember these concepts, your chances of solving questions increase. Basically, you get more clarity, you get more, a better view, better observation, better conceptual understanding. So your chances of solving a question get increased. So that's why we are discussing these some extra concepts which are there in your chapter. Now let's just look at this final part of this chapter, which is what when you asked to deal with the image of a point in a plane. So yes, we have discussed that this is something which you have studied in 2D as well. This is exactly what we'll be extending here as well. But now let us understand the algorithm, then we'll talk about the formula. Through algorithm, of course, we'll discuss the formula. So here, what is the algorithm? The algorithm is pretty simple, students. What I know is that this L and this Q are needed to be found. What I'm trying to make you understand is, let's work on L, because once L is found, Q can be found. Why? Because L is feet of P and Q is the image of P. So if L is the feet of P, L is the midpoint of PQ. So if I know P, if I know L, will I not be able to find Q? I can, right? So point is simple. Let's work on finding L. How do I find L? The approach remains same. The approach remains simple. This approach we have also discussed a lot many times. Again, I'll be covering that same portion, but through this perspective. Now plane has come into picture. How do we deal with this? See, we have a plane. This is the plane, right? Ax plus by plus cz plus d, that's your plane. We have this point P, whose mirror image and whose feet is what we are trying to find or work upon. Now, what we know is that Q, let's say, is the image of this point P. So x1, y1, z1 is the image of this point P in this plane. Now, what I know is that PQ meet the plane. PQ, this line meets the plane at L. So PQ has a midpoint, which is L. And this L is the point of intersection of this line PQ with the plane. So I hope something is there in your mind when I talk or say or mention the term that the line is intersecting the plane. Do you remember something we have discussed? So this is what is the advantage of knowing more. So the more knowledge you have, the chances are higher that you can use these knowledge in those basic questions and get the answers more quickly. So better understanding you have, the better clarity you have, the better you will be able to solve those questions, right, students? So here we know that this PQ is intersecting the plane at L, right? So what I know is direction ratios of normal to the plane are ABC. Why am I saying this? Because we know this. The plane is there. Can I not say that PQ will also be perpendicular to the plane? And if PQ is perpendicular to the plane and plane has a normal which has the direction ratios as ABC, which we already know, then this line PQ will also have the direction ratios as A, B and C. Do you agree with this? With me? Now, if I know the direction ratios of the line PQ which passes through L, which lies on the plane, then this equations line can be given by x minus alpha upon a, x minus beta upon b, y minus beta upon b, z minus gamma upon c. Because alpha, beta, gamma are the coordinates of P, the point through which the line PQ passes. And A, B, C are the direction ratios of the line because it is parallel to the normal of the plane. I hope you are understanding this very clearly, because the line is perpendicular to the plane, right? Now, with that, if I find any point, if I try to find the coordinates of any point parametrically on the line, then I hope if I put it equal to r, it will be given by AR plus alpha Br plus beta and Cr plus gamma. Do you all agree with this on me? So here, let's say there is a point on the line which has the coordinates Ar plus alpha, Br plus beta and Cr plus gamma. Then I know P, I know Q. So can I find the midpoint of PQ? I can. I repeat, I know the coordinates of P, alpha, beta, gamma. I have the coordinates of Q, which are there in the parametric form where R is a variable for me so far. So I know the coordinates of P, I know the coordinates of Q. P and Q if I'm aware of. Now I know the coordinates of P and Q. So if I know the coordinates of P, I have cracked the coordinates of Q, although in the parametric form. Can I not find the midpoint of PQ, which is L? I repeat, the midpoint of PQ, which is L, which is the feet of this point P on this plane here. Now, if this point L is the midpoint of PQ, then yes, we have the coordinates of L, midpoint theorem, section formula, you can use that. If I have the coordinates of L, although in the parametric form where R is the variable, then this point L has its own beauty that it lies on the plane. The point L lies on the plane. Then would you not agree that L must satisfy equation of the plane? Because on the plane, the point L lies. So L's coordinate will satisfy the equation of the plane. So the coordinates of L, which we have found here, then I'll pass it to the equation of the plane. And once the coordinates are passed to the equation of the plane, I will finally now be able to find the value of the parameter R. Now, if you are able to relate this R, do you not agree that this is something you have already seen? This is something which you have already seen, because if I make you recall something which you have studied in 2D, then this is what you have studied. Let's say there is a point x1 comma y1. There is a line ax plus by plus c is equal to 0, and this point has a mirror image. Let's say the mirror image is given by alpha comma beta. Then do we remember a formula to find alpha comma beta? I hope you must be able to recall something which we have studied as, see, alpha minus x1 upon a is equal to beta minus y1 upon b is equal to, if it is the mirror image, we use minus 2 times power of this point with respect to this line, which is ax1 plus by1 plus c divided by a square plus b square. Do you remember it? And if it is the feet of this point x1 comma y1 on this line, then we use minus 1 here instead of minus 2. So if it is the feet, minus 1 is used. If it is the mirror image, minus 2 is used. This is the formula which we study in 2D. Now, if you look this same formula in 3D, you will say the same thing is being used. I hope you can see it very clearly here, that this minus 2 times, I hope you can see this relation here, minus 2 times A alpha plus B beta plus C gamma plus D. What is it? Power of alpha beta gamma with respect to the plane. I hope you can see ax plus by plus cz plus d, which is the plane. Alpha beta gamma were the coordinates of the point. So I hope you can see the power. In the denominator, what do we have? A square plus b square in 2D. So in 3D, we'll have a square plus b square plus c square. Are you getting this result? And once you crack the value of r, by having this value of r placed over here, you can have the coordinates of q or L depending on what you are trying to find out, either feet or the mirror image. I am repeating my words very clearly here, students, that the latter part of this video, whatever we have been discussing here in this video, that this part contained majorly those topics which are either reduced or removed. So yes, I have still tried giving you the clarity on these topics because they can be used. And if they are learned or remembered by you, they will help you in being more efficient and being more effective. That's exactly our intent was. So I hope you have understood that 3D, we have tried giving you a complete clarity on through this one shot video, a complete comprehensive coverage we have tried giving you with a lot of course, theorems, short techniques, formulae, cases. And through this, we are imagining or assuming that you are taking notes of everything. You are maintaining a pattern book where you are understanding that if this case arises, this is what it is needed to be done, and all sorts of different formulae and approaches you have there in your mind. Along with this, even if you're maintaining, we are also providing these PDF notes to you. Along with this, DPPs are also given to you through which you can practice the questions, through which you can consolidate all these learnings. It is all available on our application, PW app, the amazing platform from where millions of students are preparing for different competitive exams and getting desired results. So yes, link is given in the description. You can click on it and it will redirect you to our app. I think this is all for the day. Let us call it a day. Thank you so much. You have been a great audience.